Hello, my name is Scott Fratcher, and I was captain of Aphrodite for 14 months, and we put about 10,000 miles on the boat during that time. And I'm doing a quick turnover video here, so this is the introduction to the turnover video. And this video is really set up for the new crew that's going to be taking over Aphrodite sometime in the future, and it's to give you a quick rundown on the systems and what we learned about the boat and how to transfer that information over to somebody else who isn't actually on the boat yet. So one thing I want to tell you right off the bat is Aphrodite is an awesome sailing boat. And one of the things you'll see here is we're sailing along right now in 30-35 knots of wind. That's what should be in the background. And notice the horizon, where the boat's not taking any deep rolls. She's just sitting there. What do we have? A deeply reefed main, and we probably have the staysail up. I couldn't see right there. 30 knots of apparent wind, and we're broad reaching, so we probably have 35 knots or maybe a little bit more of true wind. And the boat is sitting there at 9.6, 9.8, just hit a 10.3 and 10.5, and she's just barreling along and without much drama. So I kind of want to point that out. I put this up here just kind of so you can see the boat under full performance there, I guess. I don't know if that's the right term or not, but anyway, you can see it's blowing and you can see the boat's performing well. So I put that out there so that you have a little taste of what she does when the wind's blowing a little bit. One thing I also want to apologize for is all the ums and ahs and everything else that you'll be hearing in the video. I did the video, a lot of it I was doing the camera myself and thinking about what I wanted to say and walking around and in the middle of moving off the boat with all these people talking to me. So there was a lot during that time that was going on, and I just kind of want to put that out there, that I'm sorry about all the pauses and that was taking place. And we do some of these turnover videos professionally, and so this isn't our normal quality. But on the other hand, we did get the information passed, and that's probably what really counts in this instance. It looks like we're going to be coming into anchor there, 10.7 on the knot meter. You just got to like that 27 knots of wind from behind. So, and we're doing 10.7, and we're broad reaching, so 37, 35, something like that is probably the true wind speed. And now you'll see us, we're going down below, and you can see what it's like for the people down below. Same conditions. I just walked down below with the camera still rolling, and you can see the crew's not getting knocked around. Everybody's just kind of hanging out, and so I mean, it's an amazingly comfortable boat when when she's sailing. There's Elizabeth there. Hello, Elizabeth, and she looks like she's pretty comfortable also. Nothing's flying off the shelves. And you can see we're kind of loaded. There's some fruits down there. We're just getting ready to or I guess we are departing here for an Atlantic crossing. And so oh, and here's Elizabeth. She's doing a yoga tree pose to show us the ability to balance. This is because we did a video a while back on a big cat that we were on, and we were doing the tree pose while we were sailing along at 10 knots. So she's showing that you can do the tree pose on a monohull at 10 knots also, which and there it is. I think I just saw 10.2, 10.1, 9.9. So I mean, obviously the boat's moving right along here. And so with that, I'm going to start turning over for giving you the Aphrodite turnover video, and I hope it helps you a little bit. And I don't know how the sound quality is going to be. Good luck and take care. All right, here's one more. Okay, this is what are we doing here? This is, we're obviously sailing along, and so we've got the pole out. That pole is probably pushed out past center, so the wind's probably going to be coming over a little bit on our starboard side. Oh, look at it, we got the staysail out too, so it'll be interesting to see what type of speed we're doing right here. Looks like nice trade wind conditions right there. 4 peaks, 4 lockers open, so we might be getting ready to pull out some other sails or something. Normally those are closed up. And skiff on deck. That's the way we normally left the skiff when we were doing ocean sailing. put the life raft and everything in there, so we had a kind of like a last ditch escape possibility. So we got the staysail and the jib wing on wing. The jib is going to be pushed out just a little bit past what would be wind dead downwind for a guy after guy topping lift and sheet line on that jib. And I keep pointing this out, that the wind's going to be coming over the starboard stern, because we found that really kicks her into gear. I don't quite know why it does that on this boat, but instead of going straight downwind, we'll run that wind a little bit over the weather side of this, what would normally be the lee side of the jib, but in this case it's the weather side, because and the boat just for some reason just really takes off in such conditions. So you can also see that our one of our guys is led to the deck winch there, the windlass. Oh, and look at that bow wake, man! We are just cooking. I wonder how fast we're going here. I'm going to guess we're doing 9 or 10 knots, something like that. And she seems like, and it's quite quiet too. I think you still have the audio in the background for this particular video right here, and it's not making a bunch of noise, and you can hear she's not creaking and groaning. And also, if you look at the horizon behind us, you'll see that that it's not really rolling around. I mean, it's such a stable boat. She was just an amazing boat. We're moving to a big cat, and I just kind of forgotten when we went. We had to take the big cat to Africa to do the transfer. So we took it from the Balearics to Africa, Algeria, and then back to the Balearics. And the captain at the time, he was going over all the weather charts and looking and trying to pick his day. And I was like, at the time I was looking, and we had been on Aphrodite for 14 months. I see how the staysail's sheeted in really tight right there. That's that isn't so much to catch wind as to direct the wind, catch that wind that's rolling off the front of the main is what we're doing there. And you can see we've also set up a second line to the end of the main boom. So that was another little trick there. Anyway, they were checking the weather and scratching their heads and really deciding when this 90-foot cat was going to go from the Balearics to Algeria and back. And it was a 48-hour run. And it just kind of made me remember how on Aphrodite you'll check the weather and everything, but like it just didn't matter that much. If it was blowing 20, it was great, man. We got some power. Throw up the sails and she'll take off, and really, if it was blowing 30, you might get knocked around a little bit, but it wasn't any really big deal. So I just point that out as compared to other boats that we've been on. I mean, you just keep watching that horizon back there. We're just cutting a wake and sailing right along, moving along towards our final destination here. And I don't know what I'm sure we're going to make a 200-mile day here. We always seem to make 200-mile days on that boat. So anyway, I just wanted to kind of point this out, and so it kind of starts your idea of what Aphrodite is capable of. You notice we're missing that forward derail. That's been missing since we got on also, and it would be nice to get that. It would start circulating some air in that forepeak, and that would probably make that forepeak a little less musty and moldy. It's kind of a dank area of the boat that we were never really totally happy with. Yeah, awesome boat, just awesome. And something else you'll notice, we're running downwind here, so we've got seas coming from behind us, and you can see we're coming off a wave right there. Now we're on the face of the wave, coming down the face of the wave, rushing down the face of the wave, and about here we just hit the bottom of the wave. And so, but if you watch the GPS, especially if the speed dampener is off, it's showing the true speed second by second, and the boat doesn't really change speed, and this is really important for crew comfort. She just kind of might go from 9.5 to 10.2 back to 9.5, but she's not doing those huge accelerations that oftentimes cause the boat to go from 8 to 12, and that wears out the crew. I mean, it's happening 6 times a minute If you got 10-second wave intervals, which is pretty common, might be 5 times a minute. If you got 12-second wave intervals, something like that. But that tends to wear out the crew. It wears me out anyway. And so I always appreciate that about Aphrodite, is how she really kind of held her speed. I don't know what that red. Oh, that red is a bungee that somebody put up there to for fish catching, and that's on the top of the port mizzen backstay. And then the starboard mizzen backstay, which you see on there, that's the single sideband antenna. And so anyway, oh, here we'll get a chance to see the speed. I think I see 9 something. Maybe I'll get to zoom in here. I haven't watched this video before, but here we go. 9289. That's our speed. That SOG is speed over ground. Okay, so we're slowing down to 8.2 at the bottom of a wave, and that's going to be our acceleration on the face of the wave. Got up to 8.6. So yeah, 200 mile days. That's about what that would be. Something in that neighborhood. And so we're doing 200 mile days with 11 knots apparent wind, and what were we doing? 8s in there, and that wind, and see how that wind, you can just barely see it on the next the log to the left. I just saw it, and the wind is indeed coming about 10 degrees over our starboard stern. So so we got 20 knots from behind us. If you take into account our apparent wind, we're still doing 8.3 there, 8.0. So 200 mile days. The wind's coming just over the starboard stern, and that's I keep pointing that out because you'll want to do that if you got the pole out for that jib. And I guess that's about it. Good luck with the boat. I hope that the turnover video helps you. And other than that, really great time. If you get really stuck, give me an email at yachtwork@gmail.com, yachtwork@gmail.com, and we'll do what we can. And but you shouldn't. I'm covering just about everything here on this particular 8.6 there, 8.5, 8.7. And maybe we were in a little lull there, 8.8. So anyway, we should have turned to 200 that day. I hope my next boat does the same. We're moving on to a 90-foot Katana. And I'm gonna miss that Aphrodite. She was one of the best boats I ever sailed on. I had a lot of people come by and tell me that too. I mean, Aphrodite was a really famous boat, and so I mean, she's got a 20-year history around the Med, and lots of people have sailed on her, and she's a very well-known boat. And I had more people stop off and tell me, "Hey, I knew Aphrodite. That was the best boat I ever sailed on." I mean, I had more people say those exact words than I think I've ever heard anything else. I mean, it was just the number of people that told me that, and it was true for me too. That's she was easily the best boat that I've ever sailed on. You were just comfortable and quick and constantly made the miles. Hoke really got it right. Yeah, Hoke really got it right with that one. He and that was one of his first big designs too. So so it was good, you know. I mean, oftentimes I hear people say, "Yeah, that boat's great," or there's all the sales pitches and everything else that people are doing to sell a boat, and then you get out on them and you find out, I don't know. See that wind coming over the starboard stern on the wind direction there? I keep pointing that out. That's going to be a good trick for you. I hear people say that all the time on boats, but oftentimes that's just sales hype. But on this one, this really was. I mean, the boat just was awesome. And so, I mean, if she had a pilot house, I'll take her anywhere. Without a pilot house, we were kind of keeping her south of 40 north, and on the return trip, just in case I didn't want to get too cold. But that wasn't for boat characteristics. That was more for crew comfort. And if the exact same boat had a pilot house, I'd be just happy to take her back to Alaska. We spent 5 years in Alaska, and I'll take her back there, or do a around the horn run. I think she'll do just fine with that. But I'm just guessing. There's some chafe gear there, a couple points there, trying to protect those lines. Those lines are pretty expensive, so we don't want to have to change them out. Okay, that was about it. Good luck. Hope you enjoy the boat.
have a good angle. We're not going to be into the wind. We're going to be 50 degrees or so.
Go on.
In the net with this wind, the bow of Aphrodite gets into the wave.
Really, just diving into it.
And then you have water inside. You have the top of the water catch.
I've got some plans on those, by the way. We had some pretty good drenchings on the crossing.
Right.
So I've come up with a few ideas.
Shimpo Uchire Kano Soko Genju. Shimpo Uchire Kano Soko Genju. Shimpo Uchire Kano Soko Genju. Yee, yee, yee. Aloha.
Yeah.
All right. Thank you. Chris didn't even hear that. That's right.
Okay, we're going to do a little bit of talk now about driving Aphrodite. And I'm assuming that you already know basically how to drive a boat. So I'm going to give you some tricks here that that we've learned on Aphrodite to help you maneuvering when you come pulling on into the docks, for example. And you can see I've been climbing around here making this making the filming. That's why I'm all sweaty and all. This might be the last episode, so I'm kind of glad that you're here with me still. Okay, so we have a bow thruster, and we have a wheel to the rudder, and then we have prop pitch down here. And so that's, and then fore and aft, forward and reverse on the throttle down there. And that's about it. That's about all that you get for control. And so bow thrust is good, but the big disadvantage, I'll give you the biggest disadvantage of the boat first as far as maneuvering, is that the prop water, the prop thrust, doesn't really go over the rudder shaft. So a lot of those tricks that we get used to when we're driving a boat, like for example, let's say we put the helm to port and then give it a little shot and forward and like rev it up to 1,000 and right back to push the stern to starboard. That trick won't really work with Aphrodite. You might get 10% of what you would get on other boats, and so I just warn you of that right off the bat, because that's the probably the most difficult thing for people to come to grips with when they're driving this boat. Besides that, she's very long and pivots on the keel too. So here's some tricks. If you're coming down a slot, for example, let's say between two boats, and you're backing into Medmore, and you're trying to hold your line, but you don't have room to crab the boat. And so, in holding your line, you're getting pushed off, let's say, to starboard. Let's say you've got wind on the port, and your rig's getting hit with wind on the port, and you're being pushed into the boat to starboard. And but you can't really use your bow thruster to turn the boat to climb off to gain a little altitude to starboard, as some people might call it, because you just don't have room to turn the boat 15-20 degrees because you're between two boats. So one trick that you can do is you can put your helm to port, and you're backing up, so that will cause your stern to get pulled to port. At the same time, you can run your thruster to port and pushing to port. And so therefore what you end up with is the whole boat itself is moving backwards, but she's also moving to port, but holding her parallel. Okay, so that's because the bow is being pushed by the bow thruster, the stern's being pulled by the rudder. Okay, so that's one trick that you can use. You can reverse that when you're coming off of a dock. Let's say that you're on a dock somewhere, and and the wind's coming straight off your port side, and the dock is to starboard. And so and now you want to pull off the dock. And if you just thrusted off, for example, then if you just thrusted your bow off, then you're going to be stern dragging all the way when you're trying to get off the dock. So you can turn your rudder to the dock to starboard. Remember, you got wind to your port, dock to your starboard. Turn your rudder to starboard, which is counterintuitive. Wouldn't you think that the boat would round into the dock? And at the same time, you thrust the bow to port. So you're thrusting the bow to port, and you've turned your rudder to starboard, and then you start to motor forward. And what will happen is that the bow, you let the bow thrust come off just a little bit, then you start motoring forward. The stern gets pushed away from the dock because the rudder is turned towards the dock. The bow gets pushed away from the dock because the thruster is pushing off the dock. And in effect, what happens is the boat moves forward and sideways to port, pushing you off the dock the whole time. So in effect, you move sideways off the dock like this. So it's a form of walking the boat sideways away from the dock, without having to go through all these tricks of lines and spring lines and all that. And people appreciate this when you're stopping, you're picking up people, you're throwing all the gear on board, and you just motor away without all of this drama. Let's say putting a spring line, now you're going to back down on the spring line and push the bow off. That would be tricks that people would normally tend to use. So, okay, so we've got bow thruster and rudder towards the obstruction at the same time to walk the boat sideways. You can do that forward and aft. Another trick that's really handy to know is you can reverse the pitch on the rudder on the prop. Under normal circumstances, you put the boat in reverse, she backs to port. So therefore you try to dock primarily with port side to the dock. But oftentimes you come into a situation where you have to dock starboard side too. So you can come over here to the pitch control and reverse the pitch. Then on your throttles, reverse becomes forward, forward becomes reverse. So now when you put her in reverse by putting the throttle in forward, that then allows because the reverse pitch of the prop becomes reverse, the boat now backs to starboard. See, so you can use this for to your advantage. For example, if you're coming into a dock on the starboard side and you really need to have the boat back to starboard, which happens a lot. Like for example, you might have hard wind on the starboard side and have to turn with the and have to make a backing turn with the to pull the stern to starboard. So if you see that ahead of time, and you know that you don't really have the prop thrust, so your other option then is to reverse pitch and then back to starboard. Now you can make a backing turn to starboard and then make a line, hold a line after that to back in between boats. You know, Europe's really tight. If you're around the Caribbean, for example, or maybe the Baltic, you don't have these really tight docking situations that we end up with in the Med. So I'm just kind of pointing these out. Let's see, what else can you do? Another trick is you can come to a stop and thrust the bow, and while you're thrusting the bow, while the boat stops, she'll spin on her keel. So you can, like for example, you can pull out into an area that's quite tight, and you can do a 180 and take off the other direction, and she'll just pivot around on her keel, and that's a nice little trick. Another thing that sometimes happens is you'll be kind of drifting somewhere, and like let's say that you're coming into dock, so you're already between a row of docks and a row of docks, and you've come down the center, and now you realize that somebody has to pull out, so you're just kind of holding position. And while you're holding position, you may find that the wind is on one side of the boat, and eventually the wind will stay on the side of the boat enough that you'll start to get a flow of water around the keel. And at that point, suddenly the boat that has been very stable in the water will be just sliding to, let's say the wind's on your port, will suddenly be sliding to starboard, and you'll realize that you're getting pinched to your starboard side. One trick that you can do is quickly motor forward about a half a boat length, and that'll cause the keel to grab fresh water and stop your sideways motion. So now you're into clean water again. The keel's into clean water. So that's a kind of like another trick that we use sometimes. I'm just thinking if there's anything else in here that well, that's pretty much it. Reverse the pitch of the prop. Jump the boat forward or aft to get the keel into clean water if you find that you're sliding sideways. Use the bow thruster and put your keel towards the obstruction to and one last one I'll go over is the process for med mooring, because we end up med mooring a lot. You may end up doing it on anchor. In that case, you've got 100 meters of chain. You may end up doing it on with bow lines off the provided by the marina. So you come in, you back in. Inside of these lockers back here, we keep 2 monkey's fists. So you tie off the monkey's fist. We run a line through the corner of the boat and up to these middle winches right here. So now you're attached. You've got a stern line on each side that's attached to the middle winch. Take the weather side. Your first line will almost always be to the dock on the side that the wind is blowing from. So let's say the wind is coming in from port. So you're backing with the rudder and the prop set to back to port. You're backing down the slot between the 2 boats. You get to the dock. You throw your monkey's fist. They put your port stern line onto a bollard or a tie-off point on the dock, and now you can kind of motor forward. You can bounce forward a little bit on that stern line. You can control your distance off the dock because you've got the line on the winch, and then that gives the point where somebody can grab the line off of the dock and start walking the line forward. When I keep an eye when I overthrust, let's say I've got the wind coming from port, I push the bow to port farther than it needs to be, farther than the line of keeping the bow straight down the slipway. Because when whoever it is that's setting up the line that's carrying that bow line forward, and remember that bow line, they're just walking the bow line forward like this, so the bow line is hanging in the water on both sides. When they reach about the point where they're getting to the mainmast, I have to stop thrusting, because what's holding me off of from the bow being blown to starboard from the port wind is my thruster, and it's sucking water from port. and the person who's ever bringing my line up is lifting the line out of the water. So about the time that they get to the mainmast, I have to stop thrusting, because otherwise the thruster is going to try to suck the bow line into the bow prop, and then of course we're out of control and we've got a line on our bow prop, which would be a bad situation. About that time, then I step away from the helm and I toss the starboard stern line, and then the guys on the dock are kind of freed up. So I put on my starboard stern line, and then I've got control again. I can set my 2 stern lines through the winches, and if I need to, I can bump ahead on the motor, and that can catch my bow if my bow is getting blown off because the bow team hasn't gotten the bow line on yet. About that time, then, while I'm still waiting, I come over here to this button right here, and I open the stern door. You see the stern door right there? Okay, I open the stern door, and then I can make my final adjustments, because that gives me kind of perspective of how close we are to the dock, and I can set my stern line. A couple other things that just so that you're aware of. Okay, so these are the monkey's fists right here, and so that's what gets tossed to the dock. We also have that fender, which is kind of like your training wheels. We use that like the first couple months just in case we backed into the dock. You can see people have done it a lot. There's see the fresh paint down there? That's all from before we got here, but I know people have backed into the docks. It's pretty easy to do. You know, there's a lot of boat and you don't get a lot of crew. So if you do it, don't feel too bad. It'll just chip the paint and you can just patch it up. It's just paint. But what you can do the first couple times is you can loop that over that stern point, and one of these goes over one of those cleats down there, then the other one goes to the other cleat, and now you've got this. Now you've got that big fender, so you've got kind of a little bit of bounce if you need it for the and a little bit of security. So so you're not like so stressed out about all this stuff back here. You can just kind of back up, and you know if you ever so gently bump that it's not going to be catastrophic to the boat, and then that's about it. Then I just pretty much have to stay right over here until they get the bow line on, and then once they got one bow line on, then we're set. And so that's pretty much it for the docking.
And you're cruising.
And you're cruising. After that, you're on your way. Disembarking is disembarking from a Medmore is the same thing. Drop your lines that are onto the leeward side, then drop your bow line, and very, very quickly, immediately afterwards, you can drop your stern. If I was pulling out of here right now, look at that flag that's on that boat right up there. Okay, so I've got wind off to my port, and so if I was to pull out of this dock right here, I would drop my starboard bow line, then I would drop my starboard stern line. Okay. Then I would use my thruster. I would thrust the bow off the port farther than it is right now, so that I'm out. So now I'm over the line. I'll drop my port bow line. As soon as I drop my port bow line, we'll drift back just a little bit. Then the guy back here can drop my port stern line, reel that in, and then I would turn my rudder to starboard, because I'm going to be getting blown onto this boat here. I would thrust the bow to port. I would reach down and put her at idle ahead, and then I would watch and make sure I'm holding my line. And as soon as I start to climb off the boat to starboard, I would straighten out my rudder, release the thruster, and drive away.
Is that it?
That's it. Good luck. Hello. Okay, so we're in the Aphrodite. Hello. We're in the Aphrodite bow section. So if you've been following these videos, you know this is a turnover video, and these are sections that we're doing, trying to explain the boat, so that the next person who comes along doesn't have to figure everything out. So I'm going to try to just explain the components in this bow locker. The bow locker is totally empty right now, and that's because we pulled everything off so that during the sale of the boat, now we're putting everything back on. And so while the bow locker is empty, we're going to use this opportunity to kind of give a demonstration of what is in the bow locker and how you go about using it. So the first thing is, this is the base of the windlass right here. I think this has a super small oil drip right down there, you can kind of see. And the windlass is hydraulically activated. The power pack is in the starboard lazarette, and it's a 5 kW. And if you're climbing a 5 kW electric motor that runs a hydraulic power pack inside the Lumar tank. So what that means to you is if you climbed down the stairs in the starboard lazarette in the aft cockpit and looked at the Lumar power pack, this windlass runs off of what, if you're facing that power pack, would be the left-hand motor. If you kind of looked at the little cases here, we've got a case here, we've got a case there, then we've got a case here. This case is the motor. This is what actually turns and provides the torque through these two hydraulic lines right here, left and right. Forward and reverse are just a switching valve that's backed by the mast, underneath the mast, just aft of the mast. This little section right here, we never have to deal with, but that's a brake. So there's a little, what would look like a little pack of clutches in here, and held closed with a set of springs. And then when we try to send pressure either forward or reverse, then this line here gets pressure, releases the clutch, and allows the motor to turn the windlass. So if you ever try to turn the windlass and it doesn't, it just sits there and sounds like it's grinding, well, maybe the brake's on, which we'll talk about later when we talk about the windlass, or maybe this clutch pack is frozen. Never been a problem for us, but I've dealt with a lot of hydraulics and that can be a problem. Also, sometimes if you're loading up the windlass really hard and you don't have the chain stopper on, you know, like you're in the middle of deploying the anchor or something, and it gets a heap of load on it, then you'll hear sometimes it'll pay out and it'll backspin like a half a meter of chain or something. This up here is just going to be, I'm assuming, I've never opened it, I think this is going to be a planetary reduction, a bunch of little gears, maybe 4 little gears on the outside with a center shaft that's providing the torque, and that's what provides the reduction so that the windlass spins at the right speed, which is about 60 RPM. Okay, this right here you shouldn't really ever see any movement up here. Occasionally when you're down here and you see a lot of pull going on, you'll see like a little bit of flex up in here, and that's the most we have ever seen. We put this remote in, and okay, so the reason behind this remote is we get to the chain locker here, and while the chain's coming in, somebody has to be down here flaking it. So they're grabbing this chain as it comes down and flaking it in this section back and forth, and then this way. And if one person has to do it, then the one person can be standing here with a remote, and they don't have to be up on deck. And this is really where the action is. And once you get used to the system, then you'll see it's more happening down here than it is up on deck. It's a great anchoring system, absolutely just hands-free, no touch except for the flaking of the chain. This here is a tie bar. That is a way that tension is passed from the deck, which in this case is a staysail. The staysail tension comes down back into the hull right there. And very simple stuff. This is a drain. This right here is a drain. And also a drain down this side. This drain here goes into a pipe that goes bow to stern and drains into a few through hulls. So all the hatches drain into this same pipe. And this is actually kind of worth noting how all of these hoses drain, because every hatch has a set of hoses like this that drain. So if you come along and you find that this gutter on one of the hatches is full of water, then probably this hose has clogged, and sometimes you can get on it with a garden hose and just push a garden hose right into the top of the hose. Sometimes people use the low pressure side of a scuba tank and blow out the clog. This is a header tank right here for the thruster. The thruster is right back there just after this bulkhead, and this is a watertight bulkhead that we'll talk about in a second. And so this is a header tank that provides a positive pressure for the gearbox that lowers and raises the thruster. So it's got a sight tube on it. It always sits about half. If you notice that it's starting to move or starting to change, you can put some, I'm assuming it's HD 30. I've never actually had to add to it, and we've been on for about 15 months now. And that level has never changed, but keep an eye on it, because if it does change, eventually the oil level will get down enough that water can intrude into the gearbox, and we've got 2 washdown hoses, or 2 washdown pipes. This one here, the galvanized one, is the fire system, and the fire pump is in the galley right by the engine room door, under the floor forward of the engine room door. Is your hand shaking? You tell me if you're shaking there, because you can always stabilize that camera, otherwise the guy on the other end will get sick, see? And see, I'm protecting you, the viewer. Okay, so the other tube coming is this small one right here, and this small one is fresh water. And that fresh water, through a valve right here, and then another valve up on deck has a hose bib just forward of the anchor windlass. And so you can choose to whether or not to use, whether or not you can turn on the fire pump and pump seawater into the fire pump to wash down the anchor, which is not a bad way to keep that whole system fresh, although we never do it because we never anchor where there's mud, so we never really end up having to wash down the anchor chain. But if you did wash down the anchor chain, your other option is fresh water, which of course is better for the preservation of the anchor chain. There's one more tube here. This is a big plastic hose, and I mean a big plastic pipe, and I'm guessing it was a drain of some kind. It's been disconnected since I've been on, and there's the other end. It's just disconnected up there, so I don't know what that does. Okay, these two hoses, these three hoses we've already spoken about. Those are the high pressure hoses and the clutch brake release for the windlass. These two hoses are the roller furling, and the headstay roller furling, and of course left and right. This drain here drains aft along with the bilge of this area. Now this is a watertight section. And what you see here for the peeling paint and all that, that's probably the worst of the whole boat. And that's because we're always throwing wet gear in here. And this right here, which is the vent for the outside, is missing the cowl, the Dorade vent. And it's the only one that's missing. It's been missing since we got on. So we leave this hatch open anytime we can to keep the fresh air flowing in here. But if we miss that, or we're like, crossing an ocean or something, then this area might get a little bit moist. So I'll replace that. Rondal has two more left, and they have to be specially made. So if you don't get it, then I don't know where you'll find them. I see that these guys right here are just kind of left over from. Left over from the unload and didn't get moved. So these two pipes right here, I'm just going to point those out. They're the for the boarding ladder off the stern. Nobody ever uses them because it makes the boarding ladder too narrow. But if you did, this ladder right here hangs off of the starboard side or the port side right amidships. And if you're trying to board, there's a ladder all the way aft that stores up here, that's out on deck, and it's a ladder that goes on the aft hatch that opens up the aft gangway, and that's how we would normally board and bring a dinghy up there. But if it was really rough, for example, and the boat was pitching, and you were still trying to get somebody safely aboard, then you can put this ladder out on either side. You can also use it for people have in the past used it for boarding people out of the water, kind of as a swimming ladder. But now we've got a much better. We've got an aluminum. It's very light. And but if not, that's what that ladder's for. I think that is getting. Oh, okay. The bilge we wanted to talk about, and the spare anchor. This spare anchor, it's all locked in here. We've never needed it, and but it's there. There's also a fortress, a huge fortress. It sits right over here. The fortress is missing a piece. It's missing the little swivel piece. Now we've ordered that, and it should be sitting in Mahone. It's been missing since we got on the boat, but we found where we could order one. We ordered it from the States. Had this whole ordeal to get it through Spanish customs. It's through customs. It's sitting in Mahone at the marina. But we're not at that marina, but I tell you where it is so that if it hasn't made it on board, you might be able to track it down. The bilge of this area, this is a watertight section, so anything that builds up in this area doesn't get pumped. It stays right in this area. So that's kind of your warning. And there's a bilge sensor down here somewhere that sets off an alarm just aft of the navigation station at the alarm panel if this area is filling up. If you went to the other side of this bulkhead, what you'll see is that there's a tube welded through the bulkhead, and what comes out the other side is a little pipe nipple with an 1.5-inch white hose on it. That 1.5-inch white hose snakes around and ends up in the port forward cabin at the very, very, very forward floorboard. If you lift up that floorboard, you'll look under there, and there's a two-way valve, a left and a right. And one side just drains right into the bilge. And oftentimes we leave it like that if we're just kind of in port. But if we're not in port, then we set that so that we set that valve closed so it's feeding into the next hose. And what that does is that means if we start to collect water up here, it'll set off the alarm, and we'll get notice we'll get told about it, so we can take action early rather than waiting till the main bilge alarm goes off, and then, of course, well, we could have a problem brewing at that point. So, this bilge drains through a hose, through the bulkhead nipple, through a white hose, into the front of the port crew quarter. Underneath the floor there's a two-way valve. One drains into the bilge, one then cycles around to another two-way valve that then selects between the gray water tank. I think it's a gray water, it could be black water, it could be gray, it could be black, but it's one of the two forward pumps for gray or black water, and then you've got a selector valve there that you can then pump this area straight away from the gray water pump or the black water pump forward. And you'll see every pump on the boat we put a Y valve on, so you can either pump a bilge or you can go back to its original application. So okay, so we've covered the bilge, bulkhead. Just looking to see if there's anything else. I think that's about it. Everything else by now should be pretty self-explanatory. There's a light right here, 220 outlet that most of the time we pump the air pump or plug the air pump into for blowing up the fenders. And so we kind of plug in right here, lay the pump out on deck, then we can inflate all the fenders and get ready for docking. Okay, I think that's about it. So hopefully you can follow all that. So we've already talked about the systems in the forward section. And so now we've packed this section. So we had everything unpacked. We let you see all the systems and how everything worked. Now, of course, everything's packed. You can't see the systems, but you can see how we've been packing this forward section, and you can probably see it's pretty packed. But I'm just going to point out what's stored up here, and then, of course, over time you'll develop your own system. But this is what we've come up with. So this black line right here. Actually, we kind of missed on that. Normally, that is stored under the spinnaker that I'll talk about in a minute. So the spinnaker is kind of normally on top, but in this case, somehow it ended up being on top. So this is just a tow line. If we need to, we used to normally tow a 40-foot skiff with Aphrodite. So we had a 40-foot rib that we towed behind us, and this is what we used for the tow lines. Nylon, really soft lay. See, I can get my finger right through there, and so it's stretched and it'd be very springy and probably doesn't have any use on the boat anymore. This is a big spinnaker for the main, and underneath this spinnaker is the mizzen spinnaker. This spinnaker, normally we pack it. See that? So when you come down, you step. You don't step right on top of it. And to get this out, we put a line around it, like a big cinch, and then lift it with a halyard and pull it out. And then once it's out on deck, then it's all inside of a sock with a turtle. So these are the fenders right here for the dinghy. So when the skiff is side tied, you can use these fenders right here. This back up in here is just a deck or a beach umbrella. These are dock lines right here. Some of them, what we've been doing is some of them are quite tore up, like see that right there. And that's because some places, like let's say out in the Azores, there's just so much surge that you can't protect your lines adequately. I mean, we try, and we're constantly putting chafe guard on, but it just wears through. So we use these lines when we're in surgy areas, and then just kind of do the best we can with them. And then when we're not in surgy areas, then we use the other lines that are in better condition. Okay, this right here.
Coffee?
Oh, all right.
Black with sugar and
coffee. Hey, thank you.
You could pump up those fenders. That'd be nice.
Yes, we'll pump up the fenders. We're going to get to that. And, okay, so these lines here, there'll be two of these, and that isn't one of them. I'll get back to that one. These lines here are Delrin. No, not Delrin, but Dyneema. Thanks, Dyneema. Dyneema lines, and these really protect these. These are what we use for pulling halyards out of the mast and putting new halyards in. And so that right there is a Dyneema splice. Make sure you use a Dyneema splice and not this one, which is just the core or the cover folded over onto itself. So if you use that, of course, it'll just pull out and you lose your halyard in your mast, and you'll be You'll be talking to the riggers probably. If you ever do lose a halyard in the mast, the trick is, by the way, you take a tagline with a little length of bicycle chain, and that's what you try to drop down. That's what we used to do in the rigging shops anyway. We'll drop these little pieces of bicycle chain on a very small tagline, and hopefully that makes it all the way to the bottom of the mast, and then hopefully it's on the right side of your spreaders and all the rest of that. So this right here gets tied off to to a halyard. In fact, I might as well just cover that procedure real quick, right? You'd keep the sail that you're trying to take down, you'd keep it rolled up. If you couldn't roll it up, then you have to put a tagline on it, a rolling hitch around, and run the line to a winch. But if the sail's still rolled up, you can just release the halyard piston from the aft port cockpit, and then the piston that's pulling the halyard down will expand and go slack. Then you can pull the pin, put a lashing from this piece of Dyneema line to the eye of the halyard, and now you've got the two lines connected. And then the rest of this goes down to a winch, and now you can control a sail raising and lowering just in kind of a standard procedure. After that, it's all kind of a no-brainer. Let's see, this black line right here, I was planning on making new lines for all the fenders, and so that's as far as we got with that, but that's just a brand new chunk of line. This one here is the other, the mizzen line for halyards, and this is the main for halyards. So kind of, you'll see these things are ridiculously expensive, so just identify those and keep everybody from using them to tie down deck loads and stuff, so that you keep those. These are just spare halyards over here, spare halyard. Nothing about those that this is a rigging chair right here. This is the rigging chair that we normally use. It's a big, healthy aluminum. This is another little rigging chair, and this one's more of a spider chair, you know. So like if two of you were working up the rig together, and one of you was doing the main thing, and another one was working out, like trying to get to, let's say, the leach or something, and there were two of you up the aloft at the same time, then this is the small chair. There's a third chair around too, which is just a climbing harness. So it just goes around your waist and legs. I'm not sure where that ended up, but it's someplace in here. This is a huge fender, and if it was inflated, it would certainly fill most of. Well, this is how wide it is. It unrolls, and it's down. I'm on the bottom of it now, so it's from there up to there, wide, and then it unrolls. And hopefully you won't need that, but if so, it's the perfect thing to have around. Okay, under this main spinnaker is a mizzen spinnaker. Under the mizzen spinnaker are two lines for towing the boat, should you ever need a tow or any other big emergency like that. There's two long lines under there that are maybe 1.25 inches, 1.5 inches, multi-braid. That's good stuff to just know that it's there. This is the fire hose right here. It's got these quick twist ends that connect up to the rest of the fire system. And there's a fire outlet up here by the anchor windlass, and there's another fire outlet back in the middle cockpit to the starboard side of the hatch, and there's a little stainless cover that flips up, and either of those will fit this connection, and that starts your fire procedure. This is a big Fortress anchor right here. It's a what do they call, a 123 or something, FX 123, and it's probably the biggest Fortress that they make, or at least made at that time. Up in this corner up here are a couple battens, long battens. Those were put into the mainsail. Originally, I don't know why, somebody made this mainsail with battens, and of course that didn't work because you just can't fit all those battens inside the mast, and somehow somebody didn't realize that, and those are the battens left over from that project that didn't work. And nice to have some long battens around if you ever need them. Those are also the children netting are just up there also. And if you don't want children netting, this is all brand new. I mean, we only put this on just for the last few trips, and so this is all brand new. I see it's all frayed on the end, but so there's probably 250 meters of this line, and then because it goes top and bottom on the net goes 3/4 of the way up the boat. Okay, now we're gonna. Oh, and this hose right here, this clips on up there. That's for the deck washdown, the anchor washdown. I'm sorry. And then there is someplace around up in here. There's another yellow coil up in this corner up here, and so you can use either of them. See how that one's got the spray pistol, and we normally keep some of the deck washdown. There's another spray pistol right there. We keep the deck washdown stuff kind of in this little neighborhood right there. Okay, if we look forward now, so
one sec.
okay. Okay, so now I'm going to come up here. We normally leave this little area. Very well done. Okay, so my right foot is kind of down in this hole. That hole down there has kind of like a little bit of a black bag with some chain in it, and that's the second anchor chain. So, and there's only about like 4 or 5 meters there. It's just enough to put on to the end of this or that big CQR that you were able to see when we could see it. Okay, I'm just going to close this. If you're going to see long term, you'd close this. When you're just running around port, we tend to leave it open. This is a little trolley just for carrying boxes and stuff back from the market. This big white deal here, this is the ladder. This is the aft boarding ladder. You come out, and once you take it apart, you'll see it. It all slides together with little pins right here. So this is for boarding the aft over the aft of the boat. It's really a good design. It's kind of a little funky when you're using it, like putting it together and taking it apart. And it stores kind of like laid over the forward. It stores between the mainmast and the baby stay with the fat end aft, and the end that goes in the water will be laying over the forward rods. And so that's kind of like a little I don't know about that when it's out on deck, but you'll see when people go to climb out of the water, it's really convenient. So it's it's one of those two-bladed swords. Up there, those 3 coils of white are old running backstays. And we keep those in case we ever lost a piece of rigging. Those are 15-ton lines. So if you had to make up an emergency repair of some kind with a piece of broken rigging, then that would you'd have a fighting chance with those, which is why we kind of keep them around. And God forbid, should you ever have to go through that, but if so, that's kind of one of your options. There's just a bag of some spare pieces here, and I think that's about it for. These I don't know if I mentioned those. These are the fenders for the dinghy. So when you're side tying the dinghy, that's where you go. And other than that, I think that's about the gear in this locker. So what we're going to talk about here is the Aphrodite electrical panel, and I'm just going to give you a little run around here. So it's really the navigation station. So I'm just going to try to give you a rundown of the nav station, and this is kind of a turnover idea here. So we got B&G instruments. Obviously this one here, it looks like the backlight did it. Yeah, backlight light bulb must be burned out, and so you can set these typical B&G stuff. You can set it for anything you want. There's a speed and depth. It'll give you wind or navigation, a little bit of navigation readout. You can run those however you want. Not much to really say about those. A couple VHF handhelds. There's another VHF handheld under the bottom. This one here is mounted down, so you can grab your VHF anytime you want. These don't have much to say about them, except everybody always tries to set the volume with this guy up top, and that isn't how you set the volume. You turn it on by pushing that top button. Channel up and down. If you want volume, you push volume, then you push these top buttons, these up and down buttons right there to change volume. Same with squelch. Push squelch, then you can squelch up and down, and that's about it. So not much to say about a handheld VHF. Hold the top button to unlock it. The monitor up here, not much to say about that, except wiggle the mouse. It normally takes a little bit of time to come on. Sometimes this blinks on and off when the boat takes a roll. We never really figured out what that was. We pulled all the cables out and retensioned everything. I've always come to the conclusion that it's inside the monitor itself, because We can also see that big screen up there. You can set that big screen to PC, and you can monitor the PC as fast as you can monitor kind of a dual of this screen when you set the sound system to PC. When you set the sound system to PC, this and the boat takes a roll, the monitor sometimes blinks out and the big screen stays on. That tells me that it's past the little switching terminal down there. Okay, this is that is a handset for the VHF, which seems, or for the single sideband, which seems very antiquated to me, but yet there it is. Single sideband, you turn it on with the rotating this right here. You can pull out the handheld, click once, and the single sideband will go through its tuning, which it's doing right now, and there it is. It's all tuned up and ready to broadcast. You can hit receive, change to a frequency 4234, just for example. Hit receive, and obviously that's not a legal frequency, or maybe you have to enter. Okay, receive 4234, enter. Okay, then 4234 is the receive. You do the same for the transmit. 4234, enter, and there it is. Now it's going to broadcast and receive on 4234. I'm trying to do this, trying to actually film and watch the camera and activate the single sideband. So if that didn't show up, then well, I'm doing my best here. So Furuno Navigator. This loses its fix all the time. In fact, all of these Furuno GPSWAAS navigators lost their fix on almost every boat that we've been on. It was kind of a manufacturer fault, but nonetheless, this works most of the time. 3/4 of the time, it's giving a fix. You can tell right off if it's giving a fix because course over the ground will be 0 and speed over ground will be 0, and then that tells you that it's not giving a fix. It's just sitting there in default, or those won't change at all. It'll be stuck on some old number and will just sit there. This Furuno GPS is what is feeding the Maxi on the computer system. And so I'm turning it off right now by holding the power button for 3 seconds. And so this little piece of wood right here is kind of funky. You'll see it's somebody just like put a piece of plywood in there, so it's easy to you could change that if you wanted. The Furuno up here, Navtex is a Navtex receiver. Yeah, you get a little information out of that when you're at sea. You can get kind of some local weathers. Up here is the AIS. You don't have to do much with that besides just turn it on. Oh, the breaker is going to be off right now. The breaker is all the way down in that cabinet right there. And right now it's closed, but you can see that you can open those. See that? And see the breakers in there? And it's the AIS is on the VHF breaker. So you turn on the VHF breaker and you get the AIS on. You don't really have to turn this unit on here. This is for the local readout. Inside of here, oh, look at those hinges. Anyway, inside of this little compartment right here, is the AIS receiver. So this is just a slave unit. It's really not doing the AIS readout. But you'll power on. Maybe that's power on. Oh, there we go. And then that's enter return. Okay, so actually it's going to power up. Coming on right now, initializing. So the breaker obviously is on then. But oftentimes you turn off the VHF breaker because the VHF in the cockpit makes a bunch of noise, and that oftentimes bothers the people sleeping back there. Okay, this right here, the next one up, that's the CTEL. That's the bubble that's on the dome that's on the mizzen mast. Hang on, just sorry, but you know we all got to check our phones, and I just heard one come in here. Okay, so you don't have to, the CTEL here you don't do much with. You turn it on, it starts to go into this whole unwrap mode. I've had people say that it has to be on all the time, otherwise you take a boat roll and the CTEL burns up and breaks up in the mast mechanically. I can't imagine why that would be, but I've had the technicians tell me that. I've also had other technicians tell me, what? That guy has no idea what he's talking about. Anyway, if you leave it on, it sits there and hunts, and so you always hear this bzzz, 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 that echoes through the boat continually. And so, if you leave it off, then you have what these guys are telling us, that the mechanics of the dome. I'm a little sidetracked here. I got a bunch of stuff going on behind me. So, anyway. The mechanics of the dome don't allow protection of the moving parts up top. So I leave that to you. This right here is the Mini M phone. So you can just pick that up and dial 00 plus the country code, 00 plus the country code, and the number, and it just dials right away. That's the phone number that's registered to us right now. It probably won't be registered to that number anymore because whoever buys the boat will end up registering it to having to open up a new account. These wires here are a little bit taped, so be gentle with them because this is all really complicated stuff that would takes hours to fix that when and track down, and hours on tech support if you tear those wires out. The other thing about Mini M is, see that right there? You click on that logo down there on the bottom, and which is onto the toolbar. Okay, we'll come back to that because that computer's going all slow, but as soon as I see it come up, then I'll bring it up to you. So this right here is the far left-hand panel of the electrical system. So these gauges up here, these gauges read out what you have the lower switches set to. And so they're going to read volts, hertz, and amps in use. So in this case we have 50 amps, and we're set to number 2, which is the middle, which is shore power. So this one here is number 2, set to shore power in the middle. So we've got just over 50 hertz. Probably the gauge is more off than the shore power hertz. And then this one here is the volts. So we're sitting here at just over 200 volts, but not quite up to 220, and that oftentimes would mean that there's going to be loss in the shore power cord. So the shore power comes in the aft cockpit. It's got a 50 amp 220 connector there, and you can connect it, or you can put any amperage connector back there. There's also a big 3-phase, but the boat runs on single phase 220. But in the back, in the bag of electrical parts, there is a 220 3-phase. It also fits the plug connection on the back of the boat, so you can slide one out and slide the other one in and use a single phase of the 3-phase plug to get kind of a bigger amperage. But the cord is only a 63 amp cord anyway, so there's going to be limits through there, but I just put that out. So anyway, if we look down to here, this green light indicates that we have shore power, ship's consumables, 220 volts on, 220 volts on and off. This side is generator, this side is shore power. So shore power right now is in the on position, and so what we have then is green to the green indicating that the ship is running off of shore power. If we turned off shore power, the green would go out, and because we have power to the board, we would have white here. If we had the generator running, we would have generator white here and shore power white right here. Then we'll turn on one switch or the other. Now I'm assuming that there's a lockout to prevent, because this little switch runs a contactor that you'll hear a big clunk clunk when the contactor closes, and I'm assuming that they have a lockout, but I've never actually tested that, and wouldn't recommend testing it anyway. There's also the 110 volt circuit here, just in case you ever tie up in America where they don't have 220 volts. I don't know why the European boats keep doing that. I've never tied up at a dock that has 110 but doesn't have 220 that has enough amperage that it would actually help the boat in any way. I mean, sometimes you find some places a 15 amp circuit and no 220, and that's possible, but 15 amps would be like 12 or 6 amps or 7 amps at 220, and it wouldn't be enough to really do anything besides run a couple lights. So I'm not sure why they keep putting that on the European boats. I just saw another one that was that's a brand new build and also has the 110 volt loop on it. Never used it even when we were on the American side. Sea recovery water maker. This is the panel right here that runs the sea recovery in the Lazarette. Now, normally you start up, you change power. When you change power, you come over, you push stop, even though nothing's running. When you push stop, that recycles this little panel. Now you can push start, and if everything's right, it'll take about 4 or 5 minutes, and then the sea recovery system will start producing pure water. Actually, it's more like 1.5 to 2 minutes. If it clicks up on need service, chances are then you need to go into the Lazarette. Either it got shut down with power. The power got shut down without the sea recovery being shut down, and that always sounds the alarm, so you have to go back into the water maker and press the button that says clear alarms, and then while you're back there you can start the water maker a second time, and then you can watch your pressures, and it should run at about 840 to 900 psi on the high pressure side, and you should have about 1 3/4 bars on the low pressure side. So if the low pressure bar is, if you get an alarm here and you go down there and the low pressure bar is like 3/4 of a bar, the low pressure, which is the pre-pump running through the 30 micron and the 5 micron pre-filter, if those pre-filters are clogging, then you'll get low boost pressure and it'll shut the system down. So you should see 1 3/4 bar there, sometimes 2 bar. Oh, I just got a beep off of my camera. I wonder if this is running out of storage space. Maybe I'm talking too long. But if you're actually trying to take over the boat, you're going to want all of this information. And so, and just to tell you, we don't get anything out of this. This is supposed to be a day off, so I'm doing this as a favor for the next guy who comes on the boat. So I really hope that oh, now that there, listen to that. That is, funny enough, an alarm that goes off at, it kind of progresses by hours now and again, but that alarm kind of goes off each day at the top of the hour and lasts for about like 20 or 30 seconds. It was going at 8, then it went to 10, and I've never bothered to try to turn it off. I just kind of use it as a moment that I think about each day, and kind of use it to remind me that I'm still on with a boat that's still controlled by computers. Service inverter. Okay, we got 2 inverters here, service and nav. The nav inverter right here, this is actually an on and off. Even though they show 1 and 2, they're actually on and off, so that's kind of that label is a little bit mislabeled. Service is doing the whole boat except for the navigation stuff like the computer and all the chargers, everything that's kind of around the the cockpit, I mean kind of around the nav station area. So the nav inverter right here, you could turn that off, click, and all the computers and everything will shut down. I should say, if you ever get to the computer and the computer won't turn on, and you'll be scratching your head, oh no, what's this all about? And then you'll like start to, and like a third of the things in the nav station work and 2/3 don't, and it's first thing to do is check the nav inverter and then go into the engine room and check to make sure that the nav switch didn't get bumped. I don't know why that one switch seems to always get bumped. It doesn't seem to be any place more fragile than any other place on the boat, but nonetheless, every time I send a guy in there to do anything, I come out here and the nav system doesn't work, and I always seem to go find it in there. Okay, these here are oh, okay, one more thing on so how to switch between shore power and generator. You got, let's say your generator's running, so you have a green light here, the boat's on generator, so you've been running on generator for a few days. So you'll walk over, you'll turn the generator switch to the off position as it is right now. And this green light would come, or this white light now would activate, and this white light would already be on, indicating that you have 220 volts on the board. And one of the things you always do, you plug in, before you come over and switch any of this, come on over here and check your voltage, because you may have 400 volts, which would, or you may have 370, and they got a lot of voltages running around in these boxes, and you may not have noticed. And oftentimes, I mean, we had a 440 coming through a 220 plug, clearly a 220 plug in St. Martin, and somebody just had wired it that way because I guess some boat needed it and it never got unwired. So so all these docks, they look like they've got really really secure professional power, but really it's up to you to keep the boat from burning up, because if you put 440 through the 220 system, well, that'd probably be the death of the vessel, because they would need a complete electrical revamp after that. So anyway, so you come over here, you check your voltage, you make sure your hertz are between 50 and 60. In America, the whole boat will still run on 60 hertz. It just doesn't seem to matter, except for the washing machine. I don't know why the washing machines on all these boats never run on 60 hertz, but everything else will. So you got 220 volts. So now you can turn on, click your shore power. To switch back, you turn off shore power and turn on the generator. To turn off the generator, let it cool down for about 3 or 4 minutes, and then you can come over here and press the stop button. And to start, you press hold down, hold the bypass, and then you push start, like that. And then after you build up oil pressure, then after you build up oil pressure, then you can release the bypass shutdown, because the generator is on a fail-safe system. So if it doesn't have oil pressure, it won't run. You can see 11,672 hours on the gen set. Sounds like a lot, I know it does, but if everything goes right, you should get about 30,000 hours on those on the gen sets, even though we just replaced a heat exchanger. Okay. 3 battery chargers right here. Oh, okay, one more thing on the generator. I know I'm skipping around a lot, but I'm filming and I'm thinking, and I got a lot of other things on my mind because we're in the middle of a double boat transfer here. So if this doesn't sound that logical and clearly progressed, remember this is just an off the wing, because I'm trying to make your life easier to take over the boat. So if you push bypass shutdown and go to start and the generator doesn't start, the generator has a bad cable between the generator and the battery. Now I say this, it's not the battery, because when I try to start the generator and I check the voltage at the battery, the voltage only drops out from 12 to like 10.5, whereas the voltage at the generator when I try to start is like 3 volts or something, or 4 volts, and when I get to the when I check at the battery, it's drawing like 400 amps, and when I check at the starter, I'm getting like 60 amps through. So there's some spot between the battery, which is located in the aft cabin, just to the starboard side of the floorboards, and the generator. So. But now what happens is if I start the generator every day, this is never a problem. It's only ever happens when the boat sits for 2 or 3 weeks, and then I have to restart the generator. So that also could say that there's a drain and the voltage is going out of the battery, and the battery's going flat and then recharges. But it doesn't seem to, because I go back there and check the voltage on the battery, and it's sitting there at like 12.7, 12.8 with no load. And when I clamp amp the cable, I'm not getting any drain out. So I leave that to you, except that in the engine room, right now I just left a little battery start pack, and there's the red cable goes under the starter on the generator, and the black cable goes on the back of the starter, and then you start it up, it just starts like bada boom, bada bang, and then once it's all warmed up and you're using it, then it's never been a problem. Like, I mean, we ran the boat for the last year, and only every time the boat sits is this ever an issue. Okay, 3 chargers right here. These are the chargers that charge the service batteries and the navigation batteries. Those are huge battery banks that are in the main salon just aft of the watertight bulkhead, port and starboard. And the chargers themselves are in the engine room. And so you walk around the engine room, you'll see on the wall, you walk in the engine room door, and straight across from you are 6 big devices, all master volt. And those 6 big master volt devices are inverter, and 4 battery chargers. I mention this, it seems all pretty simple, but I'm mentioning this because when you come over here on the next panel over, see where you are. Okay, you come over here to the next panel over, and you got your 4 battery charger outputs. The reason this is important is if you're load sharing, like let's say you come up and you've got only a 50 or 60 amp circuit that you can pull from on the shore, or you've only got that 63 amp shore power cord, you can come over here and turn off your outside chargers, which are the big chargers, and leave the smaller inner chargers on, or maybe even turn 3 of them off when you first plug in, because when you first plug in, the hot water heater is going to activate, the aircon may activate, you got all these other things that are going to take a bunch of load. So you can turn on 1 battery charger, you can wait an hour until that battery has tapered off, turn on the second charger, wait an hour, and then you can turn on the other 2 chargers if you need them. Okay, we open this up right here. Those up there are the high voltage, the 220 volt breakers. Not a whole lot to say about those. It's all pretty basic. There's those are the contactors over there that are contacting and allowing different ships' power to be diverted to the main bus bar. So depending on which contactor closes right there is whether or not you're on shore power or generator power, and those are of course activated by those rotational switches that I showed you on the front. There's also a little fan right down here. See that fan? And you can turn that fan on by closing that. But hear it? Listen to that. And that's quite loud, so that bugs people. So anyway, everybody always turns that off. You can see all this dirt right here. That's just because air is being sucked through and getting stuck on the components. Eventually, of course, that would make a short circuit, and so because of that, you go on over and and clean those with the dustbuster every now and then after you've secured power to the boat. Okay, so these are the chargers here. We already talked about that. These lights here are testing to make sure that the now I've kind of wondered about this. I've asked Vitters about this also and never got a response. But I think what happens is that this is determining how much of your load is coming out of the battery compared to how much is coming from the dynamo, which is the engine alternator. So the engine has two big alternators on it. It's got one for the service batteries, one for the nav battery, and we figured out which one's which and wrote it on the side of the alternator. So when you take battery, you push this button right here. Let's say the dynamo was very bright and battery was very dull. It would mean that your batteries were very flat and the dynamo, the alternator on the main engine, was pumping as hard as it could. On the other hand, if you saw battery light was quite bright and dynamo was very dull, it would probably mean that your dynamo wasn't putting out the power that it should, and the batteries then are actually running the boat or powering the boat, and those would both be warnings that something is not quite right. If those two lights balance in color, then everything would be right. Now, of course, I don't know if that actually makes sense, because I've been trying to figure out what these two lights mean. I don't know if that actually makes sense, because dynamo isn't putting out anything right now, and the lights are even. So I leave that to you, but that was our guess at this point. This is the amps coming out at the battery itself, and so at this point we've got a little bit of a positive charge, and of course that's coming from the battery charger. Same over here. The nothing coming into the navigation battery, and so the and so where is all that current going if that battery is always charging? It's probably maybe there's a bad cell on one battery in the bank. Maybe the batteries are bubbling just a little bit, because that's energy, and that energy has to be given off somehow. Well, let's see, that's what that battery is running at. It's sitting at 26 volts, sitting at 26 volts. That's all good. Oh, by the way, these are the this dynamo and that dynamo. Those are the alternators on the engine, and this one has always worked. It was never a problem, and then we changed the alternator back and forth a few times because the alternator had a bad diode. The navigation alternator did, and then it's either that one or that one. The dynamo stopped giving a readout, although it's still, if I clamp the cable, it's still putting out, and I can see it's still putting out from voltage here, so we just never got around to figuring out what happened with that. It also could be, by the way, that the sensor for the dynamo is in the then the sensor would just be, because it's actually reading volts and it's giving us an amp readout, but it's actually reading volts across a shunt, and that shunt is in the second floorboard back, just aft of the watertight door. So one floorboard back, there's two big gray boxes in there, and those are the power distribution, the actual power distribution for the service battery and the navigation battery. And inside of those gray boxes, you open it up, and there's a series of shunts in there, and those shunts are what are actually giving the signal to these dynamos right here. Okay, capacity. These two capacities right here are kind of like some amp counter. It doesn't make any difference. The batteries go completely flat. The thing sits here on green light. You can pull them out and put a couple of E-meters in there, and you would have something real. But in the meantime, that's kind of original equipment. Freshwater systems, port and starboard right here. That's the amount of water in the freshwater and starboard tank. Fuel, you can see this boat is going with full fuel tanks. How about that? So this is our fuel, port and starboard. Down here I've got this little 440 and 775 with these two little lines. That's because I had the tank completely empty once and slowly filled. And you can peel off that blue tape at your leisure once, if you can kind of remember that or do that a little bit more pretty. It just happened, it was a quick spur of the moment thing. One of the things that did up on the wall up here, there's a graph that tells how much fuel compared to how much fuel is actually in the tank compared to what our fuel gauge here is showing. And by taking the tank when it was completely empty and checking at these 2 points right here and then comparing them to the graph, then we verified that that graph is actually accurate. So that graph can be trusted. I guess was the point of all that. When the tank is completely full, it comes up to that little black mark. So that isn't a warning. That's a full tank right there. This right here are the alarm systems. So this is if you get an alarm, like let's say low pressure engine, oftentimes you'll get that when you shut off the engine and don't turn off you push stop on the engine, but you don't deactivate the ignition quickly enough, then the system there will think that the engine stopped, as it did, but it doesn't have oil pressure, as it doesn't, and sound off the alarm. And so you come on over here and you push general accept, and then that alarm silences. But if it's still an active alarm, once you push general accept, then the lube oil pressure, just for example, light would stay on. What you'll probably get the most are black water, fore and aft, that's telling you that that the black water tanks are full, and then you got to go through the pump out procedure. The one light that always stays on is bilge crew. That's because the that switch down there is broken and we need a new float switch. Remember, it's an aluminum boat. You don't use a flip-up float switch that has mercury contacts, because if it ever did break, it would destroy the hull. I mean, like literally destroy the hull in a matter of months. Aluminum, that's why you never see mercury on an airplane. And the same with an aluminum boat. But everybody in the airline industry knows it. Nobody in the boat industry knows it. And so I point that out because this is an aluminum boat. Fuel day tank right here, that is the amount of fuel in the day tank. It turns on when it reaches, the day tank's about 120 liters. It turns on automatically, activates the day tank transfer pump, which is in the engine room going through the large ray core. If you ever try to transfer fuel and fuel is going really slow, that's an indication that the fuel transfer pump system filter has clogged, and so you go in there and change the filter, and it should normally take about 4 minutes to fill the day tank from empty. And it just kind of goes back and forth. You can come over here and see this right here, day tank pump, and you can turn on and manually turn on the day tank and start transferring fuel. Of course, if you went off and made a piece of toast while that was happening, then that tank will just overflow and start pumping fuel. Well, I'm guessing it would pump through the overflow and out into the water. So you don't really use that that manual. We used to have to use that a lot when we were sorting out the system and fixing the fuel transfer system. But now it works. It's all automatic. So you shouldn't have to do anything. If the fuel tank transfer didn't work, or the fuel transfer filter clogged, then eventually you would suck down past this black line. You'd get down a little bit more, and what you'll get is one of these alarms will come up that says low fuel. One of these will be fuel day tank low. If you get a fuel day tank low, then that's a clear indication that you have a clogged transfer filter, or maybe the pump's gone bad or something like that. But in general, that's the only time I've ever gotten the low fuel day tank, is either when this switch was in the off position, or somebody had been working in the engine room and had turned off the big red fuel transfer emergency stop switch, or the fuel filter for the fuel transfer system, which is a large Raycor 1000, has clogged. Okay, this battery alarm, it's just tells us if the voltage has dropped out. It's another system from people that don't live with alternative power. Okay, not a lot going on back here. These are all just monitoring systems. You probably just never have to get in here. I've never had to get in here for anything important, except to look in there and think how lucky we are that the system continues to work on the monitoring edge. Okay, so now this right here is kind of the bane of the electrical system right here. Up there, that top row right there, those are the fuses for both positive and negative fuses for the navigation lights. About the only thing that is, I'm just going to look and see, because that says that my nav light, my lights are on and they're off. So turn that one off. This, by the way, this night illumination right here turns on and off that light up there, see that? Which I'm assuming was supposed to be red, and so you would have a red night illumination, but anyway, it's got a white bulb in it. It's never been an issue, so we haven't changed it. Also, night illumination is this fan. This corner can get quite warm, so there's a fan right there. Notice that coil of wire right there. That coil of wire is a total fire hazard, because I don't know where that wire goes, but that little bitty wire, I'm just assuming that it isn't fused or fused properly, and that little wire, if you ever did have a cross of wires up there, would probably just make a perfect coil, burst into flames, and you'd be running around trying to secure power, and you'd secure power by turning off night light. In this case, I'm going to leave as many lights on as I can, because that will probably make the video camera much more, what would you say, focused, because more light allows the video camera to focus more. Okay, so anyway, so this is starboard running light, port running light, stern light. Top light's the anchor light. Red and green is when you're sailing, vessel over 24 meters, sailing, red over green, sailing machine. Steaming light. Steaming light doesn't work right now. You'll notice when you turn on one of these lights, you get a corresponding indicator. Now, this little system, right, this little wiring area has been messed with by so many different people, and so oftentimes you'll turn on port starboard, like see that? I hit stern, and the light goes bright. Now, if I turn off, sometimes I start turning on other things, and they won't indicate. Yeah, okay, there. Watch this. The forward lights here are lit right now. I don't know if you can see that, but if I turn on the stern light goes brighter, and these lights aren't on. So anyway, that is something to track down, and but it's a kind of a small issue on a big boat. The fire alarm down here has never worked. Battery fan I never use. Oh, emergency batteries. Okay, this is your service battery contactor. That's your navigation battery contactor. So right now both systems are running in parallel. No big deal. But if you lost all power to the batteries, you would still have your emergency batteries that you could turn on. There's a set of gel cells in the very stern with their own little charger back there. So you could, if you absolutely needed, you'd probably have 2 more hours of power through the navigation batteries. Okay, so that little corner, see to the right of the breaker, is the diode pack that runs the lights that should be reading out on the on this panel here, and that's probably what you're going to have to mess with to if you want to get that panel fully operational again. You can see up there that all looks pretty straightforward. In here that all looks pretty straightforward. Nobody's been in there messing with it, but you get here and you can see people have been in there messing with that, and that's the area from this point here to the aft port cockpit. There's a little distribution switch panel that sends power to the mast and sends power to the lights and all that. That's the little area right up in there that probably, if I was to upgrade anything, that's what I would be focusing on. The whole rest of the electrical system, I know people they talk about this like it's this huge electrical disaster, and it really isn't. Everything works on the boat. All the electrical on the boat works, except for this distribution right here, this one little panel system right here that goes through all of this stuff down there. So you find yourself some guy who's pretty savvy and can clean up that one little section. The whole rest of the boat works. And so I've seen previous crew talk about how the electrical system drives them crazy, but it hasn't drove me crazy at all. It's all worked. I just, you plug something in here, it's coming off the inverter, it works. You turn on anything on the 220 circuit, it works. You clamp the ground lead from the 220 system to the hull, I get zero amperage. I check for voltage, I've got no voltage. I mean, it all works. It does what it's supposed to do, except for this little system right here. So that's like one loop out of everything that somebody's going to have to deal with at some point. Okay, we come down here. That right there is the 24-volt circuit panel breakers. Now it's interesting. See these all that wire right there. That's just old chargers and stuff that USB cables and all that. It's got nothing to do with the boat electric. It's just in a box right there. See that? One thing is keep in mind. Oftentimes people will throw these chargers back in here and they'll click off a breaker unsuspectingly, and they don't really hear the click because they're already throwing a bag down in the box, and then they'll throw the bag in and it'll turn off the chart plotter as they're throwing a bag in, and then the guy at the helm comes down and says chart plotter isn't working, and nobody really correlates it to the that they turned off the breaker by accident, and the next thing you know, everybody's wandering around trying to figure out the chart plotter because somebody put their iPad charger trying to keep it out of sight. So I tell you that so that all those breakers should be on. Everything in there is on. There's no breakers that are off normally. So okay, and what do we got in there? That's nothing. Bicycle pump and stuff. Here's the printer. The printer is gosh, that printer. It normally clogs a paper, about 1 clog per page printed. So not much I can say about that besides get a new printer. Okay, so now we turn this. I'm going to turn this back on. Now I don't know why that is taking so long. Windows. If it sits overnight, then and that's. Okay, so you get this. So I clicked on this right here, which that little satellite is my Amos Connect. Amos Connect is a program that connects Mini-M to the computer. So the Mini-M is a data system that also works phone. It's mainly phone that does data, I guess would be if I was being correct in this. And so the Amos connects the computer to allow you to run email through the Mini M. And Amos isn't part of the Mini M, so like if you find that this Amos program is pretty clunky, there's a few other ones on the net in shareware that you can try. So you click on the Amos Connect button. You get a little blue screen up here. You click accept, and that little blue screen connects you up here to the Amos Connect. Now you're gonna have to get a service, and when you get the service will give you a email address. But in the meantime, to connect after everything's all hooked up, you come over here to remote, the remote tab, and then to dial remote PO, give it a click, and it'll bring up eventually. Oh, and you heard that beep. I don't know, that sounded like the Mini came from the Mini M side. So I hit this dial remote and I wait. Every time the computer slows down like this, which is most every other day or so, it's probably got something in there that that's causing it to slow way down. Every time it does that, then okay, so I hit remote PO, then I'll get this screen right here. On that screen I come over and I hit connect, and I hear that beep over there. I normally don't hear that beep, so we'll see. The computer itself is fighting right now because it's going really slow. So, but anyway, you'll hit connect, and then you just wait. And oh, also on here, see that MTU 183 right there? Those are all the MTU 183 manuals. For some reason, the manuals aren't in the red books in the back, and so we spent a lot of time and talked to a lot of people that had that engine before finally. Yeah, see, like I've double clicked on this MTU and it's not opening either. So it's not the Mini M that isn't connecting through the Amos Connect to the Mini M satellite system. It's the computer right now probably wants me to come over. I even click on that start and it doesn't go, and I'll hit restart and let it restart. But anyway, that's the general system. This little switch right here has never done anything, and the rest of it's just a few nav books up there, skiff hanging. See, I don't know if you saw that, but it was one program still to close, and it doesn't show a program, and that whatever that program that's still to close it isn't showing is probably what's slowing the computer down. Okay, I'm going to do one other thing here. As long as we're going full Monty. Okay, this right here is the computer back. Okay, so this right here is the hub that for the router for the yacht spot, and the yacht spot is the Wi-Fi repeater. And so then this right here is power over Ethernet, and so this is what powers the antenna modem that's in the back of the boat. So you get a DC in. PoE is power over internet. I think it's sending 50 volts, is it? It's something like that. Anyway, so now this right here is sending power over Ethernet, 50 volts, that goes all the way back to the very back of the boat, down by the base of the mizzenmast on the starboard side. And down there is a little gray box right next to the air handler. You have to get everything out. All the red books come out, then the air handler opens up, and then there you are. You've got a gray box, little gray box. It's all waterproof, sitting back there, that has a Ethernet connector like that. That's through a little waterproof plug, and then an antenna coupling after that. Okay, this right here is tells whether the Furuno GPS or the Furuno GPS. Yeah, I think that's the last thing, so I won't have to get too deep into that. What's telling the computer? So this picks up a GPS NEMA connection, changes it into a 9-pin that goes probably into there. I'm just guessing at that, but it's a 9-pin that then tells the computer what the GPS fix is, and then then either the Amos Connect, for example, might send out your position when you send out an email, or the Maxi also will use that fix. And I get a lot of conflicts with that. Maxi's been very undependable on this computer, and we get a lot of SQLR errors, whatever that is. And it says call Maxi, and that just started happening on the last crossing, and we haven't gotten into that. Okay, so this right here is the switcher that switches the video screen and the TV screen, and so it tells the computer where to send the signal, and that's that. What is that? That's this 3-row VGA connector or something, I think they call that. Not much else in there. There is a this right here, this little white is a USB splitter that has its own power. So because the computer was just getting overloaded with USBs and everybody plugging their hard drives and stuff, and maybe that's what happened. Maybe we got a virus in there that that's slowing the computer down. So okay, now I'm going to try to just set the camera here and show you this cushion right here. Maybe I aimed it. You got to push this cushion in from the top, totally from the top, straight down, straight down, straight down, and it goes right on in. Otherwise, it's a big hassle. Okay, any questions? I hope not, because I just spent a lot of time explaining all that. And so that's the nav station right there. That's pretty much everything that I know it's a mess, but we're in the middle of moving off the boat and all of that, so I'm sorry for the confusion in there, but I think I got pretty much everything explained, and that's a heck of a lot more than we got, because we walked in here and just kind of like looked at this board and said, okay, this ought to be pretty straightforward. And so piece by piece we worked it all out, and I think I've transferred and given you all the information that I have on the Aphrodite nav station. Good luck with it. You can always email me if you get stuck. I'll do what I can. I'm really good at answering emails, and I've got a really kind of photographic memory for boat systems. So boats I was on 10 years ago, I still remember all the systems. And so if you get stuck, you can always send me an email, and I'll see if I can answer it. And other than that, good luck. I hope this video helped. Bye bye. Okay, these hatches have leaked from the time that the boat was new, and has caused just unending hassle and heartbreak for the crew, and of course the owner, who's got to pay all the bills. And they've tried innumerable things to fix it, and it's always been a hassle for them, but they're fixed. So I'm going to show you what we did, and then leave it in your capable hands. So the way this hatch is supposed to work is water drains off the deck into the crack, drains here through a hose to the overboard, and that's it. And then there's a seal right here, and this seal sits against this space and prevents water from going into the boat. So at first glance it looks like a great system, but there was a couple things that were happening. First of all, this seal wasn't really sealing, so the back half lifted. The back half of the hatch would lift, which I'll talk about in just a second as to why that was happening and how that's been solved. And then that water, the water that would peel off the decks, was a little bit dirty, and little things like, I don't know what's that, a little piece of something that was blowing in the wind maybe, and would clog that little drain hole, because it's not a very big drain hole, you can see. I mean, it's not much bigger than, let's say, a pencil. And then what would happen is that the water, because the back half of the hatch wasn't sealing against the seal, would just pour. Like, I mean, it was unbelievable how much water, for really calm conditions, just taking a little bit of spray. It was almost like you can imagine somebody took a giant funnel on deck and funneled all the water to this spot, and it would just drain down below. Now what we found was that the hatches were lifting, and that the hinges were lifting. And the reason for that is that, see that block of aluminum right here? Okay, so if you look at the top of the hatch, that top of the hatch has 4 screws that go into this block of aluminum and are tapped into this block of aluminum. At the same time, they tried to do the same thing on the other side here into the deck. And so what happened is that they took a block of aluminum and they welded it along the edges down to the deck. And so it was just welded along the edges. And so then the other side of the hinge right here was bolted into that block into the deck. And so what would happen is water would get between that bolt, it would run down that block, and then you'd get this like layer of water that would go between the stainless hatch and an aluminum block. So you got dissimilar metals, and you got lots of metals in there, because we've got the aluminum for the block, the aluminum for the deck, the stainless of the hinge and the stainless of the bolts. And although somebody may have tried to make them all the same, they're just never all going to be the same. And so the whole thing would corrode, and when it did, then that block, that was the block of aluminum that was down the deck, would corrode between the block and the deck, and it would lift. And when it lifted, then the whole hatch would lift just a little bit on the back side, and then the seal, which is the seal between here, which is attached to the hinge, would lift off of the sealing face, and then there'd be a gap in there where you couldn't see, and then what we have is a giant hole that just funnels water, and it just poured down below. So the first thing that we did was we got rid of the aluminum that was the block, and we made that block out of epoxy. And so that does a bunch of things. One of them is the epoxy sticks to the aluminum, so it makes a seal on the aluminum. An aluminum block laid over aluminum leaves a water gap, so that was kind of an issue right there. And so that was the first thing that we did. The next thing that we did was we added this other hatch dog right here, so that we have a way that we can pull the back half of the hatch down. So these are original, and then this is a new hatch dog. And something to mention here, as long as we're talking about hatches, notice the back corner of the hatch, the back of the hatch dog right there compared to that hatch dog. See how they're a different shape? That shape versus that shape. This is the new, and this is the old. They switched, although they will never, of course, tell anybody. They switched because people were undoing these hatches and getting that would catch people's rings. See that right there? And so they changed so that it's less of a ring catcher, and so we appreciate that upgrade. So that's another thing, is be careful when you're releasing your hands if you're wearing rings, because I know a couple people who have gotten rondel, including me, except I don't know if you can see my ring. Just because I work on boats, I slit the bottom of the wedding ring. See that right there? So that if I ever, and I've had this ring almost get yanked off my finger by one of these rondel hatches, and so I just mentioned that as a sideline. Okay, so the next thing that we did then was we ended up having the old bolt holes in the deck, and we kind of, we did this in Puerto Rico just before we crossed the Atlantic, so I didn't have a lot of excess time. So I ended up putting bolts tapped into the deck right here. But what I would do, now that I'm kind of back and have more time, I would take those four bolts out, and then I would take another stainless plate just like that, and I would have these bolts welded to the stainless plate, drop them through the deck, and put a nut on the backside, and it'll be totally secure. But even as it is, it's leak-free. The only leak now we have is, look at that, that's a brand new hatch, and see that gasket, I don't know why, that gasket just cracked and rotted out for some bizarre reason. So this particular brand new hatch dog has a drip that comes from that gasket, but you can see that's nothing. That's easy to fix after all that we've been through. Okay, so I'm just giving you that so that you know what has happened with these hatches, and they are leak-free now, and so with any luck they'll stay that way for a long time. Okay. Walking into the galley here, and we're going to talk very quickly about the aircon chiller. Now, one of the first things you'll notice is up here there is a fault light, and then the cooling light and the heating light. Heating light never goes on in this instance because we don't heat. Like this panel has a little heat thing on it that talks about heating, but I don't think that there's a reverse cycle on the aircon system. What there is a old Webasto heater back there, a boiler that has been disconnected, and a new one could be put in its place quite easy. Like there's a space for it and an exhaust port and all that. But in the meantime, if you don't have a little diesel heater, what we've got is aircon. So I'm just going to go over real quick what. Normally we leave it in this position right here. So I just hit back. We have back, enter, up and down. So I hit the back button twice, and that brought me to this screen, which tells me my loop temperature. The loop temperature is the cold water that's circulating through the boat, and that should be normally under about 10 Celsius, something like that. And so that tells you that the compressor is indeed chilling as it should. So if we hit back again, now we get into this main menu there. That's main menu, and I can start scrolling down. And the ones that you're going to want, one of them is chiller status. You hit enter, and it'll tell you that we're in rotate. That means that the compressor is active, it's working, it's just not in use right now because the loop temperature is low. And once the loop temperature raises because the air handlers have been activated, then the loop temperature will go back up again, and then the chiller will turn on. Okay, we continue on down. Initial setup degrees Celsius. If you really wanted Fahrenheit, that's how you change it. Fault log. Okay, faults. Here we have total faults, 5,145. Low AC voltage. We have 12 of those. This is over the history. Most of those came from a power cord that was bad. If you see flow switch here, that means that you need to go back into the port Lazarette and pump up the loop control, and I showed you how to do that in the port Lazarette video. So, but if you get a flow switch, that's the one. Low suction, 0. That means that the compressor, and high discharge, that means the compressor is not clogged. Low loop temperature. Now, this low loop temperature is 5,002. That's actually more of a problem with this little cruise air, and it doesn't shut down or anything. That was a fault that we just had. And what that means is that the loop temperature itself got down to a predetermined number. I think it's like 4 degrees or something. And at 4 degrees, the cruise air itself turns off the compressor because it doesn't want to freeze the loop. So we appreciate it doing that, and I think that's about the only errors that you'll ever get. I'm just scrolling down here. Oh, wait, no, there's 9 of something through the loop return probe. Don't know what that is. Never seen that in the last year. And okay, so now I hit back to get back to the main menu. I continue to scroll down. Fault history, input, output, chiller on off. This is another one. Sometimes you got to scroll all the way down here to chiller on off. Get up here to number 1 and see how that says enabled. Sometimes you'll get an error that I think it's the low voltage air that causes that to go into shutdown, and so then you have to go all the way down to chiller on off, go up to chiller number 1. All the rest of them aren't in use because we only have one chiller, and obviously this is a universal cruise air panel for more than one application. So we only have chiller 1. In chiller 1, if it says shutdown, then you put the little cursor mark next to chiller number 1, hit enter, then it'll go into something else and scroll through, hitting enter until you get to enabled, and then you're set to go again, and it should take off. Language or dialogue, and that's it. Okay, so now I hit back again. My loop temperature is 8.8, and we're back at the main menu. So that pretty well gives you what to do. The big thing is over here is turning the unit on and off, and then which is just right here on the main menu, clicking on to cool, and how to get rid of those faults. And so I think we pretty well covered that one. I'm going to do one other thing here as long as we're going, and that is I just opened up the engine room door, looked inside the engine room, lift up this floor plate right here, and I'll use a flashlight here. Oh, flashlight's not working. Okay, so we will okay, so now I just went through that floor plate. One of those, probably that one, there's going to be 2 pumps down here, see? One of these pumps is the aircon circulation to pump seawater to cool the aircon system, and I think it's that one right there. And then there's one more, I think it's under the next side. Oh yeah, okay, see there it says AC pump. And the other side is the water maker circulation pump. So one's for the water maker, and one's for the aircon. Now you could possibly at some point you could break a pipe somewhere, and if you did break a pipe, then what you would have is a broken pipe underneath the water line with a big pump behind it, just trying to fill the boat with water. So if that were the case, do you remember what you would do? Did you watch the safety video that's on YouTube? Because it's not going to be on this one. You would come over here to these guys, which you can barely see, but they're all the pull cords, and you would close the through hull to those. You would close all the through hulls right off, and then that way, if you're sucking in a broken, if you got a broken pipe, that's the system. Okay, I think that's it for HVAC. So we've already covered the rest of the HVAC. In Port Lazarette, when we talked about the Port Lazarette, I went over the HVAC system. I'm just kind of coming around to point the camera that way, and then I also covered the air handlers in another separate section, so we should be done with that. Okay, we're going to talk about aircon for a minute, and what I'm going to talk about right here are the air handlers and what's gone wrong with them and how I think that they can be fixed relatively easily. There's a chiller system that's back in the corner. We're going to talk about that separately. And we're going to move back there and cover that. But that chiller system chills water. The water then has a circulation pump and sends chilled water throughout the boat. Air chillers, water chilled loop is the term. So if you're not familiar with these, like if you're coming from a smaller boat, you're not familiar with the chilled loop. This is a chilled loop system. So we've got one big compressor back here. It cools the water. The water circulates around the boat, and then each cabin has an air handler, and an air handler means that it's just like a radiator with a fan and a thermostat. Very simple. When you want cold, the fan turns on, and the little electro valve opens up, circulates water through the radiator. The fan blows the room temperature air over the radiator, and it comes out cold. Very simple, great system. And the big advantage is you don't need all these little compressors, so you don't have all these maintenance headaches. And air handlers tend to be very dependable because there's nothing to them. Except in this case, the way that the air handler on Aphrodite works is that each air handler has this little electric valve. It's got like a little clock motor, and the little clock motor opens this valve that allows water to circulate through the radiator. And as long as there's voltage to that like little clock motor, then it keeps the spring open. Now what's happened is that spring all over the boat on every air handler has kind of gotten old and just gotten tired, and so the springs don't close the air handler thermostat valves dependably. And some of them, like back here in the owner's cabin, they just kind of get stuck on. So in effect, then what happens is that the rooms become too cold. So it's kind of like paying too much taxes. It's not that bad of a deal, but it's a bad deal. It's worse than not having a compressor where the boat gets too hot, but being too cold is kind of an issue too. So anyway, over the year that we've been here, we've called in a few different HVAC guys and asked them what the solution is, and they all look at it and say they don't make that valve anymore. And then they all look at it and say, no other valve fits that spot. And they go and they look in their books and they say, nothing else is going to fit in this area. So you need a new air handler. The new air handler is $4,000. And then if you're going to get an air handler, you need a thermostat kit. And the thermostat kit's $2,000. So now we're looking at 6,000 euros to change an air handler that's pretty much working under there. And then now, well, there are 10 of them through the boat. Plus the guy's got to do it. Plus we got to tear up the boat. We're really on a €100,000 project here. This is like all of a sudden starting to turn into a serious issue where the boat's already getting cold. So I started taking a look at one of these air handlers. So what I did in the interim was the air handler that's under here, I just disconnected the clock motor. So we only have one air handler running in the aft cabin right now. The other one circulates air, and you can put the clock motor back in position, but it will start getting cold again. But this way, what happens is it doesn't get too cold at night, because that was the complaint. People say at 2 o'clock in the morning the boat is just getting down to like 18 Celsius or something. It's just too cold. And then if you turn off the compressor, then of course the whole boat heats up. And so I started experimenting with different springs, and this is as far as we got in the project, and that's something I want to update you so that because somebody's going to be taking on this project at this point. If you go to the air handler springs, I think that if you just put a little gentle spring pressure on, like a very light duty spring, then that would be enough to pull the air handler valve closed again. And to me, it looked very simple. I was just kind of waiting to get back to it. And then we don't have to change all these air handlers. We don't have to do anything. All we got to do is figure out the spring, where to attach it, and put a little spring on the air handler. The next thing I was thinking of is just buying the valves and just making up an adapter. I mean, how difficult can it be? It's just, you got a pipe and a pipe, and you got a valve, and yeah, sure, you might have to make some S-curves or something, but that was going to be a long second for me, because when I looked at the chances of putting that spring in there, I thought, that's going to be the 10-cent solution. But and I bought a couple springs, and that's as far as we got in that project. So that's it for that. Okay, so what we're going to do now, I'm just going to walk through the whole boat, and it's just a quick overview of what is where. And so if this kind of, in some ways, might help you from having to tear up every cover, you're going to have to do it anyway, but eventually, at least, you'll get an idea of where everything is to start with. So we go with this bunk right here. If you go underneath this bunk forward by the feet, and let's say you pull this mattress out or flip it over, there's a hatch right there. You lift up that hatch, and then there's a storage area for, like, you can put a couple big suitcases under there. It's a fairly good size. If you pull everything out of that hatch, you can lift up under the bottom of that storage compartment, and there's another access area, and that access is how you get to the bow thruster, So that gets you to the mechanics, that gets you to the arm, the actuating arm that opens and closes the bow thruster, and to the limiting switches. So if you ever get into a situation, for example, where you're up on the, you activate the bow thruster, but it doesn't open all the way, or it isn't opening enough to activate the limit switch, that's how you get to the limiting switches. You can also get to the backing bolts for the zincs of the bow thruster box. So,
That's it.
no, you can do that, yeah. Okay, under this section right here is access to the air handler. So you lift up this mattress, there's the air handler. I don't think there's anything under the floor here. These, both of these cupboards right here have compartments underneath also, so you can pull the floor and get to another compartment. This one has some kind of a little bit of crazy lighting. It's got these, it's got a switch here that does the two lights up top. Then it also has a switch here which does that light, and the light way over there. Then it's got a switch under here which does that light. Okay, so I got a switch under here that does the overhead light, the dimming lights that are fore and aft, and then the rocker switch which does over the vanity, and then each bunk has a light up in the corner up there. So okay, so that's about it for this. Just think if there's anything else that's about it. Flashlights in every cabin. Okay, so now one more thing. Up around here, hanging by this wire. It's always been like this. It seems pretty bizarre to me. That's the aircon. Push that upper left-hand button, and the air handler will turn on. And okay, so, and I'm just going to leave that open. I'm going to turn off the air handler because, although it's hot, we don't want the noise for filming. See what we do for our listening audience? Okay. This locker here is another crew room. So both of these are crew rooms. Both of the crew rooms tend to use that bathroom that's just off to starboard that we'll talk about in a minute. And then if you shine to that door, that bulkhead right there, that bulkhead shuts off, and so this whole area stays as a crew area, and then the rest of the boat can, if you desire, be a regular area. We've never actually separated up crew like that. It wasn't part of the system that we use, but the boat is set up for it. And if so, then the crew could actually go up and down these steps and go out this forward hatch if they wanted private access for some reason. Okay, under here, where my right foot is a little foot hatch. A little hatch down there, and that's the hatch I'm talking about, that if you look under there, there's a Y valve, and underneath that Y valve, one way drains the forward chain compartment, not so much the chain, but the forward bow area, into the bilge. The other way diverts to another Y valve that we'll talk about in a few seconds. Okay, what do we have here? More clothes with see the little hatch under there, so you got another spot where you can store a few more goodies if you want. These here, all this cabinetry, and all of these guys were all kind of ruined over the years because these hatches leaked. Now we solved the hatch leak, so that's kind of an issue that's done. So see, like how these hinges are shiny, that's because people were constantly buying these hinges and changing the hinges, but the hinges were just getting ruined because salt water was pouring down here for a time, and that's how come these ocean vents got ruined. And so since then we fixed the hatches. Now everything else is quite easy. Aircon up here for push the left-hand button. The aircon should turn on. Okay, that should be about it for that very forward cabin. 2 crew can go in here. You can, if you're really cozy, you can get 2 crew on the bottom there, husband and wife team, very skinny people. Okay. Underneath here is the blackwater tank. Blackwater tank is new, from maybe 2 years old now or something. We never mess with it. Occasionally, just very occasionally, you get this burp. You get a burp, and you get a sewage smell up here. And my thought is that there is a hose that goes from the sewage tank. The vent hose goes to the base of the mast under the floor here. And my guess is when the mast got put back together I remember that there was like this deal, and one of the guys that was helping said that he wasn't sure if he got a really good seal, so he put a little bit of spray foam around the outside to seal it up. And so I don't know exactly what that means. I didn't actually get back to that to check and see what he was saying, but once in a while we get a little sewage smell up here. It's not very often, it certainly isn't right now. Okay, under my foot right here, under my left foot, is the other Y valve. So we end up with the forward compartment that can drain into a Y valve that now you have your choice at the point forward up there whether or not you drain into the bilge, the common bilge of the forward section, or whether or not you use the Y valve that's under my feet, and now you can pump straight into, it's either the gray water or the black water. There's another Y valve right here that takes the other gray water or black water pump and pumps the crew area. Okay, so we've covered those 2 pumps. Normally, if you don't have any cushions or anything in here, you can walk around both sides of this mast, which is quite a good thing. This is where we store the deck cushions. These cushions get laid out on deck. There's you'll see that these flaps go up. You remember that the flaps go up, and then and what happens is the cushions kind of get a little bit stained from the black rubber on the deck. So we try to put them out the same way every time so that the suntan lotion spills stay on one side and the black marks from the deck stay on the other. Because remember, people are laying on, they're rubbing them into into those black decks. Okay, this door here is the door that gets closed if you want to seal off the forward area and turn it into kind of a crew area. Head right here. Okay, this is another one that was having the same issue with these hatches that were leaking. They don't leak anymore, but see how all this water's come down over the years and it's ruined these, and it's stained the mirrors. So you could change the mirrors in here and solve that. The toilets, they all flush the same way. Push the left-hand button. Toilet fills up with water. Once it's full, push the right-hand button, and then the toilet will flush. Okay, showers. All the showers are basically the same. The left hand counterclockwise turns the water on. The right hand clockwise is colder, counterclockwise is hotter. So we're going to talk about the hot water system when we go into the next room. But this one right here, this whole shower tends to run hot. It's not like scalding hot unless you turn this counterclockwise. But when this is turned clockwise, it's still just a little bit too warm, and so thus it is. And I thought about changing it. That was my plan, but I mean, I don't know how you get behind all this marble. I don't know exactly what they had in mind. Maybe there's an access hatch. Yeah, you might be able to do that. Anyway, yeah, in fact, that's it. That's the access hatch. I'm waiting to change that. So, okay, we come into the air conditioning in this. Now we're in the port guest cabin. The port guest cabin air conditioning also cools the port head. And then the starboard crew area cools the starboard head. And if you come in here, we'll come in there. Okay, so the aircon up here, push the upper left-hand button, and that's that. Turn it on, it's on. Turn it off, it's off. Okay, so we talk about aircon and hot water here for just a minute. Under here, right through here is the hot water cylinder, big hot water cylinder. There used to be 2 of them on the boat long before we got here, and a hot water circulation system. So there was a pump that just circulated the hot water through the 2 tanks all the time. So any tap that you went to, as soon as you turned on the hot water, you had hot water because it was a hot water circulation system. Thus, you didn't waste all of that water. And at some point in the history of the boat, the hot water circulation pump was pulled out, and the second hot water heater, which is under the galley near the engine room side, was also disabled. So they just kind of like coupled the pipes and left the system like that. So the hot water system, it all still works. It's just fine. But what happens is that they end up this hot water system under here, this hot water heater under here, which I think they call a boiler in Europe, so we keep our terminology. So the boiler that's under here is actually running the whole boat. I think it's a 3 kW element that's in there. And so if you ever have to change the element, you turn off the water pump. To turn off the water pump, you open the forward hatch of the engine room, and then there's a fresh water pump straight down right there, and just take off one of the wires to the pump right there. They just pull apart. They're all very simple. And then the fresh water is off. Then you can run a tap someplace till the water itself is depressurized, because there's a little reservoir nitrogen bag. Then you lift up this mattress and lift up this end piece right here and fold the mattress back, and then you'll see that there's an element on the end of the water tank, and up against the wall in there, up against the wall right over here is a big socket, and you just put a screwdriver in the socket. It's a socket about that long, just made out of pressed metal, made for very light duty, such as what we're doing here. And you unscrew it, and out comes the element. The element is one of the elements that folds in half on itself, and that's very important because there's not enough room to get through the forward bulkhead right there. So we just and then that's it. You change the element, and you're done. The aircon system all throughout the boat. We'll do aircon on an individual because I've got a couple other things in aircon, so we'll keep the tape uniform. Okay, so we've covered the aircon. Same thing with the hatch right there. It was leaking, and of course it didn't have as much damage because it's farther back in the boat, and they don't leak anymore. So that's that. Okay, this room here we're just kind of using as storage right now because we're moving everything back on the boat. About the only thing to know is that around this corner and up there is the aircon switch. Open up the cupboard, reach your arm up there, and that's the aircon switch. And you get to the air handler here by lifting out this mattress, and it's right back in that neighborhood. These bunks right here, they just lift out. See, you just pop it open like that, and you can slide this board right out, or you can keep the board in if you have a reason to have a bunk beds. And what's up top here is the other bunk bed, because we've got one of them out. The whole time we've used the boat, we've always left the bunk beds in. Another thing, these lights here in both cabins have 2 switches. See, it's got a switch here. Yeah, that was funny. Did you see that? And now it doesn't go on. Oh, there it goes. Anyway, this switch here and that switch there both have to be in position. That's funny that just went. I'll tell you the whole system. We'll do it over here instead to demonstrate. Okay, so you can turn on and off here, or you can turn on and off here, but see, they both have to be in the on position or it won't work. Okay, so now we come here. Up under the floor, up in. Okay, if you lifted up these floorboards right here, you'd look under here and you would see a little watertight box about that big with a relay in it and one on that side. Those are the timer boxes for the pumps. So if the gray water reaches the high level, it turns on automatically and runs for 5 minutes, and that's where the timer is. If you ever had to reset that or play with the contactor, been totally dependable. Never had to mess with it. Under this floorboard here, actually I can lift this one because this is quite easy. Under this floorboard here is a whole pile of stuff. Okay, these are the hydraulic winch controls for forward, and so this is like the roller furling for the mast, the roller furling for the 2 head sails. So there's an in and out. The roller or the windlass control also goes through here. Just on the other side of these are shut-off valves. So if you did have like a hose pop or something, and you wanted to continue to use the rest of the system, you could shut off these. There's a set of valves right under here. You could shut off these. The way these hydraulics work is that there's one for pressure, one for volume. The volume controls the speed of the device. The pressure controls the stall force, and so you kind of want to balance those for every device. They're all set right now. Nothing has to be changed. We never mess with them except when something isn't quite right, and then we mess with them and then we never touch them again because it's all very dependable stuff. And it's all set right now. This down here is the connection box for the mast. So when you're turning on a switch at the nav station and trying to, let's say, get a light on the mast to go, that's the next spot that you can check for voltage. B&G instrument packs right here. Another one of these 24 volt. Another one of these little 24 volt breaker panels that kind of does the forward end of the boat. Here's another 24 volt breaker panel. So you get a couple sets of breakers right there, and they're all on and should always be on. So if something's off in there, then it probably tripped, because all of these are always on. And let's see, anything else in here these kind of bigger hoses that are wrapped around, those are the single pressure, like the Vang, for example, and you'll find them in other places like the running backstays. But these are this particular one right here is the Vang, and so not much else to say about this little area right here. Watertight door if you ever had to close it. The hatch is right there, and these guys here. And when I talked to Hope, the designer, he said that if you had a breech forward, that this door would hold and keep the boat afloat. If you had a breech aft, then between this door and the aft bulkhead, it probably wouldn't keep the boat afloat. So it'd buy you time, but you wouldn't be able to keep the boat afloat. But the forward section would stay afloat. So the area that we're walking into right now is the area that is the only area of the boat that you really absolutely must keep watertight. Underneath the floor right here are another bilge. There's a bilge section there, which is the forward crew. Bilge section here, which is labeled Salon on the manifold. Okay, we've already talked about the navigation system. Underneath here are just general spare parts. Underneath here, spare electrical parts. Underneath here, blocks. And I think there's a first aid kit under there. Another first aid kit under there. Underneath here, food. Underneath here, filters. Underneath there, filters. Underneath here, on the bottom side, heaps and heaps and heaps of oil filters. Underneath that backrest, the fan belts, stuff like that, still engine. Underneath that back corner are a whole set of aluminum giant plasma cut wrenches. Next section over, food. Next section over, under Allison right there, are tools. Lots of all the mechanics tools are under there. Okay, we've already done the engine. We come into the galley. Underneath me right here is the fire pump, and so you're really going to have to kind of go over that yourself. We haven't. We probably should have done more with that fire pump over the year and testing and all that, but somehow we just kind of like slipped through. Anyway, there's a whole set of valves under here that you can either pump from the bilge and use it as an emergency bilge pump, or you can pump from the sea chest to make it into a fire pump, and and there's also a set of valves so you can backfeed one of the any of the bilge sections. So if you have like a clogged bilge foot, you can use a fire pump to repressurize, or you can to repressurize the bilge suction manifold, or else you can use the freshwater system. There's two ways to clear a clog to the foot. These here are the door to the engine room. I just point this out. It can close like that. Turn here, and it's all locked, and it makes it double silent. And so that then gives us access to this area here. Okay, so what we have here, if we've got enough light, maybe that'll help a little bit, and those are already on. Okay, so we've got the 3 chillers that just air-cooled chillers for the freezer, refrigerator. And then these valves here, see that they're labeled, and now there's a chart in the next floorboard over that tells what each valve does. So that's like kind of the starter kit to figuring out how the fire pump, what valve configuration to use for the fire pump in various configurations. This is a bilge pump right here. I know it's a little bit small, and that's why we use that's why every one of these, we've got 7, 8, 9 of these on board, something like that. And every one of them I put a Y valve on. The one under the sink has a Y valve, for example, and that one you can pump the engine room bilge, or you can pump the sink. So every one of these has a dual option. So it's kind of if you were taking on water, you've got a few more options. When we got here, they were pumping the whole boat with this little like pump that you would use in the cellar of a house with a garden hose that they stretched out the door and laid overboard. So it's so much better than when we got here. Okay, main cabin, master cabin. Inside of that locker is the autopilot compass, and I mention that specifically because on occasion people will come in and they'll pile all their stuff in there, and they may have like a metal belt buckle and it gets laid up against the compass. And so if you reach a scenario where you just took a bunch of people on board and you go somewhere and pull off from the dock and the autopilot doesn't work, or it seems to work but won't hold a course, that's the first thing to check, is to check and see what people have stacked in the up against the compass. Okay. Next to the mast right here, these are all the books. Air handler under there. In order to get to the air handler, you have to remove the bottom layer of books, stack them over somewhere. Then you can take out this bottom shelf, and you can take out this board right here. And also under right there is the repeater for the Wi-Fi. So the Wi-Fi signal repeater that you activate from the navigation station has a PoE, power over Ethernet, an Ethernet cable. Power is a little gray box right here that hooks up to an antenna, and under the floor goes up the mizzen mast right here. Mizzen mast, not a whole lot to say about that, except there's the ironing board next to it, and we keep spare power cords next to it also. This one over here, just a kind of a general purpose locker. Normally we keep a few uniforms and jackets and old table covers and stuff like that in here also. Okay, under the floorboard right here are spares and more spares. Underneath this floorboard are more spares. This is more, under this one right there are the spares for the pumps, all the check valves and the bilge pumps, that type of thing. Right here underneath is the battery to the generator. Remember I said the generator needs new cables from the batteries to the generator. And this is where the cables start, and the generator is just right there. And they've ran these cables, it's just on the other side of the wall right there. I can almost touch it. Because this is that's the back of the engine room right there, and that's the generator jammed in there. So really that cable should only have to be so long, and instead they've ran that cable all the way up forward, there, under, and all the way back through the engine room. What's that?
Break.
Break.
Break. Just for
So,
Oh, I see.
break.
We're back. Okay, so we were talking about the battery to the generator is right up under here. You get right up onto that corner right there, and there's the power pack, the pump-up power pack, that could do SKF fittings, and because we've got an MTU engine, there'll be SKF fittings on it somewhere. And but we've never had to do anything to the engine. But if you did, if you needed SKF fittings, that you might be able to use that as a power pack. You can also use it to power the winch lift. The mast lift. So the mast has 65 tons of preload in it, and in order to set the rigging, you put these cylinder rams underneath the mast. Now, over the years, somehow they've lost their cylinder pumps, but the pump is still there. I've never actually pulled it out and saw if it was still in good nick or anything, but it looks like it's all there. Right under here, right about where my foot is the radar connection box and the mast connection box. So we've got the mizzen mast, and again, there's all the wires that come from the navigation station where you push, like stern light, for example, or boom lights. All those send power to the box. It's under my foot right there, just straight 24 volts, and then the 24 volts has a connector right there that connects through a stack of wires to the base of the mizzen mast and up the mizzen mast. And so and because that's one of the projects that needs to be upgraded on the boat. So if you were trying to fix that, then what you would do is you would come over to this mizzen mast box and first verify that you've got your 24 volts into here, and you'll see all the wires are old and deteriorated. So they could all be cut back, or however you decide to tackle the project. Right under my feet right here is the bilge pump control box. So there's a relay, so when you turn on the bilge pump, when you turn on the bilge pump, there's a relay, and that relay is located directly under my feet right here. Underneath this bed, there are charts right up under here, stacks and stacks and stacks of charts, like for the Caribbean and all that. More charts up there for the Caribbean. MTU spare parts is like a spare head kit and such, if you have to like pull a head for some reason. That is up about under there, and over about here there's another 100 meters of spare halyard line. So if you ever have to make up a spare halyard for some reason, that's where your line is. Okay, now we come into here. So now we're into the master bathroom. And okay, so if we look under this floorboard, these are all the hand power tools. And then there's a stick right here. Normally I point at this from the other angle. Okay, so this is all the hand power tools under here. And there's grinders and drills and all the basic stuff that you would need. There's a Dremel, there's a caulking gun, there's just stuff, lots and lots and lots of stuff. But all hand tools, nothing exotic under there. But I think there's 3 buzzy blocks under there that we use for patching the paint. And half of it's probably going to be 110 volts, and half of it's going to be 220, because some of it we end up doing when we're in the Caribbean. Okay. Bathtub. This is just awesome. This is like one of the best things of the whole boat. This is a good boat, but this is this is really good. Well, I've taken so many baths at sea. I never thought I would, but we've got a big water maker, and this bath actually fits 2 people quite nicely. One person with their back there, one person with their back there, and it's just kind of a little area of luxury. And so, a couple things about it. Same thing as the other one. Unscrew this, and the water goes on. Screw this one in, the water gets colder. This one here, again, it's one of those that tends to run really hot. So if somebody's going to take a bath, they throw this one, which runs cold, and they just lay it in the bottom of the bath. This is the pump out. And a couple things to know about that pump out. Actually, that's kind of worth mentioning. One of them is, if you come around this way and look at this piece, this right here looks like one of those air brakes, one of those vacuum unlocks, but it really isn't. So if you're sitting in the bath and you turn down, like let's say you sat in there long enough that the water's kind of gotten a little cold and you want to reheat the water, you'll pump out a little bit of water, put in some hot water, and continue hanging out. But if you did that, and let's say you slid over and sat on top of this, I think it would give you a giant skin burn, because this is connected directly to the pump. And this looks like an air brake, but it isn't. It's this is actually where, see that? That's actually where the water comes in to fill the bath. And so, so what effect that has on you is, if it was me, now that I've discovered that, I would put in a little air brake in there. I don't know if air brake's the right thing. Vacuum brake, maybe. Anyway, it needs something so it doesn't suck the skin off of your foot if you lay an ankle down in there. This boat is calm enough that it's a good enough boat and stable enough that I took a lot of baths crossing the Atlantic both directions. It was just awesome. In the middle of the day, you just come in here and hang out, and you got nothing but time because you got days to go. So anyway, that's it for the bath. It's got this right here opens up, and you can have the mosquito netting or the privacy curtain if you want, and then that opens up. And this one I don't think ever really leaked, so it didn't have that issue. One of the things, all these hatches that leaked, they we'll talk about when we talk about hatches, which I probably should do. Oh, okay, another air handler under here. So this cabin has two air handlers. It's got one under here and one under there. And so here's the vents, here's the suction, air handler behind the this little wine cabinet under there. Also the life preservers and such are under here. Is that the table cover? Oh, someone's looking for the table cover. Put that right there. Yeah, found the table cover. Okay, and so it's got a bunch of life harnesses under there. That's probably about it.
Yeah, cut.
And then hello. We're back again. This time we're going to talk about the main mast. And what we're going to talk about is what's inside of this mast between kind of here on deck level and right about there where the sail itself is rolling in and out. So first thing I'm going to talk about, I see these cheeks right here. Okay, those cheeks come off. In order to adjust or deal with the barrel, there's a set of cheeks at the very bottom and there's a set of cheeks at the very top. And you undo those, I don't know, 8 bolts or 8 screws or something on each side, and those cheeks then sometimes need a little tap with a plastic hammer, and you can slide them right out. That gives you access in here now, where there's where the tack of the sail ties on. It's lashed down with some Delron line or Delron. Jeez, getting on my terms here. It's lashed down with some high-tech line. Just about anything will work, but make sure you got a lot of them and a few of them over themselves, so that when you crank up that sail, because they have had at some point in the past, one of the somebody lost control of this sail. I just saw an insurance report about it, like it's 10 years old or something. The tack came loose, and in trying to get the tack, they lost the clue, and the whole sail came out the top of the slot up there, and was banging around, just hanging by the head. And I think it was quite traumatic for everybody involved. So when you look down at the very bottom of the mast, right about here, coming up through the very bottom and center of the mast, would be 2 hydraulic lines, a in and an out for the sail, left and right, rolling it in, rolling it out. And there's a hydraulic motor, about where my foot is, right there. That hydraulic motor has a flow control and a pressure control. The flow control controls the speed that the sail rolls in and out, and no reason to change that. I think it's at maximum right now, and in general, once you get used to the sail, there's no reason to slow it down going in or out, because basically it's just taking up time, and so if it rolls in faster, that's all the better. Next we have right here, I'm pointing with my toes, we have a selector. that selector controls whether or not the furling drum rolls in with a winch handle that would be put in, let's say, here, or through the hydraulic motor. And so you would control the selector right there. The only time you would ever reel this in by hand is if you lost your hydraulics and were trying to get the sail in. And then they give you a selector so that, of course, you can't have a winch handle in and while somebody pushes the activation button and have it all take off. And well, you can imagine what that winch handle would look like spinning. So at that point, now we've got a hydraulic motor running through this little kind of gearbox right here, and that's all that is. It's just a gearbox, whether or not the input from the shaft coming from below or the input from the shaft that the winch handle connects to transfers the torque. Now we start to get a little bit more complicated. Under this panel right here is a worm drive. So we have a box here connected with a little universal joint, which is it's not so much a universal joint as more like a Lovejoy coupling. So right about here there's a shaft and a little rubber bushing between them with 3 fingers from each direction that are interlocking through this rubber coupling. Right here now we have a set of gears that's attaching to the bottom, the top of the box, and the top output gear is attaching to this extrusion right here, and of course it's all done through a worm gear, and the reason it's done through a worm gear is so that if you lose power, the sail itself doesn't just spin out and roll itself out. So now we have hydraulic motor switching between winch handle and hydraulic motor. Now we've got a gearbox here that goes to an actual universal joint, which is about here, and then the universal joint goes to a coupling that couples into the bottom of this extrusion. Now that's how the extrusion gets spun back and forth in and out. There is kind of a you might even say a hokey connection between that universal joint and the bottom of that extrusion, and it's just kind of like 3 keyways that are laid flat against themselves and bolted together. And when we got on board, that was slipping, and we took it all apart and and put it all back together with new gear and new bearings, and it's been fine ever since. So I guess that just kind of gives you a head start. We can normally roll in this sail upwind, downwind. Like we don't really change course to do the sail, which is just to reel in and out the mainsail, which is just great. If you got too much wind blowing the mainsail against the spreaders up there, yeah, then you have to roll. Then you have to round up a little bit. And so basically, what I do when I'm reeling in and out the sail is I keep an eye on that bottom line right up here, and I make sure that it's going in or out, so that because if it isn't, then that means that you're probably stressing the system a little bit too much, and that's the time not to crank up the hydraulic pressure, because the whole idea is that the hydraulic pressure limits the ultimate amount of force, and so that the whole furling system can be put under. And the idea is that if you can't reel in the sail with the amount of force that you have on with the hydraulic motor, then something needs to change. Probably need to round up just a little bit and get the load off of the sail. When we look at that mainsail right there, see how much that's rolled in right there? That's rolled in quite a bit, and we keep it rolled in like that because the sun, of course, is going to destroy that sail during the whole time it's just sitting around. And so if the sun is beating on that sail, well, now there's a little bit of sun protection right there. If we're going to go out, the first little bit of that we roll out the sail, you have to let out a little bit of sail, hold the out sail, mainsail button for like a half a second, just whoa, boom. And then take up tension on the out haul right here. All this is done from the forward end of the middle cockpit of the main, the middle cockpit. And that pulls out that sail just a little bit. Once the sail gets out about a meter or so, then you can just hold the out button. And then if we're using the boat, we're going to be out for 5 days or something, and we're sailing every day and all that, then I don't reel her in nearly as far as she is right now. I leave about 1.5 meters of this sail out, so that the so that instead of here that the out hull is, the out hull would probably be sitting about here instead, about where my hand is. Not all that much more. I mean, it's not like it's going to catch a bunch of wind and everything. It's just that way. Oftentimes the deckhand or the owner, or people who aren't like going to be just watching with a hawk's eye how that sail rolls in and out for the first meter. Because the danger is that what would happen is that somebody would hold the out button too long and start to unroll the sail inside of here, but it's not coming out the mast. See, and so then what you end up with is a giant tangle right up in here of unrolled sail that you can't really get to, and that would be kind of like one of those ultimate disasters. Not ultimate, there's much worse that can happen with because to kind of give you a little rundown, most boats, like see that one next to us there, see, they don't have an in-the-mast roller, they've got a in-the-boom roller. And the reason people have gone to in-the-boom roller furling is because when it does jam, and they do jam occasionally, jam the first day that we took this out, or if it does jam, then at least all the problem is in the main boom, where it's kind of down on deck and somebody can get to it, and you don't have to go way up there. So we had a jam on the very first day, and what happened was somebody had a tag line that they had tied off at the top of the mast, and it got tangled up in the barrel. And I think that was actually a rigger who came out and had left it like that. And so then when we rolled out the sail for the first time, then the tagline got tangled up in the barrel and locked the sail, and it was stuck halfway in and halfway out. And so what we did was we took the boat and put her at anchor, and then went up to the highest spreader up there and took a line from the base of the spreader and went out and around the jammed sail and back to the spreader and kind of got a braille on her, and then moved to the next. Came down to the next spreader down and started working our way around, just getting lines around the main until we had her all tied off. And then once we had her all brailed up and tight and tied off as best we could, then we brought her back into the dock and waited for a really calm day. Then went back up to see what the problem was, and that's where we saw that this tagline, you couldn't see it from the deck or any of that. I only mention this so that if such an unfortunate situation were to happen to you, that you would have an option for what to do. Another thing that I should mention is this line right here really doesn't have a grippy enough cover so that these jam cleats here dependably stop the track from going left and right, and that's why there's a knot right there that we see, that knot right there that we leave. I'm trying to see this little screen with in the bright sunlight out here, so if I'm not pointing, if the camera work isn't all that great, well, that's what's happening. Just trying to get this all done so that hopefully we'll pass some of this knowledge along to whoever's lucky enough to take over the old Aphrodite here. So a few ways that we've considered correcting that. One of them is put bigger line in there, but unfortunately this track was kind of a change out. This all happened before we got here, but somehow they didn't quite get it all right. So that point right there won't take a bigger line than 14 mil, and that won't take a bigger line, whereas that right there won't take a bigger line. This little 180 won't take a bigger line than 14 mil either. So because of that, we can't really get a bigger line in this rope clutch right here. And so the other option that somebody might consider is finding a different line, a line that's got a really grippy, kind of like a softer cover. The rest of the whole main sheet has worked just fine. Make sure that you try to use the right hand, the high-speed button on the winch, on the main sheet winch, because we get a lot of times, I get people that are doing things like trying to keep the boom from sliding around, for example, while just wiggling while we're at anchor, and they'll take that main sheet winch over there and they'll crank it down on the 4-to-1 on low speed. And I mean, we're talking like, I don't know how many thousands of pounds of pressure, but there's a 4-to-1 here through a reduction on the winch. Well, that's quite a bit of pressure going. Excuse me. And all that pressure, of course, goes down into this vane. So we might as well talk about this vane for a minute. This is a a standard Lumar vang. You've probably seen these around for years if you're dealing with the boats, if dealing with the kind of this size 90-foot boat or so. But if not, we'll give you the quick rundown. The inside of the vang has 600 psi of nitrogen. So what's actually keeping the boom from going down is a nitrogen pressure in this area of the boom. So we got nitrogen pressured here, then about there we've got about here we have the end of this stainless piece right here, that stainless piston, and so the pressure that comes through this hose, let me get around to it. The pressure that comes through this hose right here goes into this black area through the center of this stainless and comes out, and the pressure is what's actually pushing or pulling the boom downward. And so the pressure pulls the boom down, which of course goes out through the end of the boom and tensions the leech. So you use the vang to control sail twist and the tension on the leech of the mainsail. And if you release the pressure, if you release the hydraulic pressure through this hose, which you would do in the port aft corner of the aft cockpit through the NavTech controls there, then the pressure, the nitrogen pressure in this area is what actually lifts the boom. And now this has the one big advantage is that when somebody does crank down these main sheet lines too much, the vang is actually able to compress a little bit, and so that's kind of the good thing. If you have to take apart, so that's a protection there. See it? There's a little bit of cush in there that helps us. Okay, if you have to, for some reason, take this vang off, like right now, this inner rod probably wants to be changed, and that's why I got a little rag there, because it's got a little leak going. The vangs have to be done by somebody who can repump up the nitrogen, so it's not something that a really crafty person is going to do on their own nearly as much as, let's say, those backstays back there that just have air pressure in them. They've got like 120 psi of air pressure that goes in that little point right there. Let me see if you're seeing that. Yeah, when my foot's touching right there is a little valve. So that's kind of a different animal, even though they all come from the same group. Okay, so if you did have to take off that vang, you would have to use a topping lift. So you'd put a topping lift on the end of the main boom. And in fact, if even you ever have to disconnect these hydraulics here, the riggers tell me to make sure that you run a topping lift onto the end of the main boom anyway, because there is, see, the bottom side of this vang could be holding just due to the vacuum. And so let's say that this 600 psi of pressure in the top half of this vang now has leaked out, and now it's down to let's say just enough that with the top half of the lowered nitrogen pressure and the vacuum effect of the piston, the boom is just barely able to hold itself up. And then let's say that you disconnect the hydraulics, and then the boom drops down. You can pull that boom hard enough to hit the bimini when the vang is all going just right. Mainly, it drives that preventer. That right there is what we use as the preventer. So let me just get to where you can see that. So you got to get the boom over to one side, otherwise it wants to sit here and rub. In fact, you can kind of see there's new stitching right here. That's when somebody cranked the winch down once on the with the preventer still kind of attached. Oftentimes we'll run the preventer to this cleat right here if we're going dead downwind. We'll run that preventer way forward, maybe all the way up to a bow line up here, and so that's I guess that's about it for the mainsail. I'm just winging all this here, it's not like making up a script or anything. I'm just kind of rambling and chatting a little bit about what I see, and so that hopefully you can watch it once, and then if you kind of get stuck, then you can do it a second time if need be. These little covers right here, these are covering the axles for, let's see, if you look up under here, see there's an axle right there. See that? What I'm touching right there? That one doesn't have anything on it, but still, that's the cover plate right there. So that little cover, like this one here. See, there's these sheaves right here, and under the sheaves, if you wanted to remove those sheaves, you'd pull one of these cover plates, and then the pin comes out. I think that's about it for what you would really need to know about the mainsail. Good luck with it. I'm going to give you just a quick rundown on this reaching pole right here. So this is the reaching pole. It goes up and down. It's all kind of basic standard stuff. It's got this little line right here, and then it's got this other yellow line that comes out of the mast. Okay, so that's the lift right here. See that line that I'm dealing with? Okay, so that lifts up, and then there's another line that comes out of the mast right here. Okay, so now I'm touching that one right there. So you put that line on the winch, kind of as it is right now, and that's what lifts the base of the mast side of the spinnaker boom in and up and down. So let's say you took that spinnaker boom all the way down, so that the spinnaker boom or reaching pole or spinnaker pole, as all these people have different terms for it. Let's say you took that spinnaker pole all the way down, and you put a topping lift here, and we use this red line right here. See that red line right there? That comes out of the mast up there. See that? Kind of just above the middle spreaders. Okay, so there's a red line there, and that you clip onto this point right here, and I'm going to talk about why that is, and not here as intuitively anybody who's ever done a spinnaker pole would be saying, no, it's there. Okay, so you clip on, you take the boom, you put it out straight. This is how we do it, and I'm sure you'll come up with your own system right here. We take this boom, we lay it out straight on the side that we're going to use it. So now it's out past the head stays. We put up a topping lift. We put a topping lift here. Then we pull this pin, pull that pin. So we pull the clevis pin, pull the actual clevis, or pull the actual the pin. Then when you pull out this extension right here, it pulls way out, and it has to flip over 180. It's kind of like they got the hole wrong somehow. Like this hole is a little bit off center, so this part of the boom then has to flip over 180 degrees for that pin to go back in. And once that's done, then you can move the topping lift from here to here. Fore guy, after guy on these right here. Clip that line around the jib sheet line, and pull that end kind of towards the knot right there, and that's it. You're going downwind. And one of the tricks that we used to great effect was pushing that jib way the sheet line of the jib, and where the pole goes way forward, and kind of getting the wind, so it might even be like 20 degrees off the starboard side, and still have the jib sheeted on the starboard side, and pushing the end of the pole way forward to compensate, and that would kind of allow us to, well, build up a lot more speed. We'll go from 8 knots to 10 knots pretty quick with that little trick. So I just point that out as something that we kind of stumbled upon. And the end of this right here, you give that a yank, and this snaps open right here. It snaps open on its own a few times. It's 90% secure, but I certainly wouldn't trust I wouldn't trust everything to it. So that's it for spinnaker pole. Hello. So now we're going to talk about the Aphrodite rig. So if you've been following these Aphrodite yacht work videos, what they are is a series of videos I'm trying to turn over the information that we learned about Aphrodite to the new crew who comes aboard. So what I'm going to talk about is the rig and some of the different kind of discussions that have happened over the life of the boat, and the decisions that we came to, and the reasons for those. So first, we have a catch rig. A catch rig means that we've got 2 masts. A split rig means we have 2 masts. A catch rig means that the aft rig is shorter than the forward than the forward rig. In this case, we have two rigs, the main mast and the mizzen mast. I only say this so that we kind of get a, so we're all using the same terminology. So the first thing that normally people look at when they come to the boat is they see that we've got hydraulic backstays, hydraulic mizzen backstays and hydraulic main backstays. And so the question people often have is, how much do you pump up the backstays to, and occasionally why? And so I'm going to cover those two first. And a lot of this is because there has always been a lot of controversy about whether or not this boat should have a triadic. A triadic would connect the top of the mainsail to the top of the main mast to the top of the mizzen mast. And so the idea is should there be a triadic on the boat? And we went through a lot with this, talking to the different riggers, the riggers who have worked on the boat, going through the history of the boat, and they've had a triadic. They've taken the triadic off. They put the triadic back on. They took the triadic off, and that's where we are right now with the triadic off. Well, after researching it, it's quite clear to me, and that's what brings up the hydraulic backstays. We have a hydraulic backstay here for the main mast. The hydraulic backstay tensions the backstay, which really all that does is tensions the headstay. So the headstay gets more tension. So if you're sailing the boat to weather, for example, then you're able to tension up the headstay and have a tighter headstay, which allows the boat to sail to weather more. Normally when we're sailing to weather, we normally sail to weather at 40 degrees apparent. That's kind of a really good slot for Aphrodite. And 35, we don't really seem to make any extra progress if you actually look at your velocity made good. Because the boat starts to slow down, she doesn't punch through the waves anymore, but at 40 degrees she's really sailing hard and quite efficiently. So pump up the backstays, tighten up the headstay. You get into port, you slacken off the backstays so that the rig isn't under as much tension while she's sitting at rest. So that's all pretty straightforward and common sense. The mizzen, on the other hand, also has hydraulic backstays, but the mizzen hydraulic backstays are for a totally different reason than the main hydraulic backstays. And I think a lot of people have missed this over the years with the boat, and just kind of looked at the backstay and saw hydraulic backstay, and kind of left it at that. So that's kind of why I'm trying to bring this forward, so the new crew will pick up and understand what we're talking about here. The mizzen, or let me go back one step. A ketch versus a cutter. A ketch has kind of a large mainsail, but not that large. A cutter is, of course, two headsails. A large mainsail and a mizzen. And a cutter would have probably a 25% larger headsail, staysail, mainsail, and no mizzen. So if you're sailing a cutter, you would, and cutter, I love the cutter rig, by the way. If you were sailing a cutter, for example, you'd be sailing along, and you would set, from the heads, you'd set your headsail. If you had the staysail up, you'd set your staysail and your mainsail for maximum efficiency, maximum push, maximum sail drive. Then you would go back and look at the rudder angle indicator. This is how we do it anyway. We go back, we look at the rudder angle indicator, and hopefully we'll have a 0 rudder angle, or maybe 2 degrees to leeward, so that we've got a little bit of weather helm, something like that. And if you let go of the rudder, she'll slowly round up and the sails would flop, and that's kind of the safety factor. And if she takes a big heel over, she'll round up. What normally happens is, though, you set the 3 sails for a maximum drive, and you go back and we'll look at the rudder angle indicator, and she'll be at 9 degrees, she'll be at 12 degrees, she'll be cycling between 9 and 12. On the bigger boats, rudder angle indicator is really what we look at. It's not so easy to kind of feel the wheel, and you know, we're going for days on end, so it isn't like somebody's out there hand steering. So you come back, you look at the rudder angle indicator, and you say, oh, 9 degrees. Oh, okay. So now you have to make a choice. You have to make a choice about whether or not to allow the inefficiency of the rudder, which is an increased drag through the water, which is a lot. You know, you think about the size of a rudder, 12 degrees, pulling the whole time. It's a lot to drag through the water compared to having the sails set for maximum efficiency. So then what happens is, or maximum drive, so what happens is everybody always kind of goes through the same thing. They start slackening the mainsail, maybe. They start sheeting a little bit to try to get less rudder angle indicator, a little less efficiency on the sails, and therefore we have basically what you would call a boat race, because that's one of the big things in yacht racing, is trying to make the decision. Are you going to reach the finish line faster if you have the higher rudder angle indicator but less drive or perfect drive in the sail, or less rudder angle but less drive in the sail? A ketch rig is different. A ketch rig, you set the jib, if you're running the staysail, and the mainsail for maximum drive. Then you kind of sacrifice the mizzen for an air rudder to set your actual rudder angle indicator more down around 0, or as close to 0 as you can get. So all of a sudden we've got a mizzen that has two functions. It can be driving us to weather, but it also can be running, which then would be draft in the sail. But at the same time, it may be using as an air rudder, in which case we no longer want the sail driving as much as we want angle of attack. Angle of attack means that we want a flat sail. Draft means that we want a driving sail. We want curve in the sail. So then the question becomes, how do we have both options on the mizzen mast? And that's where the hydraulic running backstays come in. We want a flat mizzen at times. So if we want to use the mizzen as an air sail, as a kind of as an air vane, or we want to. So now we're back to the point of whether or not the mizzen is going to be an air vane or whether or not it's going to be a driving sail. And who's ever skippering the boat at the time has to make that decision. So if you want the mizzen sail as a driving sail, then you really slacken the backstays and kind of use your outhaul on the mizzen to adjust the draft of the sail. On the other hand, if you want an air vane, if you want to really flatten the mizzen, that's when the mizzen backstays come in. We start to tighten up the mizzen backstays, and the mizzen, if you notice here, has a forward leading stay here, another forward leading stay here, and a jumper stay. We put tension on the top of the mast bends between this upper stay and this lower forward leading stay, and the mast will get a nice curve, a really nice beautiful curve. Main won't curve at all. You can tighten up the backstays as much as you want. It's not going to curve anywhere because it's all compression. Whereas the mizzen is specifically designed to get this big bow, and the bow then causes the front of the mizzen mast to move forward, and it sucks the belly out of the mizzen sail, and then the mizzen sail goes flat. So what that means to you is when you're sailing the boat, if you want to use the mizzen as an air vane, then you pump up the backstays. That flattens the mizzen sail. Tighten up your outhaul right here. Crank up your mizzen hydraulic backstays, and the forward center section of the mizzen mast moves forward. It sucks the belly section right here out of the mizzen. The mizzen goes really flat, and that might be, to give you a few examples of when you would use a really flat mizzen. You would use a really flat mizzen if you were sailing along and you wanted to set the boat so when she starts to fall off the wind, the mizzen catches air but doesn't drive. You could use a really flat mizzen if you were sitting in an anchorage and the boat was rolling. We do this a lot, so remember this one. If the boat's sitting in an anchorage and rolling, then you put up the mizzen sail, sheet it really flat, and then you can use the track to kind of set where the boat itself is going to point. And oftentimes you would have things like maybe swell refraction, where swell is coming around a point, and so the swell is hitting the boat broadside. Well, meanwhile the wind is still coming straight down the coast, so now we have kind of a rolly boat, and nobody likes a rolly boat. So we can set up the mizzen, and we can use the mizzen and start experimenting with it. Sheet it to starboard, sheet it to port, and use that to change the angle of the waves that are coming around the point to stop the boat from rolling. And of course, the sail itself acts as a dampener, so we get two effects off of the mizzen. There, we get one where the mizzen sail itself has to cut air and slow the boat roll, and then we got the second one where the mizzen itself is changing the angle of the hull to the waves. Well, let's see. I'm just thinking if there's anything else. Oh, the running backstays. Okay, one last thing to cover here. We have running backstays that come down. There's another one where people always say, when do you run running backstays, and are they really necessary? Running backstays in this boat, we tend to use them 2 times. We use them either if we're running the staysail. So now you see we get a triangle right here again, and that makes a stable point in the mast right here by tensioning up our running backstays. So and tension up the running backstay, puts aft tension on the mast right here, and at the same time the staysail comes up into the mast, and so the mast then becomes stable at the point of the staysail, where the staysail stay comes in at the head of the mainmast. And what effect that has is, let's say that you're sailing along and it really starts to blow. So you can roll in the jib, you can bring in the mizzen, for example. You might run this sail combination. Take the main, so that the main is rolled in all the way, so the head is maybe about here, 3/4 of the staysail, and then let the staysail out, and now you've got a good sail package, small, tight, right in the middle of the boat, good for about 40 knots of wind. But we need a way that we can control now the staysail is in effect working as the head sail of the boat, and we need a way that we can control the mast at that point. And that's what the running backstay does. The other time that the running backstay becomes really important is motoring in a seaway, or sailing hard in a seaway, where when you hit a wave, and you walk over to the base of the mainmast. I walk over to the base of the mainmast and I look straight up the mast. And what I'm looking for is movement between the head of the mast and the middle of the mast. And if I see the mast pumping when we hit a wave, that means that the mass of the mast is bouncing forward and needs to be controlled, because aluminum only gets so many cycles of use, and we're burning up those cycles for no real gain if we are letting the mast kind of spaghetti out and move up top, up in this area. So if the mast is moving up here, you run that running backstay. You might even run 2 running backstays, the port and the starboard, if you're just kind of motoring or running, let's say, a mizzen and a head sail, and just kind of like motoring through short chop. So at that point, you might use both running backstays, but normally I only use one. I run one running backstay, and that stabilizes the main in this area up here. Other than that, there's very little time that you should see any movement. If you see any movement going on in the mainmast, except in this area right here that you would be controlling with a running backstay, something is probably wrong, and it's a good time to start kind of glancing around. Another thing is when you're sailing hard, does the rigging go slack on the lee side? And it does not, except for the lower aft stay. And sometimes if you're really sailing hard, you'll hit a good wave, and you'll see that lower aft stay will slacken just a little bit. There's 65 tons of preload in this mast, so it's not like it's going to. It's not like those stays should come loose at any time, even when you're sailing hard, and the lee side shouldn't be going discernibly loose. If it is, that's a sure sign that something is up that needs to be attended to. Except for this lower stay right here, which does kind of slacken off occasionally. We've talked quite a bit to different riggers about that, and they all seem to kind of say, yeah, you know, that's okay. I think that is just about it for kind of what I wish somebody had told me when I got on the boat. I would have had a big head start on the rig, so I'm hoping that passes that big head start off to somebody else. Okay, now we're in the Port Lazarette. I'm going to talk loud because I'm talking over the aircon system. The first thing I want to talk about is the air chiller system, which is right here. And air chiller is this right here is what's making the cold water that's circulating around for the air handlers. This is the pump right here that circulates the cold air for the air handler. So this is the chiller loop right here, and there's a pressure gauge right there. Right now it's 0.9 bars. That's a good pressure for the chiller system. If that starts to go empty and you need to add water, listen to that. That's a normal sound of the compressor coming on. A little bit of knocking, and okay, so you hear that? That's what you want to hear. Okay, my hand right now under here is on the hose fill. So right there, you can put a hose on, and the hose provides the pressure, and you can pump up your air chiller system. So if you get a fault loop, chiller loop, anyway, it's the second most common fault in the air handler system, and it's a fault. And if you get that, something open, vent loop, I'll find it when we go down there. Anyway, you get that fault, that means you got to come down here, put the hose on right here, open the valve that my hand is on right there, fill up the system until you're like 1.2 bar, and then the chiller loop will run again. Not much more to say about this. It's been pretty dependable. The compressor over here, that compressor that's right there, is a 3-phase compressor. But back here is a slow start. Some people call it a frequency drive, some people call it a slow start, but that's where my hand, yeah, that's perfect. That's where my hand is right there. So that frequency drive takes that breaker right there, and that breaker drives the frequency drive, single phase, and then the frequency drive makes 3-phase slow start. Inside of this box right here is the brain behind the chiller, and that's about it. This pipe right here is the chiller out, and so one of the things that's happened is this is the air vent. See that where the little plug is, and so what happens is that if you don't have that plug in there, it fills up during the when the circulation pump comes on, when the cooling pump comes on, it pumps salt water and it comes out this and fills up this little area down this hose right here and drains out on the deck. And so because it always leaves like a wet spot on the floor, we put that little plug in there, and just so that you don't pull that plug and go through what we went through. Over here, my hand is on the water maker. So the water maker has 2 membranes that are right here. Here are the pre-filters, and back over there, inside of that bucket, and all back up in there are pre-filter filters. So you probably won't need a pre-filter for quite a while. Right now, I just leave this on freshwater flush. Oh, and hear that? That's the sound right there that you want to hear. That's the compressor shutting off. So nothing wrong with that knocking. That's the knocking that we want to hear. Okay, so if you get a fault in the water maker, you come over here to the front, and one of these is fault reset, and you actually have to physically come down here and click on fault reset. If the fault reset was low feed pressure, that means that these guys have clogged. If the fault is high pressure, then you go over to that black knob right there and turn it all back on and set that black knob at about 840 to 850. But that also means that your membranes may be starting to get a little bit clogged over here. So that's well worth kind of knowing. Okay, I think that's it for water maker. The other thing about water maker is in order for freshwater flush to work, this valve here is supposed to be turned all the way counterclockwise. So I'm turning it all the way counterclockwise right now, and then I'll push the freshwater flush. Okay, so I'm turning this valve all the way, and then now on the other side of the water maker, there's another one of these little filters, and that other little filter has a carbon. Okay, now I gotta see which of those. Oh, you know what? Maybe I can do it like this and read through the camera. No, you can't read it either, huh? Okay, by the way, all this oil right here is, we bought a stack of oil in the States before we left because the price was so much better. Okay, so it goes boost pump, fault reset, fresh water. So I'm just going to push fresh water and push some fresh water. Now, fresh water is always kind of a deal because there's fresh water has chemicals like chlorine in it from the dock. So it's best to use fresh water from the water tank that's been filled with your own fresh water that you made out of the water maker. Okay, that's the scuba compressor right there. We haven't really done much with it besides I've turned it on a couple times. It does build up pressure, so I think it could be made to work. If you build up pressure, then you undo this one here that lets out the water from the end of the cylinder. Then you let out this one, then you let out that one. Unscrew this top right here to change the carbon filters, and then this up here is what attaches to your scuba tank to pressurize it. Me, if I was giving a recommendation, I would say send the Bauer guy in and have him hook it up the first time, just so that you, because we haven't used it, but I've used a lot of those, and they're really good. They're really good compressors. Okay, so now I reach back here to the steering station. Okay, this up here is the bow thruster timing control box, and I think also the Honda Stott variable pitch prop is also run through here. Okay, that's the that right there. That ram is the big ram that is steering the boat through this little rudder connection right there. Oh, look at that. Every now and then we get just the perfect light. If I just hold my mouth correctly, you can actually still see. Okay, that right there in the center, which is rudder feedback angle indicator. So if anything goes wrong with your rudder angle indicator, you'll get a no feedback alarm, and that's the place to start. The white one behind it is the second rudder angle feedback indicator for the second autopilot. And on the wall, kind of over on the far other side, up there, see those two switches right in the middle of the screen right now? That's how you switch from one autopilot to the other. I've never had to do it. This is the normal pump right here that my hand is on. I know it's all dark, but I can see it on the screen, so you can probably see it. This is the normal high-pressure pump. And up under here, if you can just look up right in there, right in the middle of that inky blackness, is another pump. So there's two different high-pressure pumps. So if one pump goes bad, if this pump that is relatively shiny were to go bad, then right back up in that little black hole in the middle of the screen is another hydraulic pump. And then see those valves up here on top of the cylinder ram, right there and right there. Those valves can switch from one side to the other to activate one pump or the other. Like I say, we've never had to mess with it, so I've never touched it, but it's there. Now see that other valve right there, right in the middle of the screen right now. I'm going to pull back slowly so you keep your perspective. That's the bypass. So if you had to take manual control, like let's say that a valve's stuck and you wanted to just hand steer, then that's the valve. So so again, it's that valve, which is coming back right there. Okay, and all that is, that just connects the two sides of the ram so that you can. Some people call it a cylinder, some people call it a ram, so that you can steer manually. Manual steering, now right down here what my hand is touching, those are the two tensioning turnbuckles on the end of the steering cable. Steering cable's right here, and that's about how we've left it. See that? Just tension, but not too much tension, because most of the time you're steering on the autopilot, and so we don't want all these pulleys to be sitting there going back and forth endlessly for days. There's some of the pulleys right there just wearing out those bearings. And so there's also, see right there, I'm just showing you another block. That block, when we first got here, the center pin was out, and that block had fallen up against the housing and was just kind of sitting in there rubbing. It's the same block now that is not the big block standing up, but there's another block that's kind of hidden behind a little wooden box right there. And but other than that, this has all been very dependable. We've once we got the steering worked out, it's been quite good. I just I'm just going to say this. I don't know how people do this. See that block right there? That block had been out, with the center pin had been out for so long that the edges of the block wore through the aluminum housing and came out the other side. I mean, look how thick that aluminum plate is. Like, see that block right there is mounted into that aluminum plate. The edges of that block wore through that plate, just like this, but that plate right there wore through and came out the other side, which just amazes me that something can go on like that in a critical system for so long. But there it is. I just laughed on that one. Okay, so this right here, that little watertight hatch, this is the steering wheel right under here. And if you drop something underneath the steering wheel and it's down in that slot and you just got to get it out, that's the hatch that you would use. Looking up here, see these two little guys right here? That's a sim. That's some of your connections from the SimNet. So this right here is connecting. This right here is connecting the chart plotter up on deck to the GPS antenna. So if you go up there and you see no fix, then come down here, pull these out, and push them back in, and you'll probably get your fix back, because that's what we did. And finding that the first time takes absolutely forever. But now I've told you the secret. Those right there are the carbon filters for the freshwater flush and for the water maker. That's a Robusto heater up there that's obviously been disconnected and has been disconnected for forever. This right here is the back of the switching system that turns on and diverts like nav lights and deck lights, all that type of stuff. And that right there, that's that panel right there could use a rebuild. Huh, man, would that ever make life simple if that were all just fixed and working. Let's see, what else do we have back here? The rest of that's just storage stuff, paint and some fans and some other stuff like that. Okay, I think that pretty well covers this little area. I'm just looking for if there's anything else in here that you need to know about. And I don't think that there is. Okay, so that's the autopilot control brain right there. I never figured out what that's for. See, it just goes overboard, and it's like some little booster pump. That right there is some little booster pump or something. It just goes overboard. I never quite figured out where that goes. This under here, straight down there, is the that's where the bilge water collects. And I can see that there's a little bit of bilge water under there right now. We get a little bit of condensation from the air system. So, and I think that's it for this section. Then we're going to go to the other side. Just remembered one more thing as I went to get out. Actually, two more things. See those? That's the bottom of the winches right there. So electric winch, that's actually hydraulic winch. That's the bottom right there. If you need to get to the motor or anything, you can see all that stuff still in great condition. And I'm pretty sure it's just all original. Just wonderful, wonderful stuff. This right here, that's under the aircon, over the aircon chiller right there. And then if we look back there, see that wheel right there? So there's a wheel there, and then there's a little steering box right there. And this steering box, see how I can move it right there? Okay, this is supposed to slide out, and you're supposed to somehow stand up in this hatch with that little wheel right there attached to that steering box. And then you set the valves on the hydraulic steering. This would be like if you lost your autopilot and you lost your steering cables all simultaneously, and yet you still had your steering ram. This is an alternative method for steering the boat. And I'm not exactly sure how you would see after that, but anyway, I just pointed out, there it is. Okay, so now we're going to talk about the starboard lazarette. So we're going to start here. This is the Lumar oil tank, and this is the oil that the hydraulic system that is going to run the windlass, all the roller furlers, and the cockpit winches. Okay, so we've got various hydraulic systems on the boat, and so I have to be clear over what system does what. We also have another tank that's aft and in the center, which you can't see from there, that runs the hydraulics for the autopilot. Then we've got another tank in the port side all the way aft that is the hydraulics for the vangs and backstays and stuff like that. And that's a double tank. So if you go into the port lazarette all the way aft, you'll find a double tank. I know we're on the starboard lazarette now, but I want to cover this. That you go all the way aft, and then there's two tanks right there that are the hydraulic reservoir tanks. Somebody added a second tank, so you'll see there's one tank and somebody's added a second tank, and that's the reservoir for the hydraulic backstays, the hydraulic halyards, and the vangs. This hydraulic system here is winches, roller furlers, and windlass. This pump runs the windlass and runs the roller furlers sometimes. These pumps here run the winches. So this, I'm sorry, the windlass. This runs the windlass and the roller furlers. This runs the winches. So what happens is you want two different pumps, so that if you're paying out a roller furler, at the same time now you've got flow going to the roller furler. When you click the winch, you don't want the roller furler to change speed. So what happens is that these 2.5 kW, 3 kW, 5 kW. So really it's kind of a balanced set. This motor's been replaced. And so now when we got here, this 3 kW was working. This 2.5 kW, which is like brand new, straight from the factory, whoever first put it in tightened up this positive cable right here, over tightened that cable and spun the bolt and broke the connection, the solder connection on the back. And I don't know, nobody ever found it for all those years, because it was still all original. And some hydraulic tech was telling me that he needs we got to just buy a new one for like 5,000 euros or something. And I was like, okay, let me just look at it. And then we checked it the next day and found the broken wire, and that was it. It's worked ever since. So So what that did was, in effect, it allowed our roller furlers. Actually, these are the roller furlers here. I know that now because we got this speed up. So these are roller furlers. That's windlass and winches. And so now our roller furlers go at double speed, which now matches the winches, which is a great improvement. You can look at these little wires right here. These are the overheating wires. So if the motor starts to overheat, that's the overheating circuit. It's been disconnected on one of these two. It's been disconnected here. It's still connected here. I think this one here just got salt water on it, and like it kind of corroded the fitting. This one's still connected on the back, and it's this little, it's that little wire right here. These big cables come out of this box right here. That box right there, if you open it up, has some huge contactors in it, and then those huge contactors close and either run these winches, these motors, or this box has huge contactors in it which run this motor. And it looks like a lot of cables coming up, but you'll see they're double cables right there. So trying to get 5 kW. Here's 24 volts, and look at that double cable like that. It's got a fair amount. This motor right here shows you pressure right there. This right here is the suction filter with a gauge on it. So if you're in here and you hear someone using the hydraulics and that gauge, which is pointed kind of the wrong way, if that gauge, if you start to build up vacuum, build a suction when the hydraulics are running, then you know it's time to open this up and change or clean that filter. Inside of this box right here is the Lumar logic circuit. I don't think this will open. No, it won't. I need a key. But if you open that up, inside of here are all the wires that connect the winch buttons on deck to the Lumar control system. So if you ran into a scenario like, let's say you pushed a button on deck and the winch didn't move, then one of the first things you can do is go into the aft cabin and find the wiring diagram that shows what wire goes from the winch button that isn't working to the Lumar control pack. And then you take that and you can come in here and you can cross that, you can cross those connections, let's say 16 and 17. Let's just say, for example, that you went to the, because this is actually what's happening. You go to the port spinnaker winch next to the main mast, and one button works and one button doesn't. So you've got high speed but not low speed. So okay, so your first question is, in troubleshooting, is it in the computer, the PLC over here, or is it in the wiring somewhere, or is it in the bad switch? So you can come right over here and open up this door, and you can go to, let's say that you look and you on the drawing, and that's 16 and 17. You can come here and you can cross 16 and 17 and see if that activates the winch, and it should, because that's the same as closing the switch. So you close, I'm just grabbing numbers here, it may not be 16 and 17, but on the drawing, let's say it says that 16 and 17. Go over here, you close the switch, that'll tell you, that'll isolate whether or not it's in the wiring or whether or not it's in the Lumar system. So far, everything's been in the wiring. The Lumar has just been deadly accurate. And so anyway, so that's all inside of this box right here. Okay, I'll take the camera from there. Okay, so now another view of the water maker right there, just from the other side. That's the charcoal filter right there. And then that right there is the, see that one up under there? That's, I'm pretty sure that's the freshwater flush filter. That hose right there that you're looking at, this, that's the suction hose, air intake hose from the scuba system. See that valve right there, that yellow valve? That yellow valve right there diverts product water from the water maker, and you can flip that valve 180 degrees and then see this yellow hose that comes up to right there and is just stored right there. You can pull that hose out on the deck, and then that's a convenient way to fill your drinking containers. So you can get water maker, pure water maker water straight off the water maker, and you can stand in the hatch right there and activate that with your foot. See, so it's quite a although it looks like you got to climb down in this pit, you really don't, because that's a you can activate that from just with your left foot, and then have your hands filling the jugs that you're filling up to drink from. Okay, under here, see those valves right there? Okay, this is important now. Quite often, the gate that opens up to let people on and off the boat, the passerelle and the stern, goes through these connectors. And my toe now, I think it's the second one in. How's that? That's just dark, isn't it? Anyway, the second valve in is the flow control for the passerelle. And that gets clogged for some reason, or sticky or something. You'd probably be best off just to change that little valve, but what I do, because I'm never around, I'm always out like someplace with people on board when it's. So if you go to open up the passerelle in the back, and if it won't open or it won't close, we'll go over the closing. But you got to give it a little help at the very, very, very start. You give it a little nudge, and then it should close and open on its own. If it doesn't, if it goes like so slow that it's just driving you mad, or then you come down here, and that's the little connection right there. One for pressure and one for flow. And you got to be really careful with that flow, because that thing will close like a rat trap, killing somebody if you go too fast. It's got to really, really, really be throttled back. Okay, let's see. What do we got? This is shore power in right there. So that box right there. And I'll just kind of go around a little bit there. Okay, this is the back of your shifting cable. So if you ever lose engine control cables, this is where you go. That's the autopilot shutoff right there. So that's your autopilot shutoff switch. So those are the wires that you would be inspecting if you ever lost autopilot pump. Let's see. These are the sound system speakers, which okay. This right here is the directions for deciding on which autopilot that you're on. And then the autopilot that you would be on is controlled from those two boxes, which are right next to the Lumar box. I'm just trying to give you an update on every box that's in here, so that when the time comes, if you ever actually have to get in here and find something, you're going to be way ahead of the game, rather than just kind of coming back here and just trying to guess what everything is. This right here is a battery charger. That battery charger runs back in that corner. Let's see if we get some light. Okay. Okay, that wooden box that my light is on right there is storing batteries. Batteries, and I'm assuming the isolation transformer. I've never opened it. I've just but that's the emergency batteries that you can activate. Actually, that's the emergency batteries right there. Okay, see that? It's the emergency batteries that you would activate from the helm. One's going to be the batteries, one's going to be the isolation transformer. And that wooden box up there, I think, is part of that whole battery thing also. I never had to get into it, so I'm just kind of giving you the quick rundown. See that right there? That is the control for closing and opening the passerelle. And there's spare drive chains everywhere. Like I can't imagine ever using up one of those drive chains, and there are lots of them around. So they must have like 3 sets. That green box right there is the SSB. That's just trying to illuminate this with a pen light to you know, I don't got much time. I'm sorry for the quality here. I'm just trying to get you what I can. We normally get time to set this stuff up, but I'm trying to do this whole video turnover just like Johnny on the spot here for you. So that green box right there is the single sideband. That's actually the heart. That's actually the radio right there. What you see at the nav station is the control head, and nothing else. That's actually where the radio is working from. And that white box right there is the antenna tuner. So the antenna tuner way back there, and that kind of bright spot that you see in the center of your screen, that bright spot that I'm taking, that right there is that's actually the antenna coming out on the deck. This gray covered box right here, this is all your neutrals and grounds for the whole 220 system come together right here and out that black cable and attached to the hull. See that? Okay, what that means to you is you can go up with a clamp amp, an AC/DC clamp amp, and clamp AC and clamp DC. I do this a lot, probably like every month or so. every time I'm down here that I have a clamp amp around, I clamp that. And so if you have a leaking device, it's leaking current into the hull, that's the cable that it'll be going through right there. And that's the place to check, because that's all your AC systems come together into the hull, grounded to the hull through that black cable right there. Okay, so that's very important to remember that if you ever see corrosion happening someplace, that's the cable right there that you would find the stray current in. And once you found the stray current, then you can start working your way backwards with the clamp amp, electrical loop by electrical loop, until you found the source of the stray current and eliminated it. Okay, inside this bag right here are a whole bag full of electrical connections, and they're just like probably 2,000 euros worth of electrical connections, because it seems every marina you go into has a different electrical system. And the red typically is 3-phase, the blue is oftentimes single phase. I don't trust any of that, because I go places and plug in and I get 440 through the 110 system, and it just seems everybody does something bizarre on there, and like they'd never seen a code or something. So I wish that electrical system gets sorted out, but in the meantime, that's your adapter kit. Okay, I think that pretty well covers it. We've already covered the valves in the hydraulic system. That right there is another one of those for, one's emergency steering, and one is how to switch the hydraulic valves for the Navico or the Robinson. So you've got 2 autopilots that you can choose from. And I think that's about it for right now. That should give you a pretty good head start on what's happening back in the Lazarette here. So good luck. I hope that helped somewhat, because it's pretty hot and stifling in here. So I think I'm gonna find someplace air conditioned. Okay, we're gonna talk about the skiff real quick. By the way, all this growth right here, that's about 2 weeks. This bottom, the whole thing was totally clean, and it sat in the water for 2 weeks. We couldn't get it out because we were down we were med-moored. That's the result of what they call nutrient-rich water. Now, if you turn it like that, the guy on the TV is going to be going like this. See?
Oh, okay.
So, this is the up and down tilt. Okay, right here, start. Okay, turn it just like a car. This run here is fast idle. When it's in fast idle, you can't shift. If you try to shift and it won't shift, make sure this is all the way down. This is all brand new stuff, so none of this should be happening. So it's all going to be some system. You got to squeeze this red handle to shift, otherwise it won't shift. If it's sitting kind of not fully in neutral, then it won't start. See, I'm turning the key. So if you jump in and you can hear this, but when you turn the key, it doesn't go. Make sure you're in neutral. That's 99% of the time is what the. Okay, so when you first jump in the skiff, turn the wheel all the way to port, all the way to starboard, then back to the center position. And what that does is this cable right here is greased. You can see a little bit of grease coming out, and so. By turning the wheel all the way to port and all the way to starboard, I'm looking around because we're underway too. By turning the wheel all the way to port and all the way to starboard, it adds a little bit of grease, gets the steering mechanism working. Up under here is a grease nipple, and anytime it's difficult to steer, give a pump of grease in there. There's one more grease nipple that's under here somewhere that lubricates the pivot point. So a second little point of maintenance. When we leave around deck, see these guys right here? These inflate these runners right there. This is kind of a flat bottom skiff, and you'll see it's kind of a kidney pounder when you're in a little bit of a seaway or going into a chop. But these guys right here, if we're just like running around for the day, we leave them inflated. But if we're going to like across the Atlantic or something, then we deflate. So we pull these plugs right here, and the whole skiff settles down about another like 100 mils or so. And then we'll go up forward up here. And under there is the bow keel. And so we deflate the bow keel, and the whole skiff sits flat on the ground, or sits flat on the deck. If we're going across an ocean, something like that, we put all of our emergency gear in the skiff. So we put the third life raft and two containers of water and a ditch kit. Up in here are the life preservers and this bag. This bag was brand new with the skiff. It just hasn't held up at all. So you might end up making a new bag. Sometimes we leave the skiff hanging on the side overnight, and that prevents all that growth. You got to be careful though. If wind gets underneath that skiff, it'll flip it up sometimes, and so there's a crack in the bonnet right here. It's a brand new skiff, and then it got a crack in the bonnet. And when we picked up the boat, the bonnet was just completely shattered. Like it's got to have happened 10 times in the past or something. And we didn't have this turnover video for me to say to you, when it's hanging like that, get that bow line and cinch the bow line down way up forward so that the skiff can't, while it's up on the side, can't do that flip up, see? Otherwise, it pinches the bonnet of the outboard up against the side of the boat, scratches things. I see something happened with our nav light. I just noticed that today. But anyway, this right here is the switch to turn on and off the nav light. And then here goes into here is the stern light. And so that just kind of lays down there and corrodes, and you end up changing it. Anchor up here, and that's about it. This little setup right here will give you it'll give you temperature. We did have for a while, I think somebody sucked up a little bit of sand and clogged the water passage, and we had the outboard was overheating for like 2 or 3 weeks, and then it seems like it spit the sand out and it's never overheated again. So I just point that out. Just something to watch for. Nothing else really to know about it. Just a basic skiff. Had a lot of fun in this skiff. Okay, we're gonna come back to that. Okay, when you go to lift the skiff, you have to hold the skiff off the boat. But there's a little thing that happens here, and that's sometimes you see people and they start doing this when they're holding the skiff off. See, and if the line were to let go for some reason, let's say that carabiner broke, the person who's pushing out is just going to flip right over the side. So what I do is I hold kind of like this. I bend my knees and I'm holding like this. See, if I start to go, if that line breaks, I've still got a hand on the boat. So that's just a quick trick after reading about a couple deaths in the marine industry. So I point that out because this is classic. We're going to talk about the bow windlass now and give you the quick rundown on the bow windlass. Okay, so this is I think it's just a big Lumar hydraulic, so you've already seen it from the bottom. Now, right now, we have a line, one of our bow lines. So I'm going to slacken our bow line real slow, and just so that we can do the okay, now I could slip this line. My other option is I can also pay out just a little bit to kind of deload this line. Okay, now I'm just going to leave that line sitting here and expect our fenders to, because it's all very calm right now. Okay, so, the windlass. You open up this door. There's a little thing here that we generally jam in the hatch. Okay, so the windlass itself has teeth. Okay, first thing, let me just show you. This shaft has just got a little bend to it, see? It's always been there. It's never been a problem, but I'll tell you how to prevent more bends coming up. Okay, so you crank down this top piece. This top piece is what normally would be the clutch. In this case, it's not really a clutch. It just engages the shaft and the gypsy to the Wildcat, or the chain line below. Take up a little bit of tension, just like that. Release over here the chain lock. Okay. And now this brake should be left off. I see somebody had left it on, so we'll talk about that in just a second. Okay, so this right here is the brake. So now you can pay out the chain in one of two ways. Normally what I would do, I would just start to put out the anchor like that. Then I would come over here, take a little bit of tension on the brake, give it a little bump, one more little tension take up. Now Now the brake is holding the chain gypsy, or the chain wildcat, and now I can release the gypsy, and all I have to do is start paying out chain is just to release the brake. Now, some people have in the past with this have paid out the chain the whole way by just driving it out and then driving it back in. And if you want to do that, that's fine. It takes a long time to get the chain out. And if you're in a hurry, as we always are, then instead I just I let it out with the brake and then bring it back in with the under just hydraulic pull. Normally somebody would be down there flaking. We won't have to do that right now because we're only going to release just a little bit. So we've talked about how to let the chain out. In order to let the chain out, you have just to review, we have the gypsy that's engaged with the wildcat. Use the power down button, which is the middle button. This button over here doesn't do anything. It was, I think, a water pump or something at one time. It's no longer in use. This is up, that's down. So we power down just a little bit until the anchor is hanging. Then apply the brake. Pay out once the brake is set. To get the brake to set, you pay out just that little bit and reset the brake. And it just kind of happens that way because of the way the brake functions. The second time you take another quarter turn, then the brake is set. Deload the windlass a second time by setting the up and down button so that these teeth here don't have pressure on them. Obviously, if I'm in this position, there's a bunch of load. Then when I go to try to lift the gypsy, I'm fighting all that friction. So just be sure that you're not doing that. So you'll know because you'll have space on each side of the teeth. Bring the wildcat bring the gypsy to the extended position. Go back like 1/8 of a turn just so that you don't jam up here and end up with a hard piece to turn. If so, you can put a winch handle in there and turn, and then that's it. Now the gypsy is free. If you hear that click, listen to that click. Hear that? That means this isn't up enough. Okay, and you'll hear that sometimes you're paying out the chain. You'll hear click, 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 and that means that those teeth are just barely catching somewhere. And okay, so now that's it. You let out the chain using the brake. Stop with the brake, and throw the chain hook. Now the chain colors. There's a various set of colors that we kind of laid out there, but the ones that really turned out that you need are red, red, and red. There's red at 30 meters, 50 meters, and 80 meters. And then there's 100 meters of chain. So at the very end of the chain, the final 10 meters is all painted yellow. So you know you're coming to the end. The very end of the chain inside it has a lashing, and if you get up against the very end of the chain, it's still just chain. Like the lashing line and stuff doesn't come up on deck. So if you ever had to cut it all loose, you'd still have to go down below. And but that also means that if you paid out the chain all the way, then you don't have anything that's going to chafe. Okay, so now we've set our brake. The last thing that we do when we're paying out the anchor, put the gypsy down, release the brake. You'll know the brake's released when it's all kind of floppy like that. Pay out that last little bit so that the chain goes slack. Now this is so that our chain stopper down here, our chain brake, is what's actually taking the load. And we're not just leaving the whole load hanging on the windlass. And I'm sure you could, and if it really started to blow, the brake would probably slip a little bit. I showed you the brake down below already. That would probably slip a little bit, but it'd be no big deal. I'm sure it would hold for a little bit of the time in moderate conditions, but generally you use that brake, deload the windlass. Okay, so now to bring the windlass back up, or to bring the anchor back up, basically you just stand and let's show the anchor. That's it. And then you come back over here and make sure that the brake is down, and that's it. We're ready to walk away. And you saw the way that anchor comes up. This boat has a phenomenal anchor system. I think it had to be Hope that designed it, and it's just no touch. It's awesome. And It doesn't really matter if that anchor comes up upside down, it flips down straight again. It's just a great system. It really is. It's one of the best anchoring systems that I've ever had the pleasure to play with. When you're going to sea, you can use this guy right here, which is another devil's claw that goes under the forward there, which I'll show you in just a second. So, okay, so that's about it. Oh, one other thing that's kind of a little bit of a danger with this is, see where these buttons are? Let's say you've got these buttons open and you're going to reach forward and grab something. You could reach forward here. See that? Your knee rolls onto the windlass. Meanwhile, your body's over the windlass. So we've never had an injury with that, but I do want to point it out. Okay, so now we're done with kind of our anchor system. So now let's say that we come over and let's say that we come out and let's say that now we want to pick up a dock line like I'm about to, because remember I deloaded that dock line at the start of this. So I release the clutch. Now I should have free spinning. Okay, so I do. So I know that so I know I have control of my gypsy again. So now come around to my okay, one thing to watch out for is see how this line is starting to just climb up the bottom of the gypsy. I mean, it's a big line. This isn't that big of a gypsy. There's a gap down here. And we have had occasionally, we've had a few people that weren't really watching, ended up getting the line jammed up down in this little, down in that little area, that little gap right there. And then I got to come up here. If that happens, see this screw right here, this little bolt? You undo that bolt, take that out. Now you can finish unscrewing this. This gypsy, and the whole thing just lifts right off. It's all greased. It's really simple. Lifts right off, and at that point, then you can clear your line and put it all back together. But obviously, you don't want to do that. So that's it. I take up my tension. Yeah, it feels about right. Come over here. Tie off to my cleat. Okay, and the last thing that we do then is we come over here and see I'm paying back out now, and I'm transferring the load to the cleat. And I'm doing that by paying out the winch a little bit. And so now if we got a big load on that bow line, it's not all hanging on the windlass. One last thing to mention. We have had, on very rare occasions, happened twice, and funny enough, it happened back to back, both on the same day, and it's never happened before and never happened after. So I just mentioned this. We had the chain paying out, and a link in the chain turned sideways, and as it came up the chain hawser, bam! It jammed in the chain hawser, and it was jammed like you would not believe. We tried everything. We tried crowbars from below. We tried. It just wouldn't release. It was like phenomenal. You remember, it did this twice in a row. It's never done it before and never done it after. So I have no idea how this happened or why this happened. Anyway, the way we got it off was, if you remember right about here, there's that little right angle piece that the chain comes up through a pipe, makes a right angle, and is heading for the gypsy here, or the Wildcat. The Wildcat is what catches the chain. We unbolted that. It unbolts quite easy. The bolts are all free. You just climb down below, and one person holds the nuts from below, one person does the Allens from the top, and then that allowed that little piece of stainless or bronze right angle pipe to be lifted off, and then we could look straight down on the pipe, and we took a big bar and a hand sledge, and it probably took 15 hits to free that link. I mean, just unbelievable that it was stuck like that. But hopefully that'll never happen to you. But if it does, you've got an option. We're done. One more thing that I kind of forgot to cover on the windlass is how to pull up your other line. So we talked about how to pull up the port line on the gypsy. So now let's look at this line over here on the starboard side. So we got this line here, and how do we get that line up? I mean, a pretty hefty line, and you don't want to break your back. So what we've come up with is we use this winch right here that and we run a line from that winch. We lay this all out before we come into dock. So we lay a line there. It's already on the winch. It comes all the way up to here. So when we pull this line in, we put a rolling hitch from that winch onto the big line. Then we can suck in the big line and then transfer the load back to the cleat and then take that line off the deck. So I just point that out because when we got here, these guys would pile up here and have this tug-of-war match that just looked like an accident waiting to happen. Okay, that was it. Thank you. So we're going to talk about the power cord of Aphrodite. So here's Aphrodite. She's tied up. Here's our power box right here. And if you look at a power box like this, you'll see that they're all different. And that's kind of the whole crux of this. This one here, that's a single phase. Blue tends to be single phase. Red tends to be 3-phase, which is why you see there's five connections: ground, neutral, and the 3 phases. So what happens is in the starboard Lazarette, there up against the wall, there's a big bag of electrical connections. And so every time you pull into a dock, that's what I do anyway, every time I pull into a dock, I go to that box of connections, to that bag of connections, and I try to find something in that bag that will connect up to the dock. Now, oftentimes you would expect the voltages and all that to be kind of common, but they're not. All this stuff just gets mixed up, and even sometimes within a marina, you hook up to one spot on one marina, and then you move over to another spot in the marina, and nothing. All the voltages are changed, and it's just something that you have to really keep an eye on. So what I do is once I hook up, then I go inside to the electrical panel and I check voltage of the power coming into the boat before, of course, I turn on the breaker to the boat. Now, one of the things to keep an eye on, if you get 440, and sometimes these boxes end up putting 440 through a 220 box. I mean, it happens much more regularly than you would imagine. If you go to plug in the boat, and as soon as you plug in the boat, it trips the breaker on the dock box, then you can guess that they're feeding 440, and it's tripping the breaker on the isolation transformer. The breaker itself on the dock, but it's tripping the isolation transformer, and that's the impedance, resistance, reactance triangle that's be like way beyond this particular turnover video. I'm just looking on these breakers too. But basically what it means is that a transformer has no resistance until the power starts to ramp up. And so the first 2 or 3 cycles there's no resistance, and a 440 breaker has enough voltage that it'll read a dead short in a transformer. There's what I was looking for. Keep an eye on your breakers on the dock. Oftentimes you'll see this little guy. See, this is off to the side right here compared to this breaker. This breaker is a double breaker. That'll have a bullet breaker inside of it, which turns off for a dead short. Then it'll have a overcurrent breaker that happens over time. That's kind of like a heat breaker that goes on the curve. That C right there is the C curve. That's the curve at which the breaker trips. And so the breakers inside the boat should be B. The breakers on the dock should be C. It isn't always done that way. But it's slowly making the change. This right here is a ground fault. On the European systems, oftentimes they call them RCDs, residual current indicator, or residual current device. The US system uses a similar device called the GFI, or ground fault indicator. So either way, they both do the same thing. If you have an imbalance of current going up your line right here, so in this case we've got our blue, our brown, and our green. So now we're going to talk about these for a second. If there was an imbalance going into the boat between our blue and our brown, that means that voltage has to be coming out someplace, like maybe through the hull, maybe up the ground lead. And so because of that, and they put in these little devices here, these RCDs on the left-hand side of that breaker. And I mention that specifically because oftentimes you'll turn on all these breakers and nothing will happen, and then you'll be going, wow, that's awfully strange. This thing should have power. And then the next thing you know, you're looking for power and you don't have power, and it becomes this whole thing. That's one of the first things to check is the RCD. Oftentimes just plugging in or unplugging will cause the RCD to trip, and then you reset it, and then it's fine after that. And so it doesn't mean that there's a problem if it just trips. If it continually trips, like you reset it and 2 minutes later it trips, and you reset it and 2 minutes later it trips, and that means that there is a ground fault someplace. Water in your cord, something, some device inside is leaking, then you got to go into troubleshooting procedures. Okay, so we have 3 connections right here. We have blue, brown, and green. The brown is your voltage. That's your line. So when you look at one of these little connectors, this is a 3-phase connector, and I have L1, L2, and L3. So brown would go to L1, L2, or L3. It doesn't really matter which one. Blue is going to be neutral. So there's an N. So I put blue to neutral. My thumb's on the neutral. The green goes to the ground, which is a ground connection, which are those dashed lines that slowly get smaller. Don't hook up to 3-phase as in trying to put, let's say, neutral and brown to line 1 and line 2, because this isn't a 3-phase boat. So what then you would have is you would have a hot blue line, a hot neutral, and I'm not exactly sure what would happen. I've never done that. I stay away from that, but I'm just warning you not to do it. You'll also notice these cables are just the ends are starting to get a little bit worn. If you have to cut them back, which we do occasionally, then the brown and the blue tend to be made the same length, and you'll notice that the green is longer. And why is the green line longer? Because if tension gets put on the power cord and the cables get ripped loose from the socket right here, the last thing to disconnect is the ground lead, and the ground is our safety lead. So the last thing is our earth, our ground, and that would be the last cable to disconnect. So when you recut these, oftentimes people, they don't really think about it, they just cut everything the same length, but you recut them so that the green line is the longest, and so that it's the last one to go. Funny, we were on St. Martin, and they do it just the opposite. They make their brown line the longest because they say that they want the ground to take the strain. So everybody's got a different way of doing these things. Okay, I think that pretty well covers it. There's 2 connections going in the back of the boat. There's a 50 amp 110 220. That's what I'm leaving the boat clipped onto. And then there's also a big 3-phase that you can hook up single phase. There's, I think it's a 64 amp, or it might even be more, 67 maybe. I'm just looking at if I can read that. Anyway, it's that connection right there. There's a receptacle connection in the boat in that same bag on the starboard Lazarette. And you can go into there if you wanted to make the connection a larger connection. Unfortunately, see, this cable is only a 65 amp cable, something like that. It might be 63. It says on it somewhere. Anyway, the cable's only 63 amps, and that's actually kind of a little bit of an issue because see this 3-phase plug right here. If you look at those breakers, that one's 63, and some of these other ones will probably be more. And that's one of the things that when we start mixing these cables around, what we can sometimes end up with is a connection that goes into the box that's bigger than the power cord, and it just happens to be the way that things line up. So if that's the case, then just be really careful of your power cord. I also see this one here, it's got 380 at the dock also, so if it's got 380, that's another thing that won't work on Aphrodite. We need 220 single phase 50 hertz. 220 single phase 60 hertz will also work. So that's your goal. 220 single phase 50 hertz. That's perfect. This right here is our hose connection. That little piece right there screws on and makes an adapter for the quick disconnects, and those stay with us. So when we hook up at the dock, we bring that with us. This little adapter screwed into the dock. There's a large size and a small size. You can use either. There's both are in the bag. That's in the back side of the forward cockpit on the port side. Port aft forward cockpit. There's a locker right there, and there's a red cloth bag, and in that red cloth bag are all of the hose fittings. Okay, I think that pretty well covers it. Okay, good luck with it. Trying to teach electricity through the YouTube here, but I'm trying to make this turnover video so that so that somebody else can take over the boat without all the drama. So good luck. Bye bye. So now I've hooked up to shore power, and so the second phase here is that I come down. This tells me that I've got 220 volts on the board, but I don't really know if I have 220. We'll go over that in just a second. And I'm running on the generator right here. So I come over here, I look shore power, 220 volts, number 2, I'm on 2, so that's my generator, number 1. That's my shore power, number 2. That's my shore power 110, number 3. Okay, so now I've verified. I do indeed have 220 at just over 50 hertz on the generator, and just about 50 hertz on the just over 50 hertz on the shore power, which probably would actually be 50. Like I could use that and set that, see that, so that it's actually 50, because I can pretty well guess that shore power is actually going to be 50 hertz. If I really wanted to know, I could put a hertz meter on there, but shore power is going to be pretty much 50 hertz. So now I come over here, I've got my generator which is on, so I turn off my generator. Now my generator is running because I've shown power to the board, but the green light is off. And so now I've got my option. Now that I've turned off the generator, I have my option. I can turn on the generator power, or I can turn on shore power. I've verified that my shore power is 220 volts and 50 hertz. So now I can come down here to my shore power and turn on my shore power. I hear the whole boat powering back up again, the fans coming back on, all the rest of that. And after a couple minutes of cool down, letting that generator kind of cool itself off, I look over here. I think we've already covered all this, but fuel, and day tank. I can come over here to my day tank. See that green light go on when I flip on the day tank? Okay, now I'm back to auto. So my day tank right here. If you flip that on the manual and just walked away, you could pump all of your fuel from one tank into the ocean, and that would be really a bad thing. As would it be if the high level on the day tank didn't read. Then there would be nothing to tell the day tank not to transfer the fuel, and well, that would be a bad thing. It'd probably dump all your fuel into the ocean, making a huge spill, a huge mess, and you'll end up something like that might happen if you were crossing the ocean and the electrical failed. So it doesn't seem like that fuel day tank should have another sensor that tells you when it's high. It's got a low. If it goes below the on, then it goes below that and gives you a low, one of these over here, fuel day tank low. That's what I'm on right now. Okay, but basically what I was doing was burning up enough time that I can come over here, push stop. The generator is off, and that's it. So now we've successfully switched from generator to shore power, reverse the procedure to go the other way. So here's the galley. This galley's been pretty good. I'm just going to go over it real quick here. Looking at it from various angles. Biggest disadvantage of this galley is people standing in here when somebody wants to get into the back cabin. The other kind of disadvantage problem of this galley, I might as well cover these both right off, is this little corner, because people stop here to do the trash, people stop here to do the water. I can't imagine anybody keeping this little igloo water, but it's worked out quite well. So we fill up that igloo water holder off of the freshwater water maker, and then so people come up and then they go to fill a glass here, and it's taking like 30 seconds, and meanwhile people are trying to walk by and get to the trash. So that's kind of been the about the only disadvantage to this galley. Fire extinguishers over here in this corner right here, fire blanket up here, along with the aircon chiller. You reach into the drawer right there, you can pull out a clicker. Sometimes we leave the clickers back here. It all depends on what you're doing. Go into this corner up here, flick that little green light. You see that switch in there for the green light? That activates the propane. And in this case we're using butane because we're in Europe. And then you can turn on, in here you turn on and push and hold down until after you've lit. So it's kind of a two-handed procedure. And I'm going to turn this gas back off. This here is the propane locker itself, and so that's the propane locker, but you access it through the deck and coming down through a deck hatch there. So you can get to you can get into it by lifting this. See that? And that's the inside of the propane locker, but it's all sealed up. See, so there's nothing in there that you would ever need to get to. The next one down is refrigerator right there. See, it's a double door. See that? And another refrigerator right here. And freezers. This one here is just a food storage. This one's a freezer, double freezer here, and more food storage here. The oven is kind of is actually not that great of an oven. In fact, I just don't understand why people rave about these. And but anyway, it's got these two knobs here. The fifth knob, or the left-hand knob of the two that I'm dealing with here, is the grill. So you can light the grill from the top, and this one lights the grill from the bottom. And all that this is just a burner with no thermostat. So you're supposed to somehow watch this temperature gauge here. If you want a quick warm up, you light the grill and the bottom, and let the unit come up, let the stove come up to temperature. And a bunch of dishes down in here. You'll end up setting this up any which way you want. I can't imagine that that anybody's going to do it the same way twice. But spices up in here. That's worked. Worked quite well. More spices up in here, and teas up top. So this is just the way that we did it. You can do it any which way you want. It is that little panel up there, that 24-volt panel up there, is the aircon, or the refrigeration units that are under the floor right down there. So 3 refrigeration units under the floor right there. And other than that, you'll just set this up any which way you want. There's a 110-volt outlet here, and a 220 outlet. The couple 220 outlets. The 110 volt is run off of a transformer. It's kind of back up under here. So dishwasher right there. It all works. It's a little old, but it works. I wonder if there's anything in there. No, it's all clean in there. The one thing about that is if you're on the starboard tack, it'll lose a little bit of water out onto the floor because it's not really a good seal. This button here, see that right there? That button there pumps up the sink. And the next button over here lights these lights. See that? So that is the rope light. Now the rope lights are pretty well. The rope lights themselves are pretty well blown out, but the electricity and the power and all that is still all there. So really, all you need to do is get another rope light and put it, just lay it in place, and it'll do the wiring and everything. It's all there and works. Microwave, old funky microwave. We never used microwaves, so not much to say about that. And well, I guess that's about it. Good luck with the galley. Hello, welcome to the Aphrodite engine room. So what I'm going to try to do is give you a little tour of the engine room so that you could take over the engine room if, for example, I have to fly off to go look at another boat, or maybe you're taking over as captain, or maybe I was injured on one of the passages. And for some reason, somebody else has to take over the engine room. So I'm going to try to show you what all these little components do. So like when we got here, we had to kind of figure out each and every step along the way, and hopefully you won't have to do that because you've got this video to take a look at here. Okay, so I'm going to start with what oftentimes is one of the first things people need to know about, and that's this manifold right here. Okay, this manifold right here is the bilge pump system. And so this one right here that's open, this manifold here takes all of the suction and all the pumps, the 2 pumps, the electric pump and the engine-driven pump, and at the same time all of the suction points all come to this one manifold. And you'll see it's not labeled too well, but we have a little label maker system project that's underway right now, so what you actually may be seeing might be better labeled, but if not, I'm going to go over it with you right here. This is the salon, which is the main area, kind of underneath your floor by the TV set and by the main table. This is what sucks from that area. The next one here is the forward suction. This is the crew area. The next one here is the engine room suction. You'll see it's tied off, and I keep it tied off so that you don't accidentally activate it, because you want to check and make sure that all the oil's out of the engine room bilge before you pump. This here is the actual suction from the electric pump, and so when we turn on the electric pump, this valve has to be open so that we bring suction into the manifold, and suction in the manifold then will either pull from wherever it is that we want to pull from. This guy right here, this valve right here, that's the engine suction, and we'll talk about that at the very end. There's a big pump on the engine that will also supposedly dewater the boat. Last one here is the Lazarette. And this cord that I'm pulling out of the way, that's just a portable light right here. Okay, so that's the Lazarette, the last one. This is this top one right here is an air vent. Don't know why you would want an air vent, but it's also got a barb. So you could conceivably put a hose on this barb and kind of work your way around the boat, sucking from little tiny corners or something like that if you absolutely had to. So the on-off switch for the pump is right here. And you can hear the pump running, and that pump is off. Last captain told me that the captain before him told him that the captain before him had a temper tantrum in here and punched this box once, and that's why it's all kind of falling apart. And that's on my project list of item 347 to take care of. But in the meantime, just be gentle with it. Okay, this guy right here is the Strom, the filter, and what this does is this filters the water that's coming from the suction manifold, and filters it, just kind of strains it. I shouldn't say filter, I should say it strains it, so that before it goes into the actual bilge pump, it takes out the small stuff that made it through the system, toothpicks and stuff that made it through the manifold, but would probably clog a check valve. One more valve down here that you should know, and that's this one right here. This is a freshwater feed. You can tell it's not the code because that's a test. Because there's no anti-check valve in it. There's not a way that that you could possibly not contaminate the boat's water system with bilge water, but we all know not to do that. And so you wouldn't do that. The way you wouldn't do that is you'd make sure that you had actual freshwater pressure anytime that yellow valve was open. And so you would use that yellow valve, the freshwater system, freshwater pressure into the manifold. If, for example, if you had a clog down line, let's say that let's say you had a clog in an elbow from from what's this one, the salon suction. Let's say that the salon suction had picked up an old piece of plastic, and somehow it got through the little strom foot and got caught in an elbow somewhere. And so you can feel that you've got vacuum here, but when you go to the other side and you put your hand over the strom foot, then you've got no vacuum. So how would you clear that? You would take this valve that's right down there, and that valve that's right down there, and let me get a little bit of light on that so the camera is a little bit better. That valve is the valve that's between all of the suction bits and the manifold and the pump. So you would close that valve, then you would close everything else except for the area that has a clog. In this case we're hypothesizing the salon suction, and then you would slowly open up the freshwater feed. And so the freshwater feed then would try to pressurize the manifold. It would try to send water to be pumped out. It can't pump it out because the valve is closed to pump overboard. That's that little valve down there on the other side of the strainer. And so it would have to backwater flush the salon and force water out the salon. And the salon suction foot, and so the salon suction foot then would probably get a thwap of whatever was clogged inside the pipe, and it would push it backwards. And allow you to clear a clog. The other thing that you could use that for is the engine suction. Now I haven't actually been able to make the engine bilge pump suction system work, but I've only tried it once or twice, and I kind of look at it and say, yeah, this could possibly work sometime with the proper amount of effort put into it. And it might need a little TLC. It might just work. The bilge pump for the engine is kind of up and around that corner. And it's the same pump that's actually the water pump, the saltwater pump for the engine. So there's a saltwater pump for the engine, and it's got two chambers. One side of it is the dewatering bilge pump, and the other side circulates water through the engine. So that means two things. First of all, it means that it's going to be some type of a centrifugal pump that'll obviously need to be primed, and that's that little valve that allows you to put fresh water into the manifold system that we'll talk about in a second. And the other thing that's kind of tricky is, that's a test, that if the impeller ever went bad on the forward half of the pump, you could conceivably still run the engine using the aft side of that pump. So if it wasn't a big leak, if maybe just the impeller wore out and slowly eroded away and stopped circulating water through the saltwater system, you could conceivably switch the hoses around on the saltwater pump of the engine and use the dewatering side to circulate the saltwater through the engine and keep going until you could get the pump replaced. Okay, so how would you start the engine dewatering pump? Again, you would close the valve going to the electric pump. Or in this case, it's probably easier. We just close the valve right here. Open the valve going to the engine dewatering pump. Turn on the flush and turn off your suction to wherever it is that you're sucking from. Let's say that the salon. So now what we have is a completely closed manifold, except that we're pushing water into the ship's dewatering pump. And that's how we're going to start a prime. We're just going to keep flushing water into the ship's dewatering pump. And then slowly, when we think we probably have just started a little bit of a suction going, we start to, this would be closed in this little scenario, we start to slowly open the salon bilge pump. And that would then start to allow suction to be taken from the engine dewatering pump through the manifold into the salon suction, being primed by our freshwater system right here. So not a bad little system, kind of clever. It's got a few little intricacies there. And okay, so that's our bilge pumping system. You'll probably have to watch that once or twice, and then you'll probably catch on. One quick thing: the Lazarette has all the hydraulics in the back there, so before you pump the Lazarette, put an eye down in the Lazarette going through the aft cockpit, and just kind of look down there in the suction area and make sure that we're not going to pump oil, like maybe a tank ruptured or something, and that's why the bilge alarm is going off. So be sure to go back there and take a quick look. This here, undo the four bolts. You can lift out this little cage in here, rinse it off, and clean up that little suction C strainer, and then you're on your way, all clean. Okay, the next set of valves back. Down here you see it says fire main. The next one down is, that's the engine suction, and the next one is the generator. And see, the engine suction and the generator both have cables attached to them. And that's because if the boat were supposedly, I think they think if it was flooding, that you could pull those cables from outside the engine room without having to open up the door, because this is a watertight space, and shut off water to either the engine or the generator, and secure the area while the bilge pump, which is just outside the door, continues to pump the area. Okay, so that does our bilge pumping system. This guy down here is the sea chest. This is just straight open to the bottom of the boat right there with a little grate over it, and so that's it. That's raw open sea that's out there. And if you took off the top of that little container right there and you were small enough, you could probably just jump, make a little dive, and go right into the water if the grate wasn't there, and come up outside the boat. But not being a James Bond submarine, we won't have to do that. Okay, let's talk about the fuel system. In fact, if you weren't having to watch this video to figure out the bilge system, then chances are you're having to figure out the fuel system. Fuel system, just a quick little story. When we got here, they were running this engine off of an outboard tank on the floor. And why were they doing that? Because they hadn't worked out the fuel system here and didn't realize the intricacies of it. And they had bad fuel in a forward tank that had water emulsified in the fuel, and then every time that they pumped that fuel into the day tank, which I'll tell you about in a second, then it would clog the engine fuel filters, which are up here, and pretty soon they just had a whole catastrophe going on their hands, and a stalled engine, and it was just one long nightmare for them. So that's all pretty much been worked out. And but by working this out, this has added a lot of valves to the system, and so it's probably really a good time to talk about it. So we have two filters right here. These are both our Raycor filters, and both of these filters then allow either filter to be used or both to feed the main engine. The main engine has a set of secondary filters on. I think we have 30 microns in here right now, and so 30 micron filters in pre-filter, and then the main engine probably has 2 microns that are on it. We don't really know what they are because they come from MAN, M-A-N, and they don't tell us exactly what the filters are, but we can kind of guess. Okay, this filter here is the fuel water separator between the main tanks and the day tanks. And then between all of the valves that we're going to talk about in a second, you can do all kinds of groovy things. You can circulate fuel through the day tank, for example, and just keep circulating fuel around and around inside the day tank to polish the fuel inside the day tank. You can take either forward tank and transfer fuel around and polish the fuel. You can run from one forward tank to another forward tank and transfer all the fuel to, let's say, the high side for a long sailing passage. So if you had one empty tank and one full tank, and let's say that you were going to be on a port tack, you could conceivably transfer fuel to the port fuel tank, because we got 4,000 liters. That's 2,000 liters of fuel, so that's, that's almost 2 tons, a little less, you know, because fuel weighs less than water. But you know, you could have 1.5 tons of fuel, and that you could put on the high side rather than the low side, give the boat just a little bit more stability if you were on a long tack, for example. So some of those are little tricky things that could be done with the fuel system. So I'm going to shine this light and kind of point around to the valves. So this tank right here, or this fuel filter right here, is managed by that fuel pump down there. Now, what that little fuel pump that you're looking at has a suction. The suction comes around inside of the fuel filter. From the fuel filter goes into this fuel manifold right here, and this fuel manifold kind of continues on. We'll talk about that in a second. So the first opening is just a hose that I have just right there. So for example, if you did have to suck fuel from a 5-gallon bucket that you wanted to put into the day tank, and so you could take this hose right here, turn on the fuel pump, open that valve, and it'll suck and close this valve. This valve would be closed in that scenario. So then this manifold would be sucking from this system right here, which is just that open, which is just an open hose to suck from whatever scenario that you wanted. The next valve over is the day tank. So this valve right here is sucking from the bottom of the day tank. So if you wanted to polish the fuel, you could suck from here, and then you could return to the day tank that we'll talk about in a minute. This valve here now sends suction down the road to way back up in that corner back there is a port and starboard fuel valve, and it's a one-way, it's a 3-way valve with a handle on it. And so if this valve is open and you turn on the fuel pump, it'll suck from one of the 2 forward tanks, depending on where the Y valve is. That's up and around that corner, and you might be able to see it way back up there, black handle, and it says starboard tank, port tank, and it turns 90 degrees, and there's a little white line on it that kind of shows you, because it's one of these things. So if it's in this position, we'll do my hand for just a second. If it's in that position, it's going from the top, which is the suction, to the right. And then if it's in that position, only turning 90 degrees, it sucks from the top to the left. So it's only a 90-degree turn, and so there's a white line on the valve that kind of gives you some idea of which side that it's sucking from. Okay, so now we have a way that we suck fuel into the filter, into the fuel pump. Now coming out of the fuel pump, we have this clear line. I won't go into why we have that clear line. It's a long story, but anyway, there's a clear line, which is kind of nice because you can kind of see what the fuel's doing through that line, and probably at some point you're going to have to change that back for a fuel hose, and because eventually that'll get old and stiff. So fuel is now coming up around this corner and into this little manifold that's right here. The top one returns fuel to the port tank, bottom one returns fuel to the starboard tank. How could you have a disaster? It's a test. All of life is a test. How could you have a disaster? You could be sucking fuel from the starboard tank and be returning fuel to the port tank. And thus you would either overpressurize one of the main fuel tanks. Let's say that each fuel tank was 2/3 full. You could conceivably overfill a tank then and start pumping fuel into the bilge or overboard. I don't know where it would go because I've never actually done it, thank goodness. But if you did do it, that would be a bit of a disaster. So if, for example, if you're trying to polish fuel in, let's say, the port tank, you would make sure that that forward valve is sucking from the port tank, and then you'd know that you were returning to the port tank. If you did something like, for example, we're walking through here and just smacked the valves and left them in that position, for example, well, you could have a disaster because this pump turns on, the fuel pump turns on automatically to transfer fuel from the fuel tank, from the main fuel tanks to the day tank. So you could potentially have a little disaster there. And in fact, one of these days I'll probably get around to turning these valves, but see, I have to be loosening when I turn them this way. But what I'd like to do is turn them so that both of these handles are pointed straight down, but that isn't the way it is right now. But if both of these are closed, we carry on. So fuel is now going from the pump, sucking out of one of the main tanks, through the fuel filter, through all the manifolds, coming up through this return line right here. Closed valve, comes down through this little S-curve and comes out to that open valve. That open valve right there, that my hand's on now, returns to the day tank. So what that means is that we leave the system in the configuration where the fuel pump is sucking from a fuel tank of choice, and returning to the day tank. And so what that means is that there's an automatic sensor on the day tank, and if the engine's running and the day tank runs down to 20%, it turns on the fuel lift pump. The fuel lift pump, the electric fuel lift transfer pump, transfers fuel from whatever tank is selected up forward, back through this little valve right here, into the day tank. When the day tank reaches 80%, the day tank turns off. There's not a day tank overfill alarm, so if the overfill didn't actually turn off, you could conceivably just keep right on pumping fuel into that day tank. And where would that go? Don't know, never done it, but I know it would be a real disaster. Okay, next valve right here is another little transfer valve. If you open that transfer valve and close the day tank return valve, now we get into this little, cool little system where there's a check valve. So now we're pressurizing that T. There's a check valve going so the fuel can't go back to the day tank. That little valve right there, by the way, with the cable on it, that is the suction to the main engine. And then, of course, outside the engine room, underneath the sink to the right, are the pull cables. And if you pulled that pull cable, let's say you had a fire in the engine room and you pulled the pull cable, it would shut off the fuel supply, everything past that valve. So if we sent fuel pressure down this little S-curve past this open valve that would normally be closed, we would send that fuel back up, and it would go around into this manifold, which is for the main engine. And this is our selection. That's this selection for the main engine using either the first or the second main filter. So in this case, we're pointing towards this filter. We're using that main filter. Turn it so that so we're pointing down. We're using both filters. Turn it this direction. We're using the other filter right there. I try not to use this filter too much because you'll see on the bottom I've got a bolt in there instead of a fuel drain, and that's because when I went the little fuel drain gasket after 20 years finally failed, and when I went to Raycor to try to buy another one, they upgraded them and they got a special order, and we're never in someplace long enough to get that piece. But eventually, by the time you get here, that may be replaced, it may not. So now we've pressurized this fuel manifold by turning on the fuel electric lift pump, opening up this little transfer valve right here. Fuel can't go backwards into the day tank through the check valve, so it's got to come up into this manifold, through this manifold, through these hoses right here that my hand is on, into the engine fuel system. And so, what does this mean? Another test. It means that you could, for example, change the fuel filters on the main engine, which are right under here. These are the two secondary filters for the main engine, normally left in the all position, which is where my hand is right now, in the all position. So normally we would leave in the all position. That's one filter, and that's the other filter. Hey, look at that! The hose doesn't quite allow that switch to make it into the left or the right position. But anyway, you could change these filters, for example. Now the filters are totally empty, and it's and now you want to refill those filters. Well, that's what this little bypass system that we're looking at is for. So now you're actually pumping fuel through that little transfer, through these pumps right here, through those black lines, which then come up through the day lift, through the engine lift pump, into this filter system, into the injection pump, and back to the day tank. So how cool is that? That means that this whole thing about like trying to push the little hand pump with your thumb, tunk, 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 to fill one of these filters, like being in a rolly seaway and changing a fuel filter and then trying to fill it off of a 1-gallon jug, spilling fuel all over the place. I'm sure everybody's been there. You don't have to do any of that. You just put the empty filter on, do the valves in the configuration that I just showed you, and turn on the fuel pump, and voila, let it run for a couple minutes, and pretty soon the whole engine system will be bled, and you don't have to do anything besides go outside and push the button and start the engine, which is a huge advantage. Okay, so I'm going to turn this so that we are back to refilling the day tank. Now I'm going to check, because when I leave, this fuel pump is going to be on automatic. So that means that the next time this fuel pump comes on, I'm not going to be sitting here. So I want to make sure I'm sucking from a tank. I already know I'm sucking from a tank up forward, sucking from a tank. I'm not sucking from the day tank. I'm not sucking from my emergency suction. I'm going into my tank, going into my fuel water separator, out this little suction right here, up to my manifold up here, my pressure manifold, my exhaust manifold of the pump. My return to my port main fuel tank is closed. My return to my starboard main fuel tank is closed. My return to the engine is closed. My return to the day tank is open. So now I can safely leave. If there was ever some major problem here, here's my fuel transfer pump shut off. Hit the button, fuel transfer shuts off. Hit the button, fuel transfer shuts off. That's it right there. We leave that in the on position, and on the main panel behind the navigation board, there's a fuel transfer that sits in auto or manual. If you wanted to do manual takeover, you could push this button, like for example if you were bleeding the engine. You could go out to the panel behind the navigation system, push, excuse me, got breakfast going there, and sitting in this cramped position. You could turn to manual. Then you could come down here, you've got this button pushed, and now because you're on manual, every time that you turn that button, click, then that's it. The fuel pump turns on automatically. So now you'd be bleeding the engine, transferring fuel, whatever it is that you want to be doing. Push that button, fuel stops. I'm leaving it in the on position because we already know that all of our valves are in the right position. So I feel confident that we won't have any issues once the fuel takes off on its own. Okay, working our way around the engine room, we've got this little fan that I've got unplugged right now, which is partly why I'm sweating. And that right there is just to blow air around the engine room. We've got the intake blower. Intake blower is still under construction right here. Just mounted that a few days ago, found it in a second-hand shop. Somehow they lost the fuel blower, or the air intake blower. The last crew lost it and was sent it off for repairs or something, and nobody knows where it is, and it's just lost. So found this one at a second-hand shop for 100 euros, and it turns out it has a 3-phase motor, and so I've ordered a slow start single-phase to 3-phase converter that's probably going to sit someplace right around in here, and what you'll see is a little box with single-phase going in, 3-phase coming out. The 3-phase will run this motor right here, and then that motor will run the blower. The 3-phase converter should have a speed control on it, and I don't know what we'll set this at. 50 hertz is 1400 RPMs. We might have it running full speed. I don't know. We'll see. But you'll figure that out. Okay, got a box right here, which is, I'm pretty sure that's like one of our main power boxes. Never been in it, don't need to. All these relays here are the relays for the relays that are the on-off switches that are at the navigation panel. So, for example, there's let's say the day tank pump. When we run the day tank pump, there's a little switch. That's actually the contactor right there, the relay, the contactor that actually closes and starts the and transfers the load for the fuel pump. And this one here is that's actually the freshwater pump. Let's see, that's the air inlet fan. Bilge pump. Now that's funny because let's just see if that closes. I'm just going to. No, so I don't know what bilge pump that is, but I'd like to know. So eventually we'll figure that out. Circulation pump, hot water, that's been removed long ago, which is one of the reasons that you have to run the water for so long to get hot water, and kind of a waste of water. Okay, so now I'm sitting on top of the engine, but we're going to keep trying to view. This is the heat exchanger for the hydraulic thruster. So this little hydraulic thruster heat exchanger right here. That green right there is the water fill. Oh, by the way, if you can see this, can you see this red hand pump over here? Does that? Okay, that red hand pump, by the way, I should have covered this one under the fuel system. If you ever get into a situation where the electric pump doesn't work and you still need to fill the day tank, then that's the bypass pump. There's a little valve. Open up the valve underneath it, close all the rest of the valves on the suction manifold, so that all suction from that little hand pump goes into the hand pump down through the down to the day tank, or down to the forward tanks, and then you'll just sit up here on top of the engine, I suppose, and pump. Glad we're not doing that. Okay, so we come down here. Those are the fuel inlet hoses right here. Oil check. Never uses any oil. Never uses any oil. If this engine started using oil, then take care. What's going on? Something's up. Oil fill after an oil change right there. I'm sure that this engine has a bunch of zincs, and I've been trying to track them out. I'm wondering if that's one of the zincs right there. Haven't opened that yet, but it might be, so I'm just starting to try to figure it out. This is the exhaust, the dry exhaust right here. To this point, turns to wet exhaust around the corner. Turns to wet exhaust right here. And what's all that? I've been wondering too. One of these days, I'm going to have to get in there, probably before we make our next passage. But anyway, I don't know what all that little dust is. Pyrometer right there. Now that's funny. That pyrometer only goes up to 200 Celsius, and we routinely have pyro temperatures at 300 when we're running the engine hard. So what does that mean? Well, I'm not sure, but we'll get back to that in a second because I've got a system for checking. Little glass right here is something you can look through to see if water is flowing. Oftentimes it looks like no water is flowing inside of that glass, but in reality, water is oftentimes, or always has been for me, flowing. And so, but that's a little glass, so you get a sight tube. So, talking about pyrometers, we use this laser temp right here, and so right now it's 44 degrees. This, whatever you point this at, you see that laser there? And whatever that laser hits, it tells you the temperature of that point. So if you want to check exhaust gas temperatures, you can come to this point right here, and you can shoot each direction. And what that does is, I can get like 250 off of each side, 250 Celsius, where it kind of combines up to 300 up here, probably where all the pressures and everything meet. And so what that tells you is that from this point you can shoot the gearbox. Normally runs at about 47 Celsius. You can run between the gearbox. This is the gearbox cooler right here, and you can check the transfer of temperature between the gearbox cooler, and you can check the amount of temperature, the temperature of the gearbox cooler right here. You can check the temperature of the gearbox cooler by shooting the shell compared to the gearbox. Of course, everything. Well, one's 33, one's 29. That's kind of funny. And then you can check how much heat is being taken off through the gearbox cooler between these 2 points right here. This valve right here is diverting water. It normally just stays all the way open. They had it kind of like wire tied, really wire tied down in this like, you know, 3/4 closed, but I've gone at it with a laser temp, and when it's all the way open, the engine's running cool enough and everything else is running cool enough, so I've just let it divert all of its extra water to the stern tube. So the stern tube gets the extra water. So gearbox cooler, That's the diverter to that valve right there is a diversion to the stern tube. That's the temperature probe. I've got that wire tied down because it vibrates off all the time and then sets off an alarm like the gearbox is overheating. Down there is the gearbox oil check. That we don't have to use that too often. Normally I check that gearbox oil about once a week or so. Okay, let's see. Now we come around. I see that the battery light's flashing, so eventually we're going to have to go to the battery. Okay, so the camera battery. So you'll probably see a blip coming up. You'll notice that this whole manifold little system right here, all that was just hanging when we got here. It's just like all drooped down by the hoses. So I've got a wire tied up into place, and eventually I'm going to have to make a bracket that holds the whole system in this place. There's only one bracket right now holding this whole thing, and that's up here. So if you push there, the whole thing kind of cantilevers around. So I don't know how they were doing that in the past, but it's kind of humorous. If you ever have to shut down the engine manually by just reaching down here, that's it right there. My hand's on it right there. So if you were down here and something was going on, you wanted to shut the engine off, you just hold that, and that's it. The engine would shut down. Okay, down here by my feet is a little cover because that's my hand's on the shaft bolts right now. Check these all the time. When we got here, they were just loose, and I tightened them up, and they were loose again right away. So I pulled them all, and realized that they kind of had this deal where the bolts weren't shoulder bolts all the way. So one side of the bolt was sitting in the shoulder, the other side was a different diameter where the threads had been cut on the bolt. So, and then they just had regular nuts on. So I've replaced them all with full shoulder bolts and nylock nuts. So we're hoping that that they don't keep coming loose. I also checked alignment at that time. We were 5/1000ths open right on the port side. So we were 5/1000ths, which is probably about max for this engine. There's 5/1000ths of an inch, and underneath this little cover right here is a big donut that kind of is supposed to take up vibration. So thank goodness that's there because we got 5/1000ths of an inch on the other side. And then this second gearbox right here, this is the Henderstadt propeller, variable pitch propeller, and that's controlled up in the cockpit that we did talk about on another time. But when you push the button up there on the control up top, this little guy right here, this motor runs through this little right angle box into this gearbox, and that gearbox has a push-pull rod through the center of the prop shaft that changes the pitch on the prop. And there's a couple points. There's one under there to grease, and there's another one back up under there that we grease somewhere. And so you'll see them. They oh, hey, that helps. All this stuff becomes a lot easier to see when the floor plates are up. I can't pull up this other one because I'm sitting on it right now. But anyway, oh, and then this is the gearbox check, and you look at this one every now and then and make sure that the oil hasn't emulsified, which would tell you that water is getting back up through that center shaft. See, and so because at first it looks like there'd be no connection between that gearbox and the water. And the seawater, but of course there would be because the center shaft is out in the gearbox, and at the same time it's in this gearbox right here. So the center shaft is in the gearbox and in the prop shaft simultaneously, and so we want to make sure that that there doesn't become a connection in there, and that the oil starts to become milky. These are the fuel lines for the generator, so I can put this floor plate back down. And that to me looks like we're going to have to get under there one day and do some more clean out under there, because that just looks ugly.
Dude, can I have you for a minute?
Oh, I'm getting cold. Okay, good time to change the batteries. Yeah. And we'll go on to the next step. Okay, so we'll be cool. So, this is the door to the engine room right here. Separate from the door to the engine room is this separate little door that goes in there, pushes, turns. You wouldn't even know if there's an engine room behind there because nobody cares unless the engine doesn't start. In this case, we open back up, click that guy, balance these so that they're absolutely straight, and then push. Now that latches. This is the engine room blower. You know that the engine room blower is on because the orange light is on. Don't go past this line right here. If you do, all you'll hear is that The blower doesn't go any faster, but it makes a whole bunch of straining sounds. This means that the bilge pump is running. It's not actually a switch. It just warns you that the bilge pump is running so you don't forget it. This switch right here is just a spare. It doesn't do anything that we know of. Right here, break that glass. That then allows you access to the pull cord that sets off the engine room fire air system. Before you would pull the engine room fire, let's say that you realize that there was a fire taking place in the engine room, or you opened up the engine room and you realize, hey, there's a fire taking place in there. You would slam that engine room door and come around this corner right over here. And inside of here are all of the pull cords. So you would pull the cords. Each one of them, see, has a little cable attached to it. And you would, and the ones that are super important are, of course, the fan. And then you'll have fan the other direction. So you'll have to shut off air. If you didn't shut off air and you pulled the fire, you pulled the fire CO2 release. Well, you'd probably lose the boat then, because what that would mean is that the CO2 would escape, the fire would continue on, and now you'll have really no way to fight the fire except for portable extinguishers. So it's very important. Come in here, every one of these little cables pull until you can't pull anymore. You'll probably have a bunch of adrenaline going at the time. Then you'll come over to this panel right here, break the glass, and then pull, and that would release the CO2. Everything else can get pulled by accident. It's no big deal. That's why they're out in the open. It might shut off the engine, might shut off the generator. But if you pulled this one by accident, you could actually kind of kill somebody inside the engine room because they would be asphyxiated. So that's why that one's behind glass. Little work list over here that on the panel. Okay, so when you open up this door is a watertight door, see, so it's sealed, and it takes a little yank right there. I'm going to turn off the fan now so that it doesn't make a bunch of noise. And you can do three things with this door. You can go inside and close the door. You can take the door and put the bolt down there, or you can open the door all the way, blocking access for the people in the aft cabin, and put something in front of the door, like the garbage can. So, three things right there. Don't put the bolt halfway down and let it drag on the floor, because it'll just leave a mark in the varnish and won't actually stop the door from moving. Okay, so. Okay, I unplugged just the portable fan there to quiet down the noise. This is the CO2 air release. I think it's CO2. No. It's halon carbone. Halon carbone. I haven't heard of that. Halon, obviously, which they're not using in the States anymore. And carbone, I don't know what that is. Must be some hybrid of some kind. Anyway, and then when you pull that cable, this is the cable release right here, and that's of course what's releasing and shutting off the fire. I will grab the portable light to give us just a little bit more filming light. Okay, so this is that's our fire right here. This right here is the anti-siphon loop for the generator. Navigation inverter. So if the inverter is if this inverter is running, that's running all the navigation gear. This next inverter back over here is the service inverter, which means this is running. This is the inverter for everything else on the boat. There's a way on the panel that you can switch navigation and service back and forth if one inverter were to go down. We try to keep, that's one of the reasons that we spend so much, pay so much attention to all of the air that's going on inside of here, the air exchange, because what we don't want is to overheat these electronics right here. This is a charger right there. This is a 24-volt 100-amp charger, and then two more chargers. And what's this last one? That's yet another charger. So that gives us 1, 2, and those are probably 50 amps. I'm just guessing at that. So probably 300 amps of charge capability going on in that little pile up right there. We kind of keep our generator filters up here, and that is our generator oil or fuel filter. So just remember that one, WK811/86. Always good to have those numbers around. This is just a little rollaway toolbox that we put in. It's pretty solid in there. I don't think it's going to come flying out. To close it, kind of a funky little system here, but it was all just kind of a spur of the moment. just wiggle that back and forth. Close these guys. I'm sure if you went through the ultimate storm, this might come open. But remember, the drawers are pushing square, so they're pushing against these. I'm trying to come up with a little bit better of a system. It might be there by the time that you get there. Generator behind here, and generator oil check right there. So nice and easy to get to the generator oil check. Down here is an oil change pump, and that's the switch for the oil change pump right there. How cool is that? So what that means is that you can pump oil out of the gearbox, the engine, or the generator through that little pump system, and these two hoses right here. One of these is actually meant to suck and push oil back into the engine. I don't use that. I'm not too happy with that idea, because you know that hose is open most of the time. What if dirt and carborundum got in there, and then you stick it inside of an oil can and suck all that stuff back inside the engine? So in other words, I only use this to pump out, and I pour the oil in the regular oil fill places. Up on the wall right here is the oil change schematic, so you could always refer to that. And the other valves are up under here where my toes are pointed right there. One thing to note on this is that under the generator, there's a valve between this little manifold and the generator that has to be open. But there isn't one for the main engine, so the main engine could conceivably lose all of its oil because there's just this funky PVC pipe attached to the bottom of the engine. And so by now there may be a valve on there. That's kind of on my list, is to upgrade that. Don't know what these cables are for. I'd like to figure that out one day. They look like they're 24 volts. This is the original piping color code from the shipyard. So for example, if you look down at this pipe right here, and you saw green on that pipe, I've never actually never messed with this, but this is the flushing system for the water maker. If you saw green there, then you came up here, saw green, seawater, cooling. So that means that there's seawater running through that pipe. Okay, we come around to this side, and we're just about done in here. So thank you for holding attention the whole. Oh my goodness! Thank you for holding attention all the time, and sorry for shining a light in your eyes. Okay, this is the engine room lights right here. Don't know what that switch is, been wondering myself. This is the 220 outlet, and the 220 outlet, I keep a fan plugged in there, and then the trouble light. And this right here, I think, is another fan control, fan speed control. I think that's actually the fan speed control, and what's in the door that I was showing you at the beginning of part 2 in this video is the control for this little fan speed control. But I've never actually verified that. I've just kind of assumed that. This is a 24 volt outlet. If you ever needed 24 volts in here, you'll see these all over the place. That's just a little box. And when I got here, there were just all these power lines or electrical cords that were just hanging. I never knew what they were, but every time I come across one, I grab one of these boxes and screw it in the wall and put the power cord inside of the box. So there's probably 15 of those around right now that you'll see here and there, and more coming, because dead-ending a wire inside of an electrical box is much better than just a dangling wire. Okay, this is a 24, and this is a 220 to 110 transformer, and so this little transformer right here is what runs the fan. That fan up there, and so that fan is a 110 volt fan, so this feeds 220 in, 110 volts out, and so that's just another little circulating fan. Bilge pump on off that we already covered. These right here, we just put these in. This is just a cheap little way to store filters. So this is like, for example, those are the filters for the main engine, or for the main fuel filter for the engine. And what's in there? Those are, ooh, did you see that? That was all oil. Oh man, that was just horrible, wasn't it? Well, I bet you're just glad that you're watching a video and that's not actually on your feet and your hands. But if you're climbing in this engine room, you're going to get that stuff on your hands pretty regularly. Anyway, that's a set of filters that's, and that set of filters that's in there, now I just kind of remember what that was. That was, we heard that somebody was coming on board and they didn't want the they wanted to be very sure that the engine didn't shut down, so we changed all the filters. But we knew that the old filters, which are $80 a piece or 80 euros a piece, does that sound like a lot? Sounds like a lot to me. That those had to be, that I didn't want those to clog, and that was back when the fuel was still kind of messy. So I changed the fuel filters and kept the old ones in there. But normally this would be new fuel filters in here, and these are the fuel polishing filters. So these are just a convenient way to store fuel filters. And looking around here, I think that pretty well concludes the engine room. Oh, hey, one more thing I wanted to mention. You know how I was talking about how on this fuel system right here that you can set up to use the water system, and there's a little trap that kind of happens here. If you bend over and reach to that valve, that water valve, your face is kind of right over this little plastic glass strainer lid. And if you don't leave an outlet, like for example, if you closed everything on the manifold, or the clog, the hypothetical clog that we talked about happened to be so strong that we pressurized the manifold and there was no place for that pressure to go, this glass could blow out of there, because I've seen that flex at times and said, ooh, there's a lot of pressure there. So what that means is that when you open up that valve, maybe put something over this, or just keep an eye on it. Make sure that there's a way that the pressure is going to get out of that manifold. Just remember that. So a little safety tip right there. And I think that's about it. Everything else in here is just kind of storage, and well, hopefully you won't have to spend too much time in here. But I spend a lot of time in here. So if you're here too, then we're going to have a great time.
Deep cleaning.
Go.
Hello. This video right here is for Aphrodite crew. And the idea is to give you kind of an update, a way that you kind of can deal with emergencies and get how to deal with those emergencies into your mind by simply watching the video. And with any luck, this will save me a bunch of time, because I have to repeat this stuff over and over and over every time somebody new comes on board. So with any luck, you'll be able to watch this, and then when we have the discussion, we'll be able to make that time more productive, talking about specifics rather than the generalities. So what we're going to do, we're going to talk about the generalities of a couple basic emergencies that could happen on board and how to deal with them. The reason we're filming here in the galley is because a lot of the way that you would deal with these emergencies happens right here in the galley. And that's because right behind me is the engine room door, and right in here are the emergency shutoffs and the emergency pulls. And so we're going to discuss these, and we're going to discuss how to use these to your advantage. And hopefully, if things are done in the right order, if an emergency ever does take place, well, with any luck, we'll be able to take an emergency and prevent disaster. So the first emergency we're going to talk about is fire, engine room fire. So let's talk about a scenario. You walk down to do an engine room check. You're on watch. You do an engine room check. You open up the engine room door, and the engine room door is kind of a sealed place. Let's say that the engines aren't running, nothing's on, but you open up the door and you realize that the whole engine compartment is full of smoke. And immediately, as soon as you open the door, you're letting oxygen in, you're letting fresh air into the engine room, and kahoof! The engine room bursts into flames. One big flash fire. And so now the question is what do you do? What order do you do it in to give us the best chance of containing the fire? So if nothing was running, we can pretty well assume it's going to be an electrical fire. The other possibility that the other reason that a fire normally starts in the engine room is diesel leaked from one of the engines. Diesel or oil, like it could be maybe a turbo, but we don't have turbos. But a turbo oil feed line is a common reason, or an injection line broke and squirted raw diesel onto the hot exhaust. Either the hot exhaust manifold, we've got water-cooled manifold, so it wouldn't be that, but the hot exhaust riser. And the hot exhaust riser is a common place where fires start in engine rooms. So one of two reasons that a fire would start: either a oil or diesel line broke and sprayed oil or diesel onto a hot exhaust area, or the other possibility is that we have an electrical fire taking place. So one or the other. So let's in this scenario that we're talking about, we're going to say it's an electrical fire, but the situation, the way that we're going to contain the fire, is going to be the same. Okay, so the first thing that we're going to do, we're going to demonstrate how this might happen. This is our engine room door right here. You walk over, you open up the engine room door, smoke starts billowing out. At the same time, kahoof, and a big snot of flame comes blowing out the door. Okay, first thing that you would do is, of course, shut the door and turn the bolt. Okay, that's our first action right there. Now we've contained the fire inside the engine room. Now the next thing that we want to do is we want to break the chain reaction of fire. So we want to limit the amount of air. This right here is the engine room blower. We want to make sure that the engine room blower is off, pushing the top of the button, rotating the switch down. One other place that we have an engine room blower, we're going to walk out here, and we're going to go to the nav station. So now we're going to turn, and we're going to come around to the nav station. And right here we have air intake fan in the engine room. And you'll push that button and release it. Okay. So that's it. So 2 buttons. Hey, the bilge and the Lazarette.
That's on.
Okay. Yeah, I've been working on that Lazarette sensor for a while, and you were here for the success of the Lazarette build sensor. So that's something that now we've kind of bonded together. So now we've turned off the forced ventilation of air to the engine room in this scenario that the engine room is burning. Okay, so now we've changed the situation from an engine room fire that we're forcing air into to now the fire is slightly starved for air. Next thing that we're going to do, we're going to open this little compartment here, and we're going to reach in, and we're going to work our way down, and we're going to pull the diesel fuel, the main engine diesel fuel tabs, and the air dampeners. So we've got 2 air dampeners. Air dampener in, air dampener out. I'm not sure which one I'm grabbing because I'm kind of got my head out of the way there. And we've got tags being made up right now, by the way, that will give you a better labeling on this. So when you look in here, you'll see better labeling. Actually, those tabs should come back today. So it should all be done by the time that you get here. Okay, so now we've closed the air dampeners, and we've closed the fuel. So if it was fuel that was spraying on the the exhaust manifold, now at least we've limited the fuel going into the engine room. Next thing is turn off the engines. Be sure that the engines are off. Pushing stop on the generator right here. We'll turn off the generator, and going up into the cockpit area and pushing stop on the main engine. So now, if we have, because even when we pull the stops, even when we pull the valves for shutting off the diesel fuel to the engines, there's still 2 fuel filters that are that big. So we've got probably 4 more liters of diesel that the engine can still suck through the system if it was squirting diesel in that scenario. In the scenario that an injection line has cracked and is spraying raw diesel onto the hot riser, well, now we want to stop the action of the pump, of the injection pump spraying this diesel. Okay, so now we have the fire triangle, and we're breaking legs of the fire triangle. The first thing we did was we shut off the forced air vent. That's slowing down the amount of oxygen in the triangle of oxygen, fuel, and heat. The next thing that we're doing is we limit the amount of air going into the engine room by pulling the dampeners. Now we've shut the oxygen off. Now the fire can really only burn the amount of oxygen that's in the engine room. Now, that's kind of true. It's not really true because there's going to be places where air is getting into the engine room. And so now, the next thing that we do, we come over here with our little hammer, and we can break this glass right here. And behind there is one more pull. This pull releases this fire retardant chemical right here, which will spray out in the engine room. And with any luck, that'll put out the last of the fire. So now we've sprayed the chemical into the engine room. With any luck, we've put out the last of the fire. And now what do? We've limited the air. We've blown some chemical that should actually stop the combustion. And now we wait. We wait and we perimeter cool. Perimeter cool means that we get the fire system going, and we come around the engine room, and every wall of the engine room we spray water on. The cockpit, the walls, the front, the sides, we continually perimeter cool the engine room. Okay, so now what we've done is we've limited the amount of air going into the engine room. We've put a fire retardant over the fire, and lastly, now we're perimeter cooling. Last thing that we should do, first point or early on if we can, is also secure electricity to the engine room. And this is kind of tricky because that's back at the navigation panel, and there's a bunch of different steps depending on the situation. If the generator's running, if we're on shore power, if the engine's running, if we're on alternators, if we're only on batteries. So because of that, I'm going to do that part in person, and we'll go over that in person. Just remember that one of the things that we'll be doing is securing electricity. Just in case it's an electrical fire, we don't want those wires crossed and to continue to melt. So now we've limited the oxygen to the fire. We've removed as much of the oxygen. Now we're removing heat. We're perimeter cooling, which is removing more heat. And now we wait. We continue to perimeter cool. We continue to wait 12, 14 hours, as long as we have. The longer the better, until we can walk up and touch any side of the engine room and not feel any heat coming out of the engine room. And then after, sometimes you might wait 24 hours. It's because it's a last-ditch effort. If we open up that engine room and if that fire takes off again, well, we're down to hand fire extinguishers to try to put it out, and that means that we are inside the smoke of the and now all of a sudden we need self-contained breathing apparatus, and everything gets more and more complicated. And so because of that, we keep that engine room door closed. We keep the engine room closed, and with any luck, that fire will be put out, contained, put out, and smothered. So, just to recap, you open up the door, you see smoke, close the door, turn off the forced air ventilation, pull the air dampeners, shut off the generator, shut off the engines, pull the diesel fuel, secure power to the area, put out the alarm. I probably didn't mention that one. Fire, fire, fire. Let everybody else know. Get everybody else involved so that we're all making so we're all here on our fire station, and then perimeter cool and wait. And of course, I'm doing this all off the top of my head, so I wouldn't write this down and memorize these as the steps. This is just kind of the general thing, and when you get on board, we'll go over this a little bit more in detail. Now, the next possibility, one more thing, one more emergency that you might end up dealing with right from this area is flooding of the vessel. And this is another real possibility that we have a way of containing. So flooding of the vessel. Let's say we're going to come up with another scenario. You walk downstairs you come down the main hatch, down the stairs, and you look, and as the boat takes a roll, you see a floorboard pop up and water splash out. Let's say that we took a roll and you saw this floorboard pop up, water splash out, and then the door slams shut. Okay, well now all of a sudden we've got a clear indication that we have water in the bilge, water inside the boat. If that is going to happen, this isn't a particularly bad boat for that to happen in. It's a good place to be, actually, because this boat is broken up into 5 watertight sections with 3 watertight bulkheads and a watertight engine room. So what that means to us as the crew is that our way of dealing with the boat, if the boat's taking on water, our way of dealing with that is to close off the watertight bulkheads, try to pump each area of the flooded boat, and one area, of course, won't pump. We'll be pumping and moving water out, and water will be flooding in, and 3 or 4 areas would pump. So what that means is that now we know. Let's say the Lazarette, we pump the Lazarette, and the Lazarette keeps pumping, and water keeps coming out, and yet the level of the Lazarette isn't going down. What that means to us is that the Lazarette's flooded. The boat continues to float because we've still got 4 more watertight areas. Really 3 watertight areas, because the engine room isn't going to give us a whole lot of flotation. The engine room is watertight because it's got the heart of critical systems there. It's got our generator and our main engine. So if this area that we're in right now, the salon area, were flooded, the engine room conceivably could still be operated. And as long as we're pumping, the amount of water that would seep into the engine room probably wouldn't flood the main engines. So Now we go back to our scenario. We've realized that there's water in the boat. We close off all of our watertight bulkheads, which we're going to talk about how to do that in just 1 minute. And then we start pumping, and we try to find the area of the boat that won't pump down, keep the rest of the areas pumped down, and then we can move on to start to try to find the reason that that area has flooded, maybe a broken pipe, something like that. Now let's talk about a reverse scenario. You walk down the engine room, you walk down the main hatch, you come around to do that same engine room, and we open up this engine room door. Let's say we're just sailing, and we open up the engine room door, and water just starts spilling out of the engine room. Let's say that the water level it would probably be about here. That's water level outside. So water comes out, spills over our knees, and this is a possible scenario, and we have a plan to deal with this. So water comes spilling out of the engine room. So what do? Well, the first thing we do would probably be our natural reaction. We try to close the door. It may take a few seconds for the water level to equalize. Close the door, close the hatch, step back out here, take a breath. Okay, so the engine room has flooded. That means that something is going on. There's a broken pipe. There's something that has allowed seawater to enter the engine room. We come back to our section here. Of course, put out the alarm and call and get everybody else involved. And make sure I know, because I really want to know if the engine room has flooded. And you look in here, and there is a main engine water feed, there's a generator water feed, there's a water maker water feed, and there's a fridge water feed. And we pull all those, and what that does, that closes the valve right at the sea chest. That closes the valve, so water stops going to the engine, stops going to the generator, stops going to the fridge, and stops going to the water maker. And so what that means is that, let's say that just maybe this all happened because a hose popped off. Maybe just a hose popped off, or a plastic pipe broke that's downstream from the intake valve for, let's say, the water maker. So the water maker has a pipe that broke. And it's got seawater that circulates through the water maker, as does the air conditioner, as does the refrigeration system, and so then that pipe broke. It started to flood the boat, and all we really have to do is turn off that valve, and then the flooding has stopped. So that's our first attempt right there. Next thing to do is we start pumping again, and pump the water out, try to get the water out, and see if the water level went down. So inside of here we've got the air dampeners. We've got the fuel shutoffs all on these pulls. We've also got the through hulls to shut water to the through hulls in case we have flooding going through the vessel. One last thing in this area is this red box right here, and that's our fire pump on. And we're going to talk about how to run the fire pump in a separate video. So now we're going to talk about how to shut off our watertight bulkheads. So we've got a watertight bulkhead behind the main cabin. Behind the master cabin, there's a watertight bulkhead that separates the Lazarette from the rest of the vessel. That's already watertight for us. We don't have to think about that one. Okay, the next one is this door right here. Reach up to the top, release a little click, give the door a good slam. If you don't slam it enough, the handle won't turn. Turn the handle, and this right here becomes a watertight door. Below is a watertight bulkhead. This is all watertight along the side. So now what we've done is the main salon, from the bulkhead aft of the master cabin to this point, is now watertight. Watertight, probably more water resistant. But what really our definition of watertight is that the water is entering the other compartments at a rate that we can keep up with by pumping, and that's really all that we can hope for. There's a bunch of areas in here where water can come leaking through. There's wireways and passages, and every wireway gets spray foam put around it, and then somebody else puts another wire in by poking a rod through the foam and passes a wire, and they try to spray foam into that little area, and not everybody sprays the foam back in. And there's many reasons why water will continue to pass. And what that means to you is that once this door is closed, regardless of which side has the leak on it, you got to get to the other side and start digging around in the bilge and see where that water is leaking through. And then you got to contain that water. You got to keep that water on one side of the bulkhead at all times, so that we can keep our flotation. So we open up this watertight door, and we come up here through the dirty laundry into the very forward crew cabin. There's one more watertight bulkhead. That bulkhead is watertight. On the other side is a chain locker. Well, it's almost watertight. Really, what? Actually, I don't think anybody else has ever really realized this, because when we got here, we realized that the forward chain locker drains into a hose that drains into the bilge of the crew area. And so we are taking that hose, and we're going to take that hose and connect it, extend it, run it to a bilge pump, and at the same time run it so we can drain it into the crew area. So either the chain locker will drain into the crew area, or we can pump it overboard directly. So when you get here, we'll show you where that valve is. But what that means to you is that if the chain locker were flooding, or if the crew area were flooding, we've got to get to that valve and make sure that that valve is set so that the water that's in the bilge can't backfeed into the chain locker, or the water in the chain locker can't feed into the crew area. We want that water in the chain locker to be going direct to a bilge pump where it's being pumped overboard. So we've talked about two possible scenarios, two possible emergencies, and how we would deal with those. We talked about fire, and we talked about fire, mainly an engine room fire, and we talked about flooding. You might want to watch this one or two more times, think about it, so that by the time that you come on board, you're in a position where instead of having to talk about where the bulkheads are located, we can talk about things that are more productive. Thank you very much for watching. Okay, we're going to talk about the cockpit, taking control of the wheel and not taking control of the wheel, but just kind of being back here on watch. This is something that oftentimes when people come and crew on Aphrodite, this is one of the main things that we ask them to do, is to stand watch. To just stand out in the cockpit and watch for boats. And what that does is it frees up Allison and I to go along and do other projects. So we're still on board. If something happens, you just call us. And if a boat's coming along, you just give us a shout, and then we come up and make the passing arrangement with the other boat. But the rest of the time, then we can go along and today I was repairing, making upgrades and repairs to the dinghy while our crew was over doing the lookout. So that way I don't have to like sit there and work on the dinghy and do a lookout. So what I'm going to do is I'm going to give you the kind of the pre-brief of the cockpit. So this is the wheel, and of course it's a big impressive wheel and all stainless and leather grip, and the leather grip is because oftentimes you get a bunch of salt spray and the salt dries on the stainless, and you touch all that salt and it burns your hands. So we get the leather. It also keeps our hands from getting too cold on the stainless all the time. So that's kind of a neat little deal. This is our autopilot control head right here. And then I'm actually going to activate the autopilot. So the two buttons that you'll normally be using are standby and auto. So let's say that we're actually sailing along and we're on the course we want to go, and once everything's set, we push auto. Okay, so now the boat will follow this course. 159 degrees is what we're trying to follow, and we're actually doing 160 degrees. So now if I want to change course, I can take this little wheel and I can say, let's do a 170. And now that little chunk you hear is the wheel trying to follow the course. And the wheel and the computer right now, of course, will get confused because we're trying to go 170. We're doing a 163. It's got 3 degrees of rudder, and we're not really changing course. So the computer will be wondering what's going on. That's because we're at anchor while we're making this film. But if you were sailing along right now and you saw something ahead of you and you wanted to take control of the boat, you would simply press standby. You would press the S. The A over here changes to an S, and that means that now you've got control of the wheel. And once you're back on course, you're going the direction that you want to, your boat's stable, everything's right again, looking ahead, it's all clear, you can push A again, push auto, and now the boat's on autopilot again. So now I want you to watch the wheel, because the wheel is following the autopilot. And the hydraulic ram that steers this boat is about the size of your forearm, of my forearm. It's just massive. You know, normally you see like a linear drive that's driving a boat, and it might be the size of your thumb. And this one, this ram, it's that big around. It's just absolutely amazing. And so it's not going to stop turning for if somebody gets tangled up in the wheel. So I'm gonna make an adjustment. I want you to notice what the wheel does here. Okay, so that wheel right there is now turning, and it'll do this, especially if we're in a little bit of a seaway. So what does that mean to the person who's driving? Well, first of all, it means they don't want to get tangled up inside of this wheel. It means you wouldn't reach your hand through here. I'm actually going to push standby. We have an A. I'm going to push the standby, and now I have an S, which tells me I'm on standby. I can test to make sure that the autopilot has disconnected. Okay, so it means that you wouldn't reach your hand through here. You might have to reach through to push the engine start, for example, or adjust the bow thruster, or silence an alarm. All of that you'd be reaching your hand through here. How about getting down into this little zone right here? See where my arm is right now, trying to adjust the prop pitch. These right here adjust the variable pitch prop. Well, just imagine what would happen if that wheel took off. How about this one? If you're sailing along and you just start resting your foot right here. Just imagine if that wheel just slammed down on your foot right there. Oh, that would be just disastrous. And so because of that, we kind of treat this wheel and that autopilot with extreme caution. But of course, the guys who were designing the boat, they kind of thought about this because they knew what would happen. They knew that this wheel would be following. So they give us this little mini wheel. And so what happens is when this little mini wheel is turned to the right, tightened, the wheel is engaged. But then we turn the wheel counterclockwise to the end, back off just a little bit so it doesn't jam, and now the wheel is no longer engaged. See that? The wheel spins free. And so now if we activate the autopilot and change the direction, the wheel doesn't follow. Okay, I'm going to go back to standby. So that's a good thing. That means that now it's safe for the people back here. Oftentimes people can sit and just kind of lean up against this wheel when they're on watch and the wheel isn't following. But what does that mean if you have to take control of the boat? Because we just said to take control of the boat, you come over here and press standby. Well, now there's another step involved. The next step involved is you'll come over here, you'll turn this wheel clockwise. At some point you'll feel resistance. That particular time we didn't feel the resistance, but what happens is that this wheel engages with a couple teeth. And so the teeth normally come and hit head to head, and then so what will happen is you'll feel a spot right there where the teeth hit, and then you wiggle the wheel until the teeth are engaged. And then you can turn the small wheel the rest of the way and engage. And when you hit the end and the small wheel goes tight, back off just a little bit so the next guy comes over, he doesn't have to sit there and strain. You know, your hands get sore after like many days of sailing, and so these little things start to add up like that wheel kind of being jammed in there. Plus, it's easier on the gear to just be sitting there engaged but not cranked down. Okay, so now we're back to regular autopilot. Regular manual steering and autopilot in standby. Okay, so now we go back through the whole process again. We disconnect the wheel. I hit A for auto. I'm just going to imaginarily do it just so I don't make the autopilot work. Okay, so now the boat's sailing along. We run out of wind, so now we're going to start the engine. That's the next step. Okay, so we come over here and we push this left-hand button to start the engine. Okay, that engages the engine. It's just like turning on the key. Push the middle button and hold it for about a half a second. And that's it. The engine's running. Okay, I'm going to leave that run for just a second. And I'm going to push the right-hand button to turn off. Okay, so now let's say that you're sailing along and something happens, and now we want to take control of the boat and we want to use the engine. Okay, so now we've got another step involved right here. We're sailing along. The first step then is we say, oh, we're sailing along, and I don't know, somebody loses a hat overboard and we're sailing. So a person falls overboard. Any of these things where now we want to switch from sailing to the engine. And so we're on autopilot. The wheel's released. So now, of course, we have to come over, reach down, activate the left-hand button, hold the middle button for about a half a second to start the engine. Come over here, crank down the wheel, feel where the teeth engage, wiggle, engage the rest of the way, back off, push standby. Now we can come over and come to our single lever shifting, which is right under here. Give us a little bump in forward, and now we could drive away on the wheel. So it's starting to add up to some steps if we need to react quick. And you'll think we're just about there, right? No, one more step. Okay, so now one more thing that this boat has, because this is about as high of a tech of a sailboat as you could get in 1993 when it was built. Aphrodite was about the biggest sailboat ever built for a private yacht in 1993, 92 feet. And now we look at her and there's boats all over the place that are bigger than her. It's just amazing how technology and I guess financing have changed over the years. So one more thing that we have. We've got this little panel right here. This little panel controls the pitch of the prop. And so you can see this little gauge right here is telling us the pitch. And so if we're sailing along, I can add a little bit of pitch to the prop and make the prop a little bit more pitchy. Slow the engine down, get a little more grunt into the prop, and so everything quiets down. The engine gets less wear. We kind of go along on with less engine RPMs and holding maybe 8 to 9 knots. But now let's say that we want to sail. Well, I can take this and I can run this prop and I can pitch it all the way back. Notice how long this is taking, by the way. It takes about 20 seconds or so to go into feather mode, and that's what I'm going into right now. So if we were sailing, we would be in feather mode, and what that means is that the blades of the prop are parallel to the water. So now you'll see that gauge over there under pitch is at feathered. So now if we were sailing along and we had the same thing, something happened, somebody fell overboard, somebody lost a hat, for some reason we want to switch to the engine. And now we're on autopilot sailing. Not only do we have to roll in the sails, we've got the following steps. You'd come to the pitch and you'll release pitch. Notice the amount of time this takes. This is, well, I'm talking a fair amount of time right now, 10 seconds, 15 seconds, 20 seconds. This would be a long time if you were right now waiting for someone to bob their head up. It'd be a long time if you were in the water watching the boat go away and you weren't seeing any particular movement of the like the boat rounding up, coming to weather, or anything like that. Of course, we'll have a little procedure for that. We wouldn't just run over here and do the pitch first, but I'm showing you generally you'll come over here, run the pitch, start the engine, engage the little wheel, up to the autopilot, press standby, come over here to the gears, engage forward, and that's it. Now you'd be motoring along instead of sailing or instead of being on autopilot. A couple other things I want to show you in the cockpit. One of them is if indeed somebody were to ever actually get tangled up in the wheel. Let's say you heard a scream and you came running back to the cockpit and somebody hadn't followed these procedures. Their little wheel wasn't disconnected, for example, and they had reached through, and now their arm's tangled up in the wheel. Or maybe they're tangled up in the wheel and the autopilot just won't release. You push S and the button's not activating. Well, in such a case, we have emergency autopilot shut off. Just walk over, push the button. That's it. Right there, the autopilot shuts off, the bypass is activated, and now we have control of the boat manually again. So if everything else goes wrong, if somebody's tangled up in the wheel, we've got the big red button that shuts down the autopilot. If we look on the other side over here, here's another panel, and this panel has this big red button, and this is all of our winches and the anchor windlass simultaneously. And so if, for example, we had a runaway, now we'll talk about winches separate, but if you hear someone calling runaway, the winches are running away, what that means is that somebody pushed a button on a winch and released the button and the winch kept going. Or the anchor winch kept going, for example. And so under normal circumstances, what you would do is you would step back from the winch and call runaway, and then whoever is closest in the stern right here, they push that button. And that button, we really want to know where that is. And I ask people all the time, somebody gets tangled up in the wheel, what do you do? Winch runs away, what do you do? And so winch runs away, your answer is, I come and push this button. And I'll tell you, just recently we actually had, well, we've had a lot of winch runaways on all the different boats that I've been on. But just recently we had a winch runaway on board, and we had gone over this and over this and over this like so many times with the deckhand at the time, and then there it was, the winch runaway. And so we said, oh, the winch is running away. And he was like, oh yeah, the winch is running away. And we're like, no, go to the button. He was like, oh, the button. And so it's amazing how you practice these things all the time, and then when the real moment comes, how easy it is not to go and do what you've planned for. Okay, I think that's about it for the controls here. And of course, once you get on board, you'll figure these out even more. We always put these covers on at night if we can, except for our depth over there, because we want to know what the depth is by just stepping out into the cockpit. Okay, so that's about it for staying safe and the gear. Okay, we're going to talk about the entertainment system for a minute. The entertainment system. Those are the three remotes right there. TV, DVD, amplifier. Amplifier's down here. This guy right here. Use a left-hand knob to switch between Bluetooth, DVD, or PC. Volume over here. This one here is labeled outside. You can click the outside button. Then there is, right about there under that table cover, is a speaker button. You push that speaker button, turns on the outside speakers. There's another set of outside speakers in the aft cockpit. So as long as that right-hand switch is on, then you have access to the outside speakers. This right here, upper left-hand button, allows the TV to switch. TV itself, it's just regular TV. AV3 is a DVD player. HDMI 3 is high definition. And PC is the computer. And you can use a computer for a few kind of groovy things. You can put up the Max-C so that everybody else can see the Max-C on the big screen. You can use the PC, not audio, but just video. The audio comes when you're set on PC on the lower amplifier, and you'll notice that when you play the PC that there's kind of a buzz in the background, and that's because the headphone out to amplifier in cable, it isn't really grounded and it isn't shielded, and over through all that mess, under that cushion right there, is a cable that could have ends put on it. That's a shielded cable, so it's a high quality cable, and that would end that buzz. So that's about as far as we got in that project. To play a movie off of a hard drive, you come over here. Let's just let me just minimize that one. So I'll close this. So you'd come over here, you'd pick a movie, let's say this one here, whatever that is. It's some okay, once that double click on this guy, wait a minute, and the movie will come up and it'll play on the big screen. Also, you can use this for anything else that you want to play the computer on the big screen. Okay, in this case, we're probably getting ready to do a morning yoga, so I'm going to click from PC to a yoga class, and we're going to go do that. And one more thing, if you set the Bluetooth has that headphone jack, so you can either play into an iPod, or you can plug that headphone jack into a little built-in thing about that big that sits down in here and is powered up, and that allows you to connect through Bluetooth. And so, for example, here's an iPad. Doesn't go with the boat, but here's an iPad that could easily that could feed the Bluetooth, or off of somebody's phone. I think it comes up, it says Bilkin 1001. So if you can hook up to Bilkin 1001, you can play into the Bluetooth and run that audio through the boat sound system. I think that's about it. It's been quite simple. These speakers here were like 4,800 euros a pair, and when we opened them up, because they weren't sounding very good, we noticed that the outside ring, rubber ring, foam ring of the speaker was totally deteriorated. So we found new ones. They just sell those rings for about 12 euros each, and glued them on, and the sound system sounds remarkably better, much better. So at the moment, it's all high quality and working, and I hope it keeps working for you, because it's been quite a nice sound system. There is no boomer, no bass on the system, and I've kind of thought maybe under here, maybe it would be a place to put kind of a big floor thumping bass if you were into that. Other than that, that's about it for that system. Great sound system.
Okay, this is part of our safety training. I noticed last night it was pretty rough and nobody had one of these but me. So, I'm going to show you how to use them. This is our life preserver. It comes with a bell and a flashing strobe light. Sometimes that's automatic, sometimes you have to make it work yourself. We'll show that in a minute. However, let's just figure out how to put them on. Take it like so, whip it around like a vest, and there you go. If it's tight on you big guys, you gotta like work your straps over here, see that? Pink part. How are you doing, Elizabeth? Like a vest. That was unorthodox, but it worked. Okay, now, have we got them on? Don't touch anything.
Everybody but the camera person.
Wait for further orders. Okay, help him get his bigger, Elizabeth.
Keep talking loud.
Okay, so while Tad figures out how to open his.
Here, buddy. You gotta take it off. Then you gotta slip your arms here. Yeah.
See, oh, look at that. We don't have that. We have to use it. Okay, okay, don't touch that yet, Tad. Hands off. Now, okay, so you'll notice Scott's here has this beautiful little clip that we don't have. We have this. Put your thumbs underneath, like so. Thumbs up, underneath. Grab your key, hold, pinch them. Here, let go of that. Let go of that. Tap, tap. Drop that.
Wait, my
Tap.
thing.
Tap. Okay. Watch me. Okay, thumbs under. Boom. There we go. Not so far back. There. Now, bring it forward. Twist your right hand like your chest is gonna have a keyhole in it. Bring it right inside and turn it back up. Elizabeth got it. If it snaggles at the very end, just let go. It'll. Oh, more, Dad. Watch the key. The key got to go right into my chest.
My slot was inside.
Well, okay, let it go. If it snaggles at the end, don't try to force it.
I got it.
Just let go and it'll pop shut. There you go. That's how you put it on. That's important to figure it out now rather than when you're in the water. You know, like if Scott's driving and hits a barge. So, we're on the water. Now you know, thumbs under. Remember that, right? Same way taking it off. Thumbs, twist it, open. Okay, do that a couple times. Just get familiar with that. Key, like the keyholes in your chest, in your sternum, and you just same way to undo it. Yeah. Everybody happy with that? Your thumbs aren't up there, Chris. Thumbs underneath up. Look at. Even though you could do it, unorthodox. Thumbs like this. Look at my thumbs. Look at this. There. Now do it.
Putting on a dive belt. You want to do it the same way every time.
Okay. That's the most important part of this is to feel comfortable if you're in the dark in the water, to be able to grab it, flip it over your head, get those thumbs under like I did, and turn it on. Everything else is automatic, except how to make it blow up. Now I have this brand new one here. Well, your straps will do that. We'll tighten those up for Elizabeth. Yeah. So, thumbs under, goes every time. So, everyone has, this all snaps and stuff. Now there'll be a CO2 cartridge in all of these. Do not pull it because we're not ready for that. You'll ruin your chance. I'm going to do it just to show you how it works, okay?
Because he's been waiting
for days
to see what happens with this.
Okay, and then yours is inside this. You unbutton it and you'll find it. But your buttons aren't working very well, so I don't recommend it right now. We'll show you
The
later.
snaps are old, but it's inside the snaps. Trust that they are.
This is your lift handle will come out also. Elizabeth's is out, so is Chris's. That means this is where the Coast Guard is going to swoop down the helicopter, grab this, and pull you out of the water. Okay? Alright, that's what that's for.
Actually, it's probably, yours is tucked under right here, which is where the other ones would ideally
on the left
be,
side,
so you don't
Elizabeth?
get tangled up when you're using them at night.
She's got it.
Yeah, oh, okay. Now don't pull these. Don't pull these because the CO2 will go off and then we gotta, fuck it up. Probably won't work so well next time. But I'm gonna pull it if everybody's ready.
Okay. And that's why it got decommissioned.
So. That's why we make these films. All right.
That's why we have them checked out every once in a while.
However, I did get a little in. And I have some bells and whistles in here now, which are very readily.
We should. Okay, now we can cannibalize that one.
See? And now, since that didn't work, luckily, I have.
Is that on the push thing?
Unfortunately, you have a big hole in there.
Have a big hole there, buddy.
Oh,
You're dead.
well, I'm a pretty good swimmer. So, that is pretty much the safety lowdown on these life vests. Good luck if you need them.
Don't trust them. Don't trust
Okay,
them.
one more thing.
Don't go overboard.
One more thing. Now we'll have safety lines hooked up.
So how do I know which side my CO2 is on?
It should be on your right. Yeah.
But I should leave it tucked in?
Oh, did you find it? Familiarize yourself with it. But if you take it all apart, it's hard to put back
It
together.
is good to leave it tucked in so that it doesn't catch on something. Or see where you're adapting.
Well, actually, we'll have a safety line running the whole deck. And so we'll just clip these on here. One for the thing. And we'll have a run. We'll have a line running all the way both sides of the deck. Maybe one in the back too for the.
Now, isn't that upside down?
I don't know. I don't think so because you only have time to hook one and move.
I thought what the system was is that, okay, these come off. Okay, that one that's in your right hand clips on here.
Stuck on while you're.
Okay, now you've got two clips. So you clip onto something.
Boom, boom. Oh, so you always have something clipped.
Yeah, then if you're going to unclip to like cross an area.
Oh, you're still clipped. Okay, so it's like this. Oh, you took yours off already?
Yeah.
Oh, we aren't done yet.
Keep going.
Yeah. Okay. Right.
Yeah.
That's right.
So there'll be the jack lines on the deck, which are those white nylon lines.
Right. Thumbs up. And inside.
Into your chest.
Put your thumb in this way. Put your thumb. Okay. Now this goes into your chest. No, it's not going into your chest like this. How easy that is? That's right. Yeah. Okay. And so Scott pointed out now. Here's how this works. Watch. If you have a inflated kind. Okay, watch. Okay, we got two. The reason you have two is you're over here. You can hook one on. You're always hooked up this way. You crab along like that. Now you can take this one up and run around. Oh no, I got to do it again. So make sure you always have one clipped on, so that you're. We'll pick you up over there instead of behind the boat. All right. Any questions?
Where does it stay when it's not there?
I wrap it around the whole thing. It's always together with my life.
So if I'm just hanging out in the cockpit with this on,
There's in the back by the ship's wheel. There's a hook, a loop on either side of the cockpit. And so I just hooked mine onto there last night.
But I used to.
And how's that light turn on and
When I
off?
was wearing it.
Which light?
The light.
Oh, sorry. Okay, lights. Where's your?
I used to just
Hey,
wear
Tad.
that
We're not done
sometimes
yet.
with a tether in it,
Nice
so
try.
it's always there and tucked in or something. Right.
Okay, these have, and I can use on this one. When they do inflate the light, let me find that. There's two types of lights. This is salt activated, saltwater activated. This one you don't have to do anything with. It'll just start going boom, boom, boom. Okay, it's pretty bright. Now there's a blue one on.
so if we're in Lake Titicaca, it won't work?
Right, you have to pee on it.
Stupid question.
That'll be salt. See if I can find a blue one. No, it's yellow.
Mine's yellow. I already looked.
And we got blue one. Well, if you have a blue one, you twist it clockwise, it'll flash. You'll have plenty of time. Now, I don't know, it was pretty rough last night. Nobody had one on, but I think Scott and myself. I recommend, in fact, it's not even a recommendation, I think Scott's going to make it a mandate that you got to have those at night, and you got to wear them. It's just a safety thing. We don't want to lose anybody. We wouldn't have found anybody last night if we had turned around, so even with a strobe light. So we'll hear it from his mouth and then go from there. That's it. Top that.
See the fuck, Scott.